Hello and welcome to StudyIQ IAS English. I am your friend Rahul Saigaonker. Friends, how are you all? I hope that all of you are preparing up to the mark. All the aspirants are following their schedule. And as requested by all of you, we are here with another marathon for NCERT Science. In our latest discussion, we had completed 8-hour long marathon to complete NCERT Class 8 Science. Today, I'm here again with you for discussion of NCERT Science Class 9. We will be discussing this NCERT elaborately, where we'll be covering all the chapters one by one. Please remember, the NCERT syllabus has been rationalized during the COVID in 2020. It has been rationalized, but we are not dealing with the rationalized NCERT. This is the old NCERT before that. So there will be more chapters in this and we'll be covering them one by one. So enjoy the marathon. And again, if you have any queries, any doubts, or if you want to connect with me, you can connect on these avenues. This is my social media ID at the rate Rahul Sai 222. Instagram, you can follow me. You can directly message me. This is my number. You can contact me here as well. Do not call. You can drop a message on WhatsApp or Telegram. And this is my Telegram channel, Rahul Sai 222 UPSC, where I host interesting content for UPSC civil services aspirants. Do check it out and enjoy the marathon. Let's begin our session. All right, let's begin our discussion. As I told you, our discussion today is connected to matter. Now, from ancient times itself, people have been thinking about matter around us, right? People observing that something is solid shape, something is liquid, water is liquid, and there is gas around us. And we inhale that gas also, right? We inhale air, we use oxygen, we exhale air. That means we release out carbon dioxide from our body. So we have been thinking about all these matters. Why something is solid, something is liquid, something is gaseous? What is the universe made up of? To find out these answers, we have given some philosophical answers also from ancient and medieval times. The Indian philosophers, they believe that every matter or our body is basically made up of 5 elements, the Panchatatvas. What are those Panchatatvas? Agni, Jal, Vayu, Prithvi and Akash. That means air, earth, fire, sky and water. Sky or space you can use. So these were the 5 elements Indian philosophers spoke about. The Greek philosophers also had some kind of similar analogy. But as modern science progressed, modern science observationists, scientists, they started to do some experiments based on empirical data. They gave some properties of matter by studying their physical and chemical properties. But be it physical or chemical properties of any substance, they came to one conclusion. They came to a conclusion that every matter, it is composed of certain tiny particles. So when we talk about the physical, and in this discussion, we are going to talk about physical nature of the matter first, then slowly and steadily we'll talk about the chemical properties also. But physical nature of matter, when we study, we come to a conclusion that all the matter, whatever it is, be it a solid, liquid, gas, whatever matter it is composed of certain basic particles. And the most basic particle of that is an atom. So the answer to the question, what is matter? Matter is anything which is continuous, anything which is around us. It can be a solid, liquid or a gas. And that matter is composed of tiny particles called atoms, which we cannot see. They're very, very small. So this is the first pointer. Matter, anything around us, it is composed of atoms. The first pointer. And I told you, what are the characteristics? First is clear. And these tiny particles, as I told you, we cannot see them. They're called atoms. Atoms, more number of atoms, or when they combine, it leads to creation of element. These are pure substances, which we'll talk about in our next interaction. Atoms leads to elements. When different elements combine through their chemical properties, they can lead to creation of molecules. In fact, any of these can be considered as the tiny particles which comprise the matter. All right, molecules, when different molecules meet, then it leads to creation of different compounds. That's the basic idea we have already, right? So matter is made up of tiny particles. And what are the characteristics of these particles? It can be an atom, element, molecule. So what are the characteristics? The first characteristic is that these particles, they have space in between them. For example, when you talk about water, now water is the most abundant thing that is around us, right? Everywhere. If you look at the Mother Earth from the International Space Station, you'll see the color blue. Blue is because of water. Now water is made up of two different atoms. It is made up of two atoms of hydrogen and one atom of oxygen. And this matter or liquid, it has space in between them. The next property is particles are continuously moving. That means they have some sort of a kinetic energy with them. And the next property is particles continuously interact with each other. That means there is some sort of a connection between hydrogen and oxygen which is holding it together. So this is the basic characteristic or basic nature of any matter. I'm just not talking about water, but any other matter. For example, air, say nitrogen gas, oxygen gas, any liquid, carbon dioxide, water, or say wood, this substance, anything. It is made up of tiny particles, atoms, elements, molecules, and these molecules have space between them. They are continuously moving. That means there is some sort of kinetic energy with them, and they interact with each other. Let's try to get some proof regarding this. Right? First pointer, I said matter has space between them. How do I find it? As I cannot see it, but I can feel it. Right? I take small amount of water in a beaker. Say this is the level of the water. Right? This is H2O basically. Now what do? I add some amount of salt into it. Now what is this salt? This salt is sodium and chlorine, sodium chloride. Now I mix it. When I mix it, you will see that water and salt, they have become a mixture. And technically what should happen is the level of this water should rise, right? If they do not interact, if there is no space in water, then the water should rise. But you will see the water level is not going to rise because the salt is continuously dissolved. Now what is happening? The sodium and the chlorine atoms or these molecules, they are now in the spaces that are available between H2O. That is the basic understanding. So it proves this, yes, matter is made up of particles, and these particles have spaces and they're continuously in motion. How? Because they have kinetic energy. You must have seen a phenomenon like this. Now this is called as Brownian movement, right? You must have seen this. If there is a slit opening and there is sunlight passing through it, you will see the dust particles of very minute particles, they're continuously in motion. In a colloidal solution, we do find Brownian motion. Now why I'm telling this is because atoms or the matter itself, the atoms or molecules in the matter, they are constantly in motion. What kind of motion? It may be a vibratory motion, a translatory motion, oscillatory motion. It can be any kind of motion, right? Now remember, this motion can be increased or decreased by changing its parameters. For example, if I raise the temperature of this water, it starts boiling. Why? Because now the particles are moving with more energy. The kinetic energy is increased. All right, these are some of the basic ideas. Now apart from that, we do see that they interact somehow. They interact with each other and they're continuously in movement. How do I understand this? Now let's take example that particles which are moving continuously because they have some sort of kinetic energy. Add the kinetic energy. How? I increase the temperature of it. More and more faster movement of these particles is seen. And in a mixture, you do the same thing. That means in a mixture, what is happening is, say this is water. I take another example of a dye, say blue dye. I take a blue dye here, and water is colorless. There are water molecules, and then there are dye molecules. They interact. How do they interact? They interact through a process of diffusion. Now what is diffusion? You add a small drop of this blue dye, put it in water, do this experiment. You will see that the dye initially is here, but after some time the entire water is blue in color because there is some sort of equilibrium which has been achieved. How? Because the molecules have interacted. Water molecules and the dye molecules have interacted, and this process is called diffusion. Diffusion is basically a process where the molecules, they move from higher concentration to a lower concentration till an equilibrium is reached. You must have seen this phenomenon not just in liquids but anywhere. In liquids it is quite visible, but in gases it can be seen or it can be felt, not seen per se, felt. For instance, see, when I was in Bangalore, right, we never used to cook non-vegetarian food in our home, right? So it was a rented place. We never used to cook non-vegetarian food at home. So what used to happen was the neighbor auntie, whenever she cooked, especially on Sundays, she used to cook non-vegetarian food, and we used to get a feel of that food, right? Because as soon as that smell comes, they're like, okay, there is something brewing, right? Something is getting prepared, probably chicken biryani or mutton biryani, right? So why does this happen? It happens because of diffusion of gases. The smell comes very easily. For instance, the incense, right? You have incense or you have perfume. Why do you get that perfume feeling, right? You spray and the perfume slowly spreads. That is nothing but the process of diffusion itself. All right. Now, please remember, diffusion is a process which occurs in all the three states. It happens in the solids, it happens in the liquids, it happens in the gases. Now, gases, it can be felt very easily. I gave you many examples, right? The perfume example, the incense stick example, or the agarbatti stick example, or food that is cooked. Right? I gave example, real-time example, which we felt, right? We used to salivate, right? Chicken or mutton biryani is being prepared. Then we say we'll go out, we'll have some nice dinner tonight. Okay, that thing used to happen. So with gases, you get a feel of it. With liquids, you can actually watch it. You can conduct this experiment. For example, say every day in home when you're cleaning your floor, what do? You put Lysol, or the best example is you put Dettol, right? You put a small cup or a small cap of Dettol in the water, and you will see. First of all, you'll see the color also. The white color, the Dettol, it transforms into white color, and it slowly spreads into the water, and the entire water, it smells now of Dettol. Why? Because of diffusion. So diffusion occurs in gases and liquids, which is quite understandable, but it also occurs in solids. And remember, diffusion in solids is slowest. It is slowest. Why? You'll understand in some time. Diffusion is somewhere in between. Diffusion in liquids is faster compared to solids, but slower compared to gases. In gases, it is the fastest. Now question, sir, diffusion occurs in solids also. Can you explain? Let me think. For example, say in your schools, you must have seen board, right? You must have seen a blackboard, and on the blackboard, the teacher used to write. The teacher say, I've written slowest here. Imagine it's a blackboard and I'm writing slowest using a chalk. Slowest using a chalk. Now what happens if you erase this chalk quickly? Then the blackboard will be completely black. But imagine what you do. You write slowest, you write with a chalk on the blackboard, and you leave it just like that. After some time, after 1 or 2 days, 1 week, 2 weeks, 1 month, you will see that some of the chalk has actually diffused into the blackboard, and no matter how you try to clean the blackboard, it is never going to become completely black. So over a period of time, after using chalk and the board, you will see the color of the board slowly and steadily fades. Why? Because the chalk has now diffused into the solid. That's one of the examples. Or else you can simply think of two metals kept together, and there would be a joining. Give it time, 1 month, 2 month, 1 year. So the air gap between that completely dissipates, and then there might be some sort of a temporary joining between them. Right? That's an example. But do remember, diffusion occurs in all the three states. Right. Next is, what are the states? I told you already: solid, liquid, and gases. Now, solids are something in which the particles, whatever, atom, molecules, etc., they are very closely bound together. And that is why they are always in a definite shape. Whereas in case of a liquid, which is a state of matter, here the molecules are free to move because there is a lot of space in between these molecules. Please remember, I told you that be it any matter, there is always spaces between these particles. If you look at a solid also, there is always space between these particles. Why? Because the atoms and the molecules, they can vibrate. As soon as they give temperature, then you see heat is conducted, electricity is conducted. Why? Because they're able to vibrate, right? And in gaseous form or in a gas, the atoms or the molecules, they are very loosely held together and they are free to move. And that is why we get certain characteristics of these matters. If it is something of a solid, we do know solids are rigid and they have definite or a fixed shape. Now you might have a question. So you said solids are rigid. Most of the solids are rigid. For example, now when I talk about, say, a rubber, let me give you an example of rubber, right? A rubber, you have a currency note bundle and you put a rubber on it. Now that rubber is a solid material, but that is elastic, but it has definite shape. Yes, you stretch it, it will go back again to its shape. So solids are rigid meaning they have a definite shape, they have a definite volume, and they have higher density. And the molecules here are very closely held together. You can see the picture here that the molecules are held very closely together. Of course, there is some gap, but the molecules are held very closely. And the solids, they undergo very little compression. But when you talk about liquids, liquids are not rigid. They do not have any fixed shape. In fact, they take the shape of whatever object you put into it. For example, a glass of water. There is a bottle of water or a glass of water. If you pour water in a glass, it takes the shape of glass. If you pour water in the bottle, it takes the shape of the bottle. Right? So there's no definite shape. Yes, it has fixed volume, of course. Its density is lower compared to the solids, and it undergoes slight compression. In fact, liquids undergo very little compression. Solids and liquids, they undergo very little compression. But gas is something which is not rigid. It does not have any fixed shape. It does not have any fixed volume also. Its density is very, very low, and the particles are far away. From each other. That is why the movement or the diffusion is very, very fast. Add to it, it is highly compressible. You must have seen, you have a gas cylinder at your home. That gas cylinder is approximately 15 16 I think 15 kg of LPG pumped into a small area, right? So gas can be compressed. Solids, liquids, and gases, basic three forms of matter. All right, right. Again, the question now is, can one matter transform into another matter? Can solids transform into liquids? Can liquids transform into gases? The answer is yes. The most common example being water. Now water, when I lower the temperature, it becomes ice, it becomes solid. When I give it heat, it becomes liquid. When I give it more heat, it becomes a gas. So I can transform one form of matter into another form very easily. But how do I transform them? By giving some sort of input. And when I say some sort of input, it is always corresponding to the particles. Now if you try to understand, in a solid, the particles are very closely aligned. And of course, these particles, I told you, they have space in it and they move. In solids, they move very, very slowly. But now I give it heat, I give it temperature. What is going to happen? This is going to become liquid. And in liquid, the particles are also closely held together. Slowly and steadily, I give it more and more heat, and then finally it gets into the gaseous state. So one thing can be transformed into another. How? By effect of temperature. Now, as the temperature increases, as I increase the temperature, say something is a solid, I increase the temperature of a solid. What is going to happen? The kinetic energy to the particles is increasing. I am increasing more and more kinetic energy, and at one point of time, the interaction between, or the gap between these particles is going to increase more and more, because they are going to vibrate more from their original position. And what is going to happen? They are going to change state from solid to liquid. And when this happens, it is called as melting point of that matter, of that solid matter. A point or a minimum temperature at which a solid melts and becomes a liquid, it is called as melting point. And higher the melting point of a matter, that means it is the indication of the strength of force of attraction between the particles. Meaning, if I have to heat it more and more, that means the atoms of the particles are held very closely together. They are interacting through a very strong cohesive force or an attractive force, and I have to give more and more energy so that they become loose. So solid transforms into a liquid after I raise its temperature. After I raise its temperature to melting temperature, it becomes liquid state. And I keep on giving it temperature. I keep on giving it more and more energy. I keep on heating it. And at one point of time, it changes its state from liquid to gaseous state. And this is called as boiling temperature. Right? This is called as boiling temperature. This is called as melting temperature. All right, for water, we know that 0 degrees Celsius or 273 Kelvin basically is the melting point. Add 100 degrees Celsius to it, you will get the boiling point. All right. Now, there are some areas, or there are some points at which when a matter is being transformed from solid to liquid, from liquid to gas, the temperature of that matter remains the same, but it continuously takes in energy, and these are called as latent heats. For instance, if there is a solid, say imagine there is a solid ice, and from ice if something is transformed into liquid, at this temperature it becomes liquid, but it will remain at this temperature by absorbing some sort of heat without any raise in temperature. This is called as latent heat of fusion. Latent means hidden heat, means the heat is being captured by the solid body, but its temperature is not rising. But after that particular rise, after latent heat of fusion is added to it, temperature again rises, it reaches to liquid state, and when it is boiling at the evaporation stage, we also get latent heat of vaporization. So latent heat is basically that heat or amount of heat. Latent heat of fusion is amount of heat required by a solid substance to change its phase from solid to liquid phase at a constant temperature, and that constant temperature would be 0 degrees Celsius. The same thing applies, I'm giving example of water, the same thing applies for latent heat of vaporization. It is the amount of heat a liquid substance takes to turn itself into the gaseous phase at a constant temperature, and for water this would be 100 degrees Celsius. For different matters, these temperatures differ. For example, if you take oil, if you take any other thing, the temperature differs for all of these. And in chemistry, there is a denotation also. We denote latent heat of fusion by HF and this by HV. All right. And the heat that is given here, it basically corresponds to the melting point. Now, the temperature at which it takes heat continuously without raising its temperature, it's called melting point, and the same boiling point. All right. Latent heat of fusion and latent heat of vaporization. Clear? Right. Let's move on. Let's talk about effect of pressure. Now, I already understood that as I give temperature, as I heat a matter, it transforms from solid to liquid, liquid to gas. Can I do the same thing by changing its pressure? Can I do it by changing the pressure? The answer would be yes. In fact, in our real life applications, we use a combination of pressure and temperature to change the form of matter. For example, we have carbon dioxide. Have you heard of something called as dry ice? Dry ice, or simply your fire extinguisher. You must have seen fire extinguisher everywhere. In fire extinguisher, it is basically dry ice. And how is the dry ice made? The dry ice has been reduced from carbon dioxide directly to dry ice, solid dry ice. How? By applying pressure. That means you increase the pressure, you decrease the temperature, you create dry ice. So what do I understand from this? I understand that matter can be transformed from solid to liquid, liquid to gas, or from solid to gas or liquid to gas directly, or vice versa. And this process, if I transform from solid to liquid, it is called as the process of fusion. If I transform from liquid to solid, it is called solidification or freezing basically. If I transform from solid to gas directly by playing around with pressure and temperature, it is called as sublimation, solid to gas. And from gas to solid, it is called as deposition. So basically, when I transform carbon dioxide from gas, if I increase the pressure and reduce the temperature, it directly becomes dry ice, solid dry ice. And if a liquid is transformed into a gas, this is already known vaporization, and a liquid transforming and a gas transforming into liquid, it is called as condensation. So please keep a track of these terms, very important. Sometimes, although very simple topic, but silly mistakes can occur. Please try to focus on these, that matter can be transformed from one form to another form. If I ask a question, solids can only be transformed to liquid by adding temperature, right? There is no need. Solids can directly be transformed into gas, solids can be transformed into liquids, liquid can be transformed into solids, liquid can be transformed into gas, and gas to liquid. Everything is possible by playing around with pressure and temperature. All right, you need to understand this very important concept, right? So matter can be transformed from one form to another form very easily. Now, many a times in our day-to-day activities, day-to-day life, we do see that without any sort of heating, I'm not boiling anything, but evaporation is occurring. You must have seen this in your day-to-day activities. You wash your clothes and you keep them to dry. you know that there is a constant day temperature. Say for example, day temperature is around 30 degrees Celsius. 30 degrees Celsius. And at 30 degrees Celsius only, the clothes are drying. How is this happening? I am not boiling. I am not increasing the temperature. But at a constant temperature, these clothes are slowly and steadily, they are losing moisture. How? In form of vapor itself. Now, this process is called as evaporation. Remember, evaporation. Evaporation is a phenomena of changing of a liquid into vapor at a temperature which is below its boiling temperature. Clear? So, evaporation is a process where I transform a liquid, dry clothes, it has water, liquid in it. It is transformed directly into vapors at temperature which is way below its boiling temperature, around 30 degrees Celsius. But how is this occurring? How is this happening? How is this happening? Again, the reason behind this is the same. The particles of the matter, I told you, they continuously keep on moving and they are never at rest. At any given temperature, in any gas, liquid or solid, the particles are at different amounts of kinetic energy. And because of this kinetic energy, continuously, you will see that even at 30 degrees Celsius, slowly and steadily, the particles of liquid, they get converted into vapor and they evaporate. Is it proved now that particles are constantly in motion, be it whatever temperature? And that is why we see drying of clothes very easily. And this process of evaporation, it basically depends on certain factors. You can see, as I told you, evaporation is connected to this. The particles are continuously moving. And evaporation is a process which occurs mainly because of loss of thermodynamics, meaning heat is always transferred from a hotter body to a colder body. And that is what is happening. In Mother Earth, we see there is a heat budget. The heat deficit regions, they receive heat from heat surplus regions, and that is why evaporation occurs. And it depends on multiple factors. The evaporation rate, it depends on temperature. Meaning, on a sunny day, you will see the clothes will dry very fast. That means if the temperature is high, then the evaporation is high. If the temperature is low, the evaporation rate is low. Correct? Means it depends on temperature. Second, it also depends on surface area. Meaning, if there is high surface area, the evaporation would be higher. Meaning, more kinetic energy is lost, and basically the liquid molecules are turned into vapor very easily. And lower the surface area, lower is the evaporation. You must have seen this. For instance, if I wash this cloth, say if I wash this shirt, and I simply put, after putting it in water, without wringing it and without doing anything, I simply throw it somewhere. Will it dry faster? It will not dry. Then the best thing would be to basically broaden this shirt or widen this shirt and then put it for drying. It will dry very easily. Correct? Yes. That means surface area is increasing. You must have seen this also when you're having your tea. When you have your tea, what happens? Your parents or grandparents, they used to put tea in a saucer. What is the difference between cup and a saucer? The cup has low surface area. As soon as you put it in the saucer, the surface area or exposure to atmosphere is more, and that is why it cools very fast, right? So surface area. And it also depends on humidity. This is quite understandable. Simple. If the relative humidity is very high, the evaporation rate would be very low. And if the relative humidity is dry, that means the air does not have moisture, then more and more evaporation can be seen. Apart from that, wind speed. If there is wind speed, higher wind speed means higher evaporation. Lower wind speed means lower evaporation. So these are the four factors on which evaporation depends. Apart from this, evaporation has a very important effect of cooling. Whenever we see evaporation, there is cooling of the surrounding. Why? Again, the explanation can be understood by understanding that the matter moves continuously. Whenever there is evaporation, natural cooling occurs. The basic concept here is the matter is changing state. Matter is changing state. Now, when a matter changes state, I told matter changes from solid to liquid, liquid to gas. Now, when there is a change of this state, it is absorbing energy. Meaning, when there is a change of state, solid is gaining more and more energy, and it is becoming liquid to gas, or vice versa. It can, if you go in the reverse order, it must either receive energy or lose energy. And the molecules, they basically shift phase from liquid to gas, meaning they require higher energy to overcome their potential energy and turn it into kinetic energy. What happens as a result of this? The liquid, it absorbs the energy from the surroundings. The liquid, when the liquid is transforming into the gas, it needs more energy. Where is that energy coming from? That energy is coming from the surroundings, and that is why the surroundings get cooled. So whenever there is evaporation, then evaporation leads to cooling of these surroundings. Why? Because the excess energy that is needed for this evaporation, it is taken from these surroundings, and these surroundings, they lose energy. That's why there is some sort of cooling effect. And we have seen so many applications of this. You must have used cooler. It's a summer season now. You must have used cooler. The cooler basically runs on the same principle. The cooler runs on evaporation and cooling effect itself. The desert cooler, you must have seen that it cools better on a hot and dry day. Why? Because the evaporation principle is working. I told you it depends on your humidity. If it is a dry day, relative humidity is low. It is hot day. What happens is it is taking heat from the surroundings, and the surroundings are cooled. Right? Same phenomenon for touch and spirit. Now, for example, when I apply the deodorant, or when I simply take acetone on my hand, the acetone vaporizes and I get the cooling effect. My hand feels cool. Why? Because the energy is taken from there itself and my hand is cooled. The same applies for working of earthen pot. You must have seen your matka or earthen pot, it cools your water. How does it cool? How does it cool? Because the water is evaporating, and the water is evaporating slowly and steadily from the surroundings. Heat is taken up, the surroundings are cooled, and when the surroundings are cooled, then the water inside the earthen pot, it also cools. Right? Same is for cooling of your homes, cooling of a body. For example, now I'm sweating. Now there is sweat here. Now whenever I sweat, what is the reason behind this sweating? Reason behind sweating is again the same concept of evaporation. The liquid transformed into gas, and whenever there is wind, then I get that cooling effect. Why? Because evaporation has cooling effect. It tries to maintain my body temperature constant. Same for temperature of tea. You must have seen temperature of tea, again cooling effect. Because of cooling effect, the tea gets cooled and you can have it easily in a saucer. So many examples you get in your day-to-day life, right? So this is about matter, solids, liquid, gases. One form of matter can be transformed into another form of matter, evaporation and its applications. Let us end the discussion by some very interesting snippets. The NCERT talks about some other states of matter. From our school days, we have been taught there are 3 states of matter. There is solid, liquid, gas. But today, we can talk about 5 states of matter. Apart from the solid state, the liquid state and gaseous state, there is something called as plasma state. Now this plasma state is basically ionized gas state. It consists of super energetic and super excited particles, which are gaseous ions. The gas, it gets ionized and it gets charged, and this gas, you must have seen, we use the fluorescent tube lights, we use other lamps, etc. There you must have seen use of plasma in it, right? If you blast the tubelet that we used to get before fluorescent tubes, it used to have gas in it, and that gas would get into plasma state to give you light, better bright light. So plasma is one of the states. In fact, plasma state can be seen in your sun, right? That is why we are facing a lot of difficulties. You can connect this particular discussion with your thermonuclear fusion reaction. Thermonuclear fusion reaction is being run in the ITER, International Thermonuclear Experimental Reactor, where the plasma confinement has become a big challenge, and for that they are using a process called as tokamak. You must have heard about it. If you have not heard, do follow current affairs to know about that. To confine that plasma in a space, tokamak has been created. A toroidal shape or a donut shaped magnetic confinement method is being used, right? Lightning also creates this. Whenever there is lightning, in and around the lightning, the gas molecules, they are ionized, and plasma state can be seen whenever lightning occurs. But there is also another fifth state of matter which is called as Bose-Einstein condensate. It is mostly experimental, but we have already proved a fifth state of matter called as Bose-Einstein condensate. It exists. Indian physicist Satyendranath Bose, SN Bose, he had done a lot of calculation regarding the fifth state of matter, and his work was further built up by Albert Einstein, and that is why this fifth state of matter is called as Bose-Einstein condensate, and it was eventually proved in 2001, and scientists received Nobel Prize in 2001. Eric Cornell, Wolfgang Ketterl, and Carl E. Weinman, they received the Nobel Prize for proving that Bose-Einstein condensate, it exists. It was formed by cooling a gas at extremely low density, about 100,000ths of the density of normal air. Then you get Bose-Einstein condensate. Again, I would say plasma and Bose-Einstein condensate are more and more relevant from experimental point of view. But in our day-to-day lives, we do watch solid, liquids, and gases. Sometimes during the lightning, etc. Yes, plasma state is seen, but again, you cannot feel that per se. Right? Solid, liquid, gases are something which you can feel very easily. But in general, remember, solid, liquids, gases, plasma, and Bose-Einstein condensate. These are the 5 states of matter that are there. Clear? Right. This is the end of our discussion of the first chapter. In fact, from 9th standard, you will find that a lot of technicalities also come in your syllabus, and based on judgment, some of the details can be omitted which are not very important for UPSC civil services perspective. I would be eliminating probably some of the chapters or some of the content from it which are highly technical, maybe not required for us, but all this information is very, very relevant as of now. Right? That's the completion of chapter 1. I'll see you again in the next chapter. Thank you. Is matter around us pure? Right? Now, every day we come across so many items that we use. For instance, every day we consume milk, right? We buy a carton of milk or we buy a packet of milk like this, and on which you will see pure milk written. We have seen ghee, pure ghee, salt, refined iodized salt. The question is this pure term a misnomer? What is the meaning of pure milk? Is milk a pure substance? That is what we are going to understand in this particular interaction. We are going to categorize matter into pure substances and mixtures. The agenda for today's discussion is basically this. It's the conclusion. Matter basically is divided into 2 categories: pure substances. Pure substances are elements and compounds. And matter is also categorized as a mixture. I would say a mixture of pure substances or impure substances, because they are a mixture of these substances, and eventually they are also categorized as heterogeneous and homogeneous mixtures. So if you look at this particular slide, you will understand that ghee is a mixture of many pure substances, many elements and compounds. Milk itself is a mixture of what? It's a mixture of so many elements and compounds. Milk has calcium, iron, magnesium, whatever. Milk is considered as complete food. Whatever elements that are necessary for a human body, you can find almost all of them in milk. That's why we call milk as a complete food. So milk is a mixture. Before we move on towards element and compounds, let's first talk about mixture, because these are the things we encounter every day in our life. Every day we encounter with so many mixtures, right? You have a cold drink, it is a mixture. You have tea, it is a mixture. You have any sort of food, that is also a mixture. You have many colloidal solutions that you use every day in your life. So let's try to understand mixtures first. And under mixtures, we'll talk about different kind of solutions also. First of all, mixture. What is a mixture? Mixture is a combination of 2 or more pure substances. A mixture can be homogeneous mixture or heterogeneous mixture. A homogeneous mixture means the particles or the pure substances that we use, they are distributed uniformly throughout. For example, air. Now, air is a mixture of different elements. We have already discussed the composition of air in class 6 and class 7. I told you air has nitrogen, air has oxygen in it, air has carbon dioxide in it, air has methane in it, air has so many other constituents. And if you see, it is a homogeneous mixture because particles are quite evenly distributed. A homogeneous mixture can also be composed of metals. We'll talk about that in some time. Apart from that, there is heterogeneous mixture. Heterogeneous mixture means the particles or the pure substances, they are distributed non-uniformly. For example, you take a drink, add ice to it. Now you will see, of course, over a period of time, it turns into a homogeneous mixture, but till the time ice is present, it is a heterogeneous mixture. Our blood is a heterogeneous mixture, right? Our blood has water, our blood has different kinds of protein, it has hemoglobin, it has different hormones. It's a heterogeneous mixture where the particles are non-uniformly distributed. And please try to understand, when I discuss about a mixture, the basic kind of idea that we see around us is a concept of solution. A solution is a homogeneous mixture. That means the particles are uniformly distributed throughout this mixture. A solution consists of two things. A solution consists of a solvent and a solute. The solute, when added into solvent, it completely dissolves. For example, take water and take salt, NaCl. We discussed that yesterday also, and we said that particles have spaces in between that. I told you, if you take water, if you add salt to it, you mix it, you stir it very well, then you cannot see any salt particles. Why? The salt has completely dissolved in water. And you also see that the water level has not increased. That means it's a homogeneous mixture where NaCl has been uniformly distributed in water. So solution is a homogeneous mixture. And please remember, a solution can be either a solid, it can also be a liquid, it can be a gas. A very important pointer from exam perspective. Now, what is a solid solution? Let's talk about some of these ideas. All right. Now, please understand, when a metal, a solid, is mixed with another metal, another solid, you get a solid solution. Again, the ultimate product is also solid, which we call as alloy. So alloy is basically a solution of solid and solid. A solid can also be mixed with liquid and you get a liquid solution. A classic example, salt being mixed with water. It can also be liquid. For example, a liquid can be mixed with liquid. Every day we encounter this also, isn't it? A liquid can be mixed with liquid, right? We do that. Especially, I gave the example here of vodka, right? Vodka. A vodka, it's mixed with juice, or it can be mixed with any sort of cold drink. A liquid is mixed with liquid, forming a homogeneous mixture. Liquid and liquid can also lead to heterogeneous mixture. Now, this is, say, if you create a mixture of water and oil, take coconut oil, mix both of them. Will they mix completely? No. It's a heterogeneous mixture. You can separate them very easily. So solid, 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 liquid, you can get a solution. Liquid, liquid, a solution. Liquid and liquid heterogeneous solution can also be found. Again, gases, when you mix gas and gas, you get a gas solution. This is a homogeneous solution. When you mix gas and a liquid, again, you get a liquid solution. This would be homogeneous. A classic example of this are your cold drinks that you have. Cold drinks have water and carbon dioxide in it. They are carbonated water, basically. That means they are a liquid solution. So a homogeneous mixture is one in which you do not see the particles of solute, and the particles are so small that they cannot be seen with your naked eye. That means the particles are as small as 1 nanometer. Since they are extremely small in a homogeneous mixture, if I pass light through that solution, it is not going to scatter. The light is not scattered. Please remember, light is not scattered through a homogeneous mixture. The solute particles cannot be separated by simple filtration. This is quite understandable. You take a filter, you take a filter paper or normal filter that you have, a sieve that you have, and pass the solution through it. And you'll remember, homogeneous mixtures cannot be separated directly through your filtration method. Some other special method has to be used. We'll talk about that in some time. So is it clear? Homogeneous mixture, different kinds. Please remember, homogeneous mixture can be a solid, can be a liquid, can be a gas. All the three are possible. These are the characteristics of a homogeneous solution, homogeneous mixture. Now, apart from this, we talk about a solution where we keep on adding the solute. I told you a solution is solvent plus solute. Now, when you keep on adding, for example, let's take example here that we spoke about, water and salt. Let's do an experiment of taking water and keep on adding salt to it. Add 1 spoon of salt, dissolve, the salt will dissolve, you'll find a solution, a homogeneous solution. take one more spoon of salt, again add, and again stir it. Probably the salt will dissolve again. Yes, right? At one particular temperature, say a room temperature around 25 degrees Celsius, if you're conducting this experiment, you will see that you keep on adding salt, the salt is going to get dissolved, but till one point. After that particular point, you will see you keep on adding salt, the salt will not get dissolved. So at that particular temperature, when the solution, it will not accept any more solute. It is called as saturated solution. It is called as saturated solution. Till that time, it is unsaturated, meaning it can accept more solute. An unsaturated solution is one which can accept more solute at a given particular temperature. But as soon as it is saturated, you keep on adding your salt, it is not going to dissolve, because now the solution has become saturated. And that concentration of solute is called the saturated concentration of the solution. And I told you about temperature. Why did I tell you about this? Because if you increase this temperature, say if you increase from 25 to 30 degrees Celsius, you will see probably you can add one more spoon of salt in it. Increase the temperature furthermore, you can add one more spoon of salt. That means as the temperature increases, the solubility also increases. All right. And that is how we find out concentration. To find out concentration of a solution, there are three methods. How much at one particular given temperature, what would be the concentration of solution? The mass of solute that I add divided by mass of solution into 100. This is the mass percentage of solution. You can also find out by volume, by mass by volume percentage, or simple volume percentage also. Again, not very relevant from UPSC civil services perspective, but a lot of numericals do come from this in your other competitive examinations, say like NEET, JEE, etc. You might get some questions regarding this, but not very relevant. But I wanted to tell you about the concentration of solution and mainly about the meaning of a saturated solution, solubility, and unsaturated solution. I hope it's clear. All right. Right. Let's move on. Now, the next question. We understood a solution, solvent plus solute is equal to solution. We understood different combinations of solution. We understood concentration of solution, but there are some other solutions. This is the homogeneous solution or homogeneous mixture that we found out, where the particles or the solute particles, they are extremely small. They are in the range of nanometers, less than 1 nanometers. All right. There are some other solutions like colloidal solution and suspension. Suspension is something that you see almost every day. Right? Have you observed, if it rains, there is mud. What is that mud? That mud is nothing but a suspended solution. It has water and it has impurities of mud. But a colloidal solution is something which we use often, right? For example, milk. Milk is actually a colloidal solution. All right. So a colloidal solution is one in which the size of the particle, it differs. It is slightly higher than 1 nanometer. Basically, I can say it comes in the range of micrometers, and this would be higher, around 10 to the power of minus 4 centimeters, a common suspended solution. All right. So it basically, the difference between solution, colloidal solution, and suspension, it depends on the particle size which is there in the solution. In a solution, it is less than 1 nanometer. In a colloidal solution, it is approximately 1 to 100 nanometer. It can be a little more than this also, almost towards the micrometer size. In a suspension, it is higher than 100 nanometers. And when you look at the appearance of the solution, a homogeneous true solution, it looks very clear. It looks very clear. But a colloidal solution, it appears a little cloudy, or it appears a little patchy. All right. It's a little cloudy. The same with suspension. Suspension example is mud. But there is one difference. In a true solution, if you filter it, you cannot separate the particles. That means the particles are now ingrained in the solution itself, in the gaps between the particles of the solvent. But in a colloidal solution, remember, they also do not separate. They also pass through a filter paper. But remember, they are as if suspended itself. In a colloidal solution, you can see it's a little muddy, but fine particles, although you cannot see, but they are more or less uniformly distributed itself. What happens is, in a colloidal solution, they are more like the particles in a colloidal solution are more like free of gravity. The gravity would not impact on it, meaning the solvent, the solute or the particles, they are not going to settle down in a colloidal solution. But in a suspension, they always settle down. That means if they settle down, I can simply filter that out. So examples can be many. A true solution, I would say water and salt solution. Example, a salt solution. Take a colloidal solution. The example here is mayonnaise, but the simplest example I would say is milk. Then there is suspension, which is nothing but muddy water, which can be filtered out. All right, simple. Remember, a colloidal solution as well as a true solution, you cannot filter them out by a simple filter paper, but a suspension can be filtered out. That means solute can be separated out. Apart from this, there is one more method through which we can distinguish between a solution, a colloid, and a suspension. That is the Tyndall effect. The Tyndall effect. When you pass a beam of light through these three solutions, that means flashlight, use a flashlight, try to conduct this experiment, you will understand that in a true solution, you cannot see any sort of light. But in a colloidal solution, you will see a beam of light which appears. Why? Because the particles in the colloidal solution are in such a range that they are going to scatter light, and the same applies even for suspension. And in fact, in a suspension, light is scattered the most. You must have seen Tyndall effect almost every year. For instance, have you been to a forest? And in the forest, if you have observed the mornings or the evenings, even afternoons, light passes through these small splits or small distances, gaps between the leaves of a tree, and you observe light scattering something like this. Why? Because the slit or the opening, because of the leaves, it is almost in the range where it is able to scatter the light. You must have seen Tyndall effect there as well. All right. So you can distinguish solution, a colloid, and a suspension using this. That's where the characteristics come. We already discussed characteristics of a solution. But when we talk about colloid and a suspension, both of these are not homogeneous mixture. They are heterogeneous mixture. Please remember, suspension and colloid both are heterogeneous mixture. The size of the particles, it differs. Size of the particles in a colloid, they are not visible to the naked eye, but many a times in suspension, you can see them through your naked eye. That means, say, example is mud solution. In a mud solution, you can see the mud, isn't it? Apart from that, this shows Tyndall effect. This also shows Tyndall effect. But the biggest difference is in a colloidal solution, as I told you, the particles more or less, they do not settle down. They do not settle down. So colloid is quite stable. There might be even Brownian movement in a colloid, but you do not see the same thing in a suspension. In a suspension, the solute slowly and steadily settles down, and I can filter it out very easily. Now, how do I filter out a colloidal solution? I can filter out a colloidal solution by using centrifugation method. We'll talk about that in some time. It cannot be done through filtration, but it can be done through a process called as centrifugation. We'll understand that in some time. All right. Now, apart from that, colloids are extensively used in our day-to-day lives, right? A colloid can be a mixture of liquid gas, solid gas, gas, liquid, any kind of combination. There are many examples of colloids that are given here. A liquid and a gas, it constitutes aerosol. A solid and a gas, it also constitutes aerosol. Now, aerosol is something that we find almost every day in terms of fog, cloud, smoke, automobile exhaust, etc. A gas and a liquid is foam. We use it. A gas and a liquid, the shaving foam, right? A liquid emulsion, this is a kind of a paint, milk, or a face cream, etc. Solid and liquid is sol. Gas and solid, it is foam. So remember, gas liquid and gas solid both lead to creation of different kinds of foams that we use. A liquid and solid, it gives you gel. Then solid and solid, it gives you solid sol, gemstone, or milky glass. And most of the industrial aerosols, or most of the industrial colloids that we use, mostly aerosols, they contain a lot of chlorofluorocarbons. You must have seen, right? Especially industrial aerosols that we use as fire retardant, or say in your dry cleaning industry, we use a lot of aerosols. They do contain chlorofluorocarbons also. All right, clear? So colloidal solution, colloid example. Now the next question is, sir, I understood a homogeneous mixture, I understood heterogeneous mixture, I understood solution, colloid, and a suspension. Now, what I want to understand is I want to filter things out, be it a homogeneous mixture or a heterogeneous mixture. I want to learn how to separate solute and solvent. Many a times we require solute, many a times we require solvent, whatever it is. I want to simply understand the method of separation. One of the simplest method of separation is the filtration method. We use it almost every day. Have you prepared tea? Have you had tea today? When you make your tea, you take water, you take milk, you take tea powder, you mix them. A mixture is created. That is the tea, which tastes decently if you're prepared very well by adding optimum amount of sugar, right? Then you filter it out. When you filter it out, the solute, that means the tea powder, is extracted out. A simple filtration method. And it is not just for separating, say, liquid and a solid. Even a gas and a solid can also be separated by filtration. Simply take a filter paper and pass a gas and a solid mixture through it. The solid will be coming out. For example, you have your air filters in your bikes, in your cars, you have air filters. Why? Because for burning or for internal combustion, air is sucked by the engine, and that air has to be filtered out continuously because it has a lot of particulate matters and impurities that will be filtered out through the air filter, right? So a simple method is filtration. The next method, how do I separate a mixture of say a solid and a liquid by some other method? If I'm not able to use filtration, how can I separate them? Example is, how can we obtain colored component dye from blue or black ink? Now you already know the dye. What is it? It's a mixture of some kind of color, and for that color you have added some sort of solute. Probably you have added some solvent, water, right? You must have seen this. Simply add blue color into water, it becomes blue color ink. Blue color, you add blue color dye, it becomes blue color ink. Now how do you separate it? You separate it by a method of evaporation. Now when does it work? Evaporation method works when there is a difference in terms of the boiling temperature. Now we find that a mixture of ink is a mixture of basically dye and water, and we can separate the volatile component, that is solvent, from a non-volatile solute. What you do is you simply boil stuff. When you boil stuff, the water or whatever solvent it is, it goes off as vapor and you'll be left out with the dye. That's another method of separation or filtration. I would say method of separation. Let's talk about some other things. I told you, or I discussed about colloid, right? How do you separate a colloid? The question is, how can we separate cream from milk? I tried the method of filtration, it's tough. I tried the method of evaporation, but now what happens is, with evaporation, a lot of other stuff is also going off. But I want to separate certain stuff out. How can I do it? I can do it by a method called as centrifugation. Centrifugation is a method where a mixture, a heterogeneous mixture, is rotated very fast in some sort of a container, and because of that rotation, what happens is matter is segregated on the basis of their densities. That is how you separate cream from your milk. Now you're thinking, sir, I don't have a centrifugal machine at my home, right? What my grandmother used to do is she simply used to take milk and then she used to perform this kind of action, right? This kind of action, taking an equipment, right, which is a stirrer. Now when she stirs it, what is she doing? She's trying to continuously create some sort of a centrifugal force in that fluid, because of which you will see the cream comes out. You can get cream, you can get butter, many other things. All right. Do you have a centrifugal machine now? In your home, you might have a mixer or a grinder. What is that? It is nothing but a kind of centrifugation machine where you rapidly rotate a mixture so that based on the densities, things can be separated. In fact, at the industrial level, a suspension or colloidal solution can be separated by using centrifugation at different speeds. At different speeds, different pellets or different stuff can be taken out. All right, right. This is another method. Now let's talk about some other methods of separation. I have two liquids. Say accidentally, I have put coconut oil in water. How do I separate them? Now, this is a much easier thing, because the two liquids are immiscible liquids. That means they do not form a homogeneous solution. They form a heterogeneous solution. How do I separate them out? Because their densities are different. Now what can I do? I can simply take it in some sort of a beaker where you see there is water which is heavier, kerosene oil here or some other oil also, it is lighter. So simply take out the water, oil would be left out based on the densities. A simple kind of a method where we separate two immiscible liquids. Next, is there any other method to separate a mixture of two solids? Say I mix salt and accidentally what has happened is I have added camphor to it. So is there a possibility to separate salt and camphor? Can it be done? Yes, it can be done. How? It can be done simply by a process of sublimation. Why? Because we know camphor is a volatile substance. Of course, we burn it. Now, whenever you perform your puja, you must have burned the camphor, right? But if you leave camphor just like that by opening the cap, it is a volatile compound or a volatile substance which simply effervesces. It goes off. So how can I separate these two? Very simple here. What do? You take a mixture of salt and camphor, simply heat it. Nothing is going to happen to the salt, but camphor, slowly and steadily being volatile, it directly transforms from solid to the gas state. And this gas is then helped or made to be deposited on the conical flask here at the end. I can separate the camphor, right? That means on the basis of the volatility. If it is a volatile substance, I can simply burn it off and ensure that it sublimates on one particular surface from which I can collect it. Now the next question. So how do I separate dye in a black ink, a single color? How do I do it? Now there are some other industrial separation or identification methods. For example, chromatograph. Chromatograph or chromatography is a process of separation of components of different colors. Different colors can be separated, right? This is an example of liquid chromatography, where what do? You simply take a strip of filter paper. If there is a line of ink which is drawn here, you put it in the chromatograph. Here liquid solvent is used, and when the liquid solvent is used, it is going to separate out that particular color. These days we have created many advanced kind of chromatography. Liquid chromatography is available mostly in many industries. We do use GC also, that is gas chromatography also. It's a technical method of separation. Apart from that, if there is a mixture, say for example, I have mixed two liquids. Now I want to separate them. How do I separate them? How do I separate two liquids? The method for that is distillation or fractional distillation. I can separate two liquids on the basis of their boiling points, and if their boiling points are different or if their boiling points are apart by around 25 Kelvin, we can do it simply by distillation method. Or if the boiling point is very close, then I can go for fractional distillation. Say for example, if liquid 1 and liquid 2 have boiling points at say 90 degrees Celsius and 95 degrees Celsius, then I can go for fractional distillation. Exactly at 90-91 degrees Celsius, I can take out one liquid. Then at a higher temperature, I can take out the other liquid. This is called as fractional distillation. That means a mixture is heated in the distillation flask. Slowly and steadily it is heated, and I maintain this at one particular temperature. That means one liquid out of this particular mixture is going to boil out. It's going to become vapor. I'll just cool it in a condenser, then I collect it. And at the higher or the next temperature, I again use the same phenomena. All right. So this is how we do it to separate two miscible liquids, two liquids which are added together, which have created some sort of a homogeneous solution. Now the next question is, sir, I want to filter out air. How can I filter out air? Is there any possibility? See, what we did here, we did a fractional distillation where I am heating it. Now try to reverse the process for air. Because I want to liquefy the components of air. I told you air has nitrogen in it, air has oxygen in it, air has of course carbon dioxide in it, air has other constituents. So what do? I simply reduce the pressure. That means I increase the pressure and reduce the temperature. I put air under high pressure and I reduce its temperature. That means cold compressed air is passed through some sort of a setup where you can see here air I compress it and I cool it continuously by increasing the pressure and decreasing the temperature. Liquid air. So liquid air can now be separated at different temperatures. So you can call it some sort of fractional distillation itself in the reverse direction. That means where I am not increasing the temperature, I am reducing the temperature. From gas, I am bringing it to liquid. There, I am reducing the temperature further. That means at minus 183 degrees Celsius, I get oxygen. At minus 186, I get argon. At minus 196 degrees Celsius, I get nitrogen. So I can separate it out through a setup like this. Air is passed under pressure, then the air is cooled to extremely low temperature. Then I use a separator. I take out carbon dioxide, I take out nitrogen, I take out oxygen separately. All right. This is another method of separation. Right. There is one more idea. How can we obtain pure copper sulfate from an impure sample? Right. This we have done it in our previous discussions also. We have taken an example of copper sulfate many a times. If there is an impure solution or if you have an impure sample of copper sulfate, simply heat it. Simply heat it. All the liquid would vaporize and only copper sulfate crystals would be left out at the end. At the end. That's one of the methods of separation of copper sulfate. All right. Right. So till now we have understood methods of separation. Let's move on and talk about our pure substances now. When we discussed or when we started with matter, I told you categorization is done between pure substances and mixtures. Now, under mixtures, we discussed homogeneous mixtures, uniform composition, heterogeneous mixture, non-uniform composition. Now, let's talk about pure substances. A pure substance can only be an element or a compound, right? Elements cannot be broken down into more simpler substances. A compound has fixed composition, but it can be broken down. For example, say H2O, right? Water. Element, now hydrogen. Simple hydrogen is an element. So hydrogen is a pure element, it cannot be broken down further. Water, it's a compound, H2O, it comprises of H2O molecules. It can be broken down into hydrogen and oxygen. Electrolysis can be done, right? But both of them are pure substances. Now, element is something which was discovered by Robert Boyle, and it is the basic form of matter which cannot be broken down into simpler things. Of course, it can react with other substances. Whereas compounds are substances which are composed of two or more elements which have chemically combined. I gave you example here. Say element can be hydrogen and a compound can be hydrogen plus oxygen. That is creation of water. All right. Now that is a simple compound. Now we have discussed about elements before. Elements can be seen in periodic table, and periodic table has been in news in recent times. Recently, the government has apparently removed periodic table from the NCERT books. Strange, but still, let's not get into it. But elements, we discussed elements can be metals, non-metals, metalloids, and I showed you this in our previous discussion also. Metals are structures in periodic table that are characterized by similar kind of traits. They're typically shiny material where they have good thermal and electrical conductivity, whereas non-metals are characterized by their lack of metallic properties. They are very brittle. They do not conduct heat and electricity. Non-metals can be further divided into non-metal elements like sulfur, phosphorus, carbon, halogens, and noble gases. I told you non-metals are extremely important, which basically form a lot of the combination of our body, right? Our body is composed of hydrogen, carbon, nitrogen, oxygen. Very important. We also need phosphorus, sulfur, etc. in our body, right? Apart from these two, there is something called as metalloids also. Metalloids are basically in the middle ground, which behave as metals also, non-metals also. Specifically in the periodic table, I showed you they are somewhere here: boron, silicon, germanium, arsenic, etc. And I told you that there is a difference between metals and non-metals. Metals are opaque, metals are lustrous, metals are sonorous as well. Whereas non-metals, they have different properties. Metals, they form cations. That means they form positives. For example, say sodium forms plus. Cations. They have luster. They are lustrous. They are shiny. They are good conductors. They can be molded. They are very malleable. Many of the metals are also ductile. That means they can be rolled into sheets, etc. They have high melting point. They are solids mostly at room temperature, barring mercury, of course. They are also sonorous because they make sound, and the opposite of that are non-metals. Non-metals generally form anions, that means negative ions. Say halogen, chlorine, negative ion. They are dull, they are not colorful, they are not lustrous, they are not sonorous. They are often liquid or gases at room temperature. Apart from that, compound are also considered pure substances. But please remember, compound can be confused with mixture. I told you a mixture is a some kind of a solution, or some kind of an end product which has been created by mixing two things, say liquid and liquid, liquid and gas, solid and liquid, etc. Mixture can be heterogeneous or homogeneous, but a compound is different from a mixture. Now please remember, in a mixture, the constituents, say constituent 1, constituent 2, they do not react chemically, but in a compound they react to form new compound. And remember, their composition is always fixed. And when you mix two things, constituent 1, constituent 2, the mixture itself shows the characteristics of the constituent substances. But when two elements react to form some sort of a compound, the compound itself can have completely different characteristics from the reacting elements. Apart from that, the constituent elements can be separated only by some sort of a chemical or electrochemical reaction. We have seen this. For example, say iron reacting with oxygen. This is rust. Now, iron has some property, oxygen has some property, but rust or Fe2O3 has completely different properties. And again, they can only be separated by some sort of a chemical or electrochemical reaction. But mixtures can be separated by many physical processes, which we discussed. How do we separate them? Maybe by filtration, maybe by centrifugation, maybe by simply fractional distillation, maybe by cooling and distilling at lower temperatures. We saw with air also. So these are basic differences between mixtures and compounds. And remember, always pure substances and impure substances or mixtures. This we discussed, right? The entire conclusion of today's video is this itself, that matter, it can be divided into pure substances. Pure substances are only elements. These cannot be further broken down. Compounds, when elements react, they form compounds. Compounds are also considered as pure substances. But impure substances, which have no fixed composition, they are basically different kinds of mixtures that you have. It can be heterogeneous, it can be homogeneous mixture as well, right? We discussed this. As I told you, today's interaction is about atoms and molecules. We already established matter comprises of tiny particles called atoms. We also saw some characteristics. Right from time immemorial, that means from ancient time, people are trying to explain what the matter is composed of, what the universe is composed of. We discussed about Indian philosophy. Indian philosophers, Indian thinkers, they gave a concept of Panch Tattva. Our body or any matter in the universe, it is composed of Panch Tattva. So, did we discuss concept of atom also? Yes. Now, we are going to connect some knowledge from here, science knowledge, to history. In your history, you must have discussed about 6 schools of Indian philosophy, right? 6 schools. What are those? There is Nyaya, there is Sankhya, there is Yoga by Patanjali, then there is Mimamsa, Purva Mimamsa and Uttar Mimamsa. Uttar Mimamsa is nothing but the Vedanta philosophy. And then there is a 6th school called Vaisheshika school. Have you heard of this? Vaisheshika school, which was developed by Maharishi Kannad Kashyap. This Vaisheshika school is nothing but the theory of atom. Maharishi Kannad Kashyap, right? He said that any matter or any padharth, it can be divided into tiny particles, and the smallest particle which cannot be further subdivided, that would be Paramanu. This Paramanu is nothing but atom. Paramanu. Paramanu means atom. The same explanation was given by the counterparts from Greece, more or less in the same era or same time, by Democritus and Leucippus. Democritus and Leucippus also said that matter can be divided into subparticles, and at one point of time you will reach to one particle which cannot be further subdivided, and that is nothing but your atom. Of course, it's invisible. But in the modern era, with the development of science and technology, new kind of equipment, different kind of testing methodology, by 18th century, scientists recognize that there is a difference between something called as elements and compounds. They established that, of course, the smallest unit is something called as atom, and many atoms, pure substances, we discussed what are elements. Elements are atoms of pure substances. So more number of atoms, when they join, they form elements, and different elements, they can react and form some sort of a compound having different characteristics. We discussed that difference between mixture and a compound. In a compound, the elements can combine, bringing or giving completely new properties. So chemists and other experts started to experiment, and finally Antoine L. Lavoisier, he laid the foundation for chemical sciences by establishing some important laws for chemical combination. He said when two elements X and Y, when they combine leading to formation of a compound or any other chemical structure, they follow certain laws, rules and regulations. What are those laws? The first law of conservation of mass. Antoine highlighted that any chemical reaction or any chemical reaction or chemical compound which is formed, it follows the law of conservation of mass. What is this? It says mass can neither be created nor be destroyed in a chemical reaction. That means the reactants would give you some products and byproducts, and the mass of both the sides, it has to be same. You can see here law of conservation of mass. Say when methane combines with oxygen, the reactants are 80 grams, and the final products, carbon dioxide and water, that would be 80 grams. This is the basic idea of law of conservation of mass. Mass can neither be created nor destroyed. Whatever reactants you use, they will be transformed into the final products plus the byproducts. Apart from this, there is one more law of definite proportions or law of constant composition. This is also called as the Proust's law. Now, Proust's law is extremely important to understand chemical reactions or chemical composition. Now, let me give you a very simple expression of this. What this says is any chemical compound, it is going to have definite composition no matter what, no matter how you prepare it, no matter from which source it comes. If it is a chemical compound having one particular structure or one particular composition, it will have definite proportions in it. For example, CO2. The classic example would be carbon dioxide, right? CO2. Now, you know, carbon dioxide is released by us. Like we basically breathe in, we take air, we use the oxygen, we release high carbon dioxide. So carbon dioxide, wherever it comes from humans, it comes from, say, agricultural sources, or it comes from industrial sources, it comes from the exhaust, from the IC engines exhaust. From wherever it comes, it would be the same composition. It will have definite proportion, CO2. That's it. All right. That means if you take 1 gram of CO2, if you take 16 gram of CO2, if you take 1000 grams of CO2 also, there would be definite proportions for carbon, oxygen in the same composition itself. So two laws were established. But the next question was that how do I prove these? How do I prove these? Now scientists were now thinking about how exactly, or how in an appropriate way we can explain these laws. Then came British chemist John Dalton. Right? Now, John Dalton, he gave certain rules and regulations regarding these laws. John Dalton, a British scientist from 1700s. What he did was he gave certain rules and regulations where he said all the matter, it is basically composed of tiny particles called atoms. These atoms, they participate in the chemical reaction. Atoms are the last item. We cannot divide any atom into further subatoms. That means atoms are indivisible. They cannot be created or they cannot be destroyed. They are already in existence. So atoms are something which give any element its identity, its mass and its chemical properties. So it is because of the atoms. Atoms has mass. Atoms give certain chemical characteristic to the elements or the compounds. And atoms of different elements, they have different masses and different chemical properties. And he also said atoms can combine in the ratio. Atoms can combine a ratio of small whole numbers to form compounds. And finally, the relative number and kinds of atoms are always constant in a given compound. So these are the laws which are given by Dalton, which laid the foundation for entire chemistry or chemical understanding, right? Chemical reactions. So what is an atom now? An atom is the basic unit of any matter which cannot be further divided. It is the smallest entity, which of course we cannot see through naked eye. So what is the size of it? It's extremely small. It's in the order of 10 to the power of minus 9 or even 10 to the power of minus 10 meters. All right. So you need to get that atoms are very small. They're smaller than anything that you can imagine. These constituents of atom would be much smaller: protons, neutrons, electrons. We'll talk about that in our subsequent discussion. But just look at the atom of different elements. For example, hydrogen. An atom of hydrogen is approximately size of 10 to the power of minus 10, and this 10 to the power of minus 10 is called as angstrom. You must have heard of this. A molecule of water, that is H2O molecule, it is of the order of 10 to the power of minus 9 meters. It is in the range of nanometers. A simple apple that we eat, it is in the range of about 10 to the power of minus 1 meters, right? It basically in centimeters. All right. So imagine the size of an atom, extremely small. And what Dalton did was he wanted to understand different atoms and elements. What he said, what atoms are the smallest entities, they take part in the reaction, and it is because of the atoms that every element has mass, and every element has certain chemical characteristics. So what he wanted was he wanted to give a connotation or distinguish one element from another element. So what he did initially was he proposed some of the symbols. Initially, some symbols like hydrogen was denoted something like this. That means 0 and a dot would be hydrogen atom. Carbon, oxygen, all these things were given by Dalton. But it's understandable. Now we already know in the periodic table there are more than 110 elements, and imagine such small images like this to define those elements. It would have been very tough, right? Then came the IUPAC, that is International Union for Pure and Applied Chemistry. Now what happened was IUPAC, or in short we call it as IUPAC, it's an organization which names the elements, compounds, etc. It basically brings out rules and regulations which are connected to chemistry. So what they did was they came up with certain strategy for naming different elements. Now some of the elements, they were basically named in English. For example, after whatever you explain, say if something is sodium, its Latin name, sodium's Latin name is natrium. So they took the first two letters of it. Many in English, for example, chlorine. In chlorine, they took first two letters of chlorine. See, first, not two, the first and third letter. For zinc, they took first and third letter. So they made a combination of letter or first two letters or their Latin names. Many times you must have seen some elements wherever they are discovered, they come from that. Some of the synthetically discovered elements or synthetically produced elements, they have been given the name of the renowned scientists. Right? There is Einsteinium, there is fermium, etc. You must have known synthetic elements also. So the naming is done in such a way. For example, copper, the name of copper is taken from Cyprus. Gold, the name of gold is taken from English word. All right. So it is named from Orium EU. So such nomenclature has come up, and we have developed a periodic table. You already know, and these are some of the examples of elements and their nomenclature. Meaning, now when I say aluminium, aluminium is now denoted by a symbol called as Al. Aluminium is an element which has a mass, which has a definite atomic mass, which has a definite chemical characteristic, and this aluminium is made up of aluminium atoms. All right. So aluminium, Al, argon is Ar, barium, Ba. So this is a list of some of the important elements. There is no need to mug up per se, but if you're preparing for JEE or say any other competitive exam, probably such symbols might be asked, but in UPSC this is not important for us. But nonetheless, some of the important elements and their connotation. So if there is a statement, for instance, the elements and their nomenclature, if I can create a question on this, all the elements in the periodic table have been given a name based on their first or the second letter. That statement would be wrong. Nothing like that. Many times, for example, if you see silver, if you see gold, English name Orium, you get AU. Then if you get silver is denoted through AG, right? So name silver, but Ag sometimes it can be different. So nomenclature is decided by IUPAC, International Union for Pure and Applied Chemistry. Now next question is, what is atomic mass? See, atomic mass, this was developed to explain the concept of definite proportions, the law of definite proportions. Now Dalton said that every element, it has its own characteristic atomic mass. Now he said, if I take aluminum has certain characteristic atomic mass, carbon has certain characteristic atomic mass, oxygen has some atomic mass. Now for defining any kind of unit or any kind of I would say a measuring parameter, what we need is a reference. We need a reference, right? For example, I have weights. Now if I go to market, I have to buy something. I have to buy 1 kg of onion. So 1 kg has to be defined. 1 kg has to be defined. It would be defined by the organization connected with the standards. Say for example, if I have to buy pieces, if I cut this watermelon into different pieces, now what I want is, I want watermelon which is equivalent to two pieces of another fruit. So this is how I define it. I need some sort of standard, correct? So scientists began to define every element based on its atomic mass, and we have created a periodic table. Initially a standard was needed. So what standard did they take? They took the reference of oxygen. Initially they established that atomic mass unit of naturally occurring oxygen was 1/16 of the mass of that particular atom. It was defined, and then with reference to oxygen, the other elements were defined. But in 1961, under IUPAC itself, under the other organizations, it was accepted that the reference unit for any atomic mass unit would be carbon-12 isotope. So please remember, from exam perspective, when I say hydrogen has an atomic mass of 1, what does that mean? It is in reference to carbon-12 isotope. What is an isotope? We'll understand in our subsequent discussions for sure. Now, if I say oxygen has an atomic mass of 16, that means it is again in reference to carbon-12 isotope. So these are some of the reference atomic masses of few elements. Now you already know, we'll discuss about periodic table, etc. So for any element, say if I talk about hydrogen, I denote it as 1H1. That means this would be the atomic number, this would be the atomic mass. We'll discuss atomic number, atomic mass, different isotopes in our subsequent discussions for sure. But we are talking here about atomic mass. Carbon. Now carbon's atomic number is 6, but its atomic mass is 12. This is the reference, carbon-12 isotope, and with reference to carbon-12 isotope, all the other elements have been defined. Their atomic masses have been defined, and a periodic table has been created. Clear? Do not forget about this. Next, different elements can combine, or different atoms can combine to form molecule. Now what can be a molecule? A molecule is generally a group of 2 or more atoms that are chemically bonded together, or tightly held by some sort of an attractive force. It can be an ionic bond, it can be a covalent bond, it can be different kinds of bonds. They are held together by bond, and every molecule, it can be defined as a smallest particle of an element, or it can be a smallest part of a compound as well. So please remember, atoms, when many atoms come together, they lead to formation of elements. Now some elements can be molecule, and some molecules can be compound also. Please try to understand this. Whenever I define a molecule can be a combination or a smallest particle of an element, or it can also be a smallest particle of a compound. I'm quite sure you're thinking, sir, I want to understand more. I'm not getting that clarity. Now let me explain through this. A molecule can consist of same type of atoms. A molecule can consist of different type of atoms as well. Molecule can be molecule of elements. Basically, when I say element, oxygen, I use O2 gas. That means this molecule has 2 atoms of oxygen. Chlorine gas, I denote it as Cl2. That means same atoms, they comprise a molecule. Hydrogen, for example, hydrogen gas, H2 gas, we say H2 is a gas. Now H2 is a molecule comprising of two atoms of hydrogen. Similarly, molecule can also lead to formation of a compound. It can also lead to formation of compound. For example, classic H2O. Now H2O is a compound. H2O is a molecule also, right? Molecules of a compound. H2O, molecule which leads to a compound, right? Molecules of compound or molecules of element. I hope it's clear now. All right. So please remember, whenever I say molecules of elements generally are of same atoms. It can be diatomic, triatomic, monoatomic also, monoatomic, diatomic, triatomic, etc. It can also comprise of different kinds of atoms which lead to molecules of compounds. They're held together by different bonds. All right. So let me just again give you some differentiating pointers. Molecule of an element, it is a combination of two or more atoms of same type, but in a compound it is different type. Molecule of element has atoms of exactly one chemical element. Here it can be two or more different elements. Remember, in a molecule of element, they are held together normally by a covalent bond, but a molecule of compound, it can be covalent or any other kind of ionic chemical bond. Examples are many that I have already given to you. All right. Apart from this, whenever a molecule of element or a molecule of compound, they dissociate, they lead to creation of ions. This is where the reaction comes into picture. Now, whenever we talk about any element or any atom, an atom comprises of different structure. We'll talk about structure, where we say nucleus, it comprises of protons and neutrons, and there is a configuration or there is an electron cloud around it. And the configuration of electrons of this atom, it describes or it defines its chemical properties also. And we talk about something called as valency. Now valency means how quickly an atom can accept an electron or lose an electron. Now valency, to be described in very simple terms, valence electrons or valency of any particular atom can be considered as hand. Say for example, we have two hands, right? So human valency 2. Take example of an octopus. An octopus has 8 hands or 8 limbs basically. So the question here is, how many other atoms or how many other constituents, entities can I hold? I can hold 2, but the same for octopus is 8, right? And an octopus can hold 4 persons basically. So that is how we define the valency of one particular atom, and this valency defines the chemical reactivity or chemical composition of that element. And I told you, whenever they dissociate, they form ions. So ions can be positive or ions can be negative depending on the valency or the valence electron position of that atom or element. All right. So positive ions are called cations, negative ions are called anions. And through this itself, we devise chemical formulae. Now you must wonder, you must think, sir, in your examples you have told about NaCl, right? You have told about NaCl. This is sodium chloride. Sir, why don't I call it chloride sodium? Right? For example, I have water. I write it as H2O. Have you ever thought, sir, why is this not OH2? Why is it not like this? Is there any difference between this and this? Technically, no, because the chemical composition is same. Is there any difference between NaCl and ClNa? No. Then the question is, why exactly we write something as NaCl only, something as HCl only, H2SO4 only? Because according to UPSC and other chemistry organizations, they have created some rules of chemical formulae. Whenever there is an ionic species, the sum of charges of the ions must be equal to 0. Now you can see here, when I write NaCl, Na plus is a cation, Na plus, it has a valency of 1. So Na plus, when it joins Cl minus, because chlorine has again -1 valency, that means Na plus Cl, they are going to balance each other. That is why NaCl, meaning in an ionic species, the sum of charges is equal. Same in a covalent species, for example, H2O. Now, when you talk about H2O is a molecule. Now, hydrogen has valency of 1, H plus, but oxygen has 2 minus. That is why when you add these two, you will get H2O. Similarly, in ionic species, always the cation is written first. That is why it's NaCl, not ClNa. Same applies in a metallic kind of combination. The metal is written first. The metal is written first. For example, say I write Na2CO3, right? Sodium carbonate. Na2CO3. I write Na2 first, CO3 later, right? First connected to metal. Apart from that, the number of atoms of each element or ion in the formula is written to the right of symbol as a subscript. You can see here Na2. It's always subscript. It's not equal. Please remember, in terms of nomenclature, when you are writing answers also, first letter should be capital. The second letter, if it is a two-letter element, second letter should be small, and the number should be much smaller than that. It should be subscript. Na2, it should be C, it should be O, because C and O are different elements, and 3 should be again subscript. That is the right way of writing, or right way of nomenclature writing. And again, if a compound contains more than one polyatomic ion, each ion is enclosed in bracket. So many a times you must have seen that some compound, say for example, some kind of ore, if it has a lot of water molecules, then we do write H2O in a bracket, and we write some sort of a number to explain it. Correct? For instance, say I can write some sort of a compound like NaOH2. I write NaOH2, NaOH3, something like this. Okay. It might not be chemically correct, but I'm just giving you certain examples. All right. I hope it's clear. Right. Next, you can see some examples here. When I write HCl, H plus 1, Cl minus 1. So they both balance. And I write HCl, hydrochloric acid. Same applies here. Now H2S, hydrogen sulfide gas. Now I write hydrogen. Why I need 2? Because sulfur has a valency of 2 minus. That is why hydrogen sulfide gas, H2S, is written. Similarly, I write Al2O3 because I want to balance. I want to balance these two. See, Al2O3. Always metal first, and they have to be balanced. Our primary focus is not about balancing, but I want you to know these things for sure. Okay, how do you write a chemical form, right? Now, apart from this, there is one more unit in chemistry which has been developed. You all know there are 7 fundamental SI units, and one of them is mole. Now, please remember, what is this mole and why have you brought this in chemistry? See, I was very confused when I was reading this in my school and in my college. I used to think that why they have created mole. Why they have created mole? I can simply take in chemistry, okay, in the lab, we take, say, I take 10 grams of chemical 1, 10 grams of chemical 2, I mix both of them, right? It's easy, right? But then again, you need to understand in chemistry, when we talk about atoms and molecules, they are extremely small. They're extremely small, means we cannot measure them, physically measuring them atom by atom, molecule by molecule. It would be impossible. Yes, I can use a thing in terms of grams, which is much easier. But when I take a composition, say for example, I want some molecules of, say, carbon dioxide to react with some exact number of molecules of, say, water, so that I want weak carbonic acid, H2CO3. How do I decide that? Taking weight, say for example, taking weight in terms of gram, it does not make exact sense, because the number of molecules cannot be assessed or cannot be calculated. So what have we done? We have created a new SI unit called as mole. Now it is written as, or it is denoted as MOL, mole, right? Mole. So a molecular mass of a substance is sum of the atomic masses of all the atoms in the molecule, and it is expressed as atomic mass unit. And whenever we take an atomic mass unit, we have created a unit where we say one atomic mass unit of any molecule, of any compound, it is going to have standard number of its constituents, standard number of atoms, standard number of molecules in it. And that is defined by something called as Avogadro's number. So please remember, a mole is a unit in any chemical reaction. This mole, it indicates the number of atoms or the number of molecules. Remember, number of atoms or number of molecules taking part in the reaction. So it is one of the SI unit. It's equal to 6.0221 into 10 to the power of 23. Now this has been given by the scientist. There is no need to mug up the number also, but I want you to know that Avogadro's number is basically the number of atoms or the number of molecules in 1 mole of that substance. Alright. Again, please remember, Avogadro's number was not given by Avogadro himself. Avogadro basically gave Avogadro's law. It is connected to the volume of the gases. Now, based on his hypothesis, based on his theory, many chemists, they came up with this number. In fact, it was Jean-Pierre Perrin who gave the idea, or who gave the nomenclature of Avogadro's number, and he said that 1 mole of any substance, it is going to contain this number of atoms or this number of molecules, which help us in terms of understanding the chemical reactions. All right, let me just explain. Many times I used to get confused by this, but to put it in very simple language, let me take example of CO2, carbon dioxide. Now when I say carbon dioxide, I already know that the atomic mass of carbon, this is 12. The atomic mass of oxygen, this is 16, correct? But you can see in carbon dioxide, there are 2 atoms of oxygen. That means there are 2 atoms of oxygen. So totally, when I add all these 3, I say carbon dioxide has a molecular mass of how much? It has a molecular mass of 44. So 1 molecule of carbon dioxide is 44 gram. All right. Now this 44 gram, it becomes 1 mole of CO2. This is the unit that we have created. And please remember, when I say 1 mole of or 1 mole of CO2, it is equal to 44 grams of carbon dioxide, and it is also equal to Avogadro's number 6.022 into 10 to the power of 23 molecules of CO2. I hope it's clear now, right? The 1 mole of any particular compound or any particular molecule is equal to its molecular mass, and it basically defines that these number of molecules are present in 44 gram. These molecules are present in 1 mole of carbon dioxide. It's a very simple kind of example to understand it further. Although it's a little confusing. I used to think this, why so much of hassle? Why so much of hassle? But as you try to understand in chemistry, many a times in chemical reactions, I want to understand the nature of chemical reaction, the dynamics of chemical reaction, chemical kinetics, chemical dynamics, the chemical kinematics. Then I do need Avogadro's number, which will help or which will ease my calculation and understanding. But again, from UPSC civil services perspective, you don't need too much of calculation, too much of numericals. In fact, we do not focus on that at all. But remember, Avogadro's number was not given by Avogadro, it was given by Jean-Pierre Perrin. All right, and Avogadro's number is this. So 1 mole of any particular compound, it is equal to the molecular mass of that compound, and that molecular mass is going to contain this number of molecules or this number of atoms. All right. Now, if you are getting still confused, as I gave an example of CO2. Now, if I just change this CO2 to anything else, say let us take a molecule of elements. Say for instance, say nitrogen. Let's take nitrogen gas, N2. Right? We know what is the molecular mass of nitrogen, 14. But there are in this particular nitrogen gas, there are 2 atoms of nitrogen, so it makes it 28. So 28 grams of nitrogen gas is equal to 1 mole of it. And remember, this contains how many molecules? Again, the same number of molecules. All right, that's the beauty of chemistry. So this is the last topic of discussion. I'm quite sure it has been a little bit of head scratcher. That is why we do not focus too much on chemistry in terms of UPSC Civil Service Examination. As I told you, we are not going to discuss more about balancing the reaction or numericals, etc. Just the basic gist of it, right? So that's it. Let's begin our discussion today. As I told you, today's interaction is about structure of atom. Until now, we have established certain things. In the first 3 chapters, we focused on understanding matter and nuances connected to matter. And in chapter 3, we discussed about atoms and molecules, and these are the fundamental building blocks of any matter. Now, scientists were thinking, now we discussed that from the perspective of chemical reactions, of course. Now, scientists were thinking, how does this atom look like, or what is the structure of this atom? They were trying to explain different models. We also spoke about different laws, conservation of mass, conservation of definite proportions. Now, they were trying to explain it through structure of the atom, and various scientists, they started to work by the end of 19th century to reveal what exactly an atom looks like. And different scientists have given their models by refuting the previous model. One of the initial models was given by John Dalton, of course, right? We discussed about John Dalton, that is the English scientist. He came up with the idea of matter, and he said that matter is composed of very small things, and he called these small things as atoms. And that is why his model is also called as billiard ball model. Billiard ball model means he did not give any kind of explanation about the structure of matter per se. He simply said that matter and its smallest constituent is nothing but atom. Indeed, he was right. He gave certain assumptions, rules and regulations. He said all matter is composed of atoms, and atom itself is indestructible. Agreed. Atom is indivisible and indestructible. And atoms are something that give properties to the elements. It is because of the atoms the matter has physical and chemical properties which are specific to it. And as we spoke about chemical reaction, in a chemical reaction, it is nothing but a rearrangement of these particular atoms. We have established the rules and regulations regarding Dalton's atomic assumptions. That is why it's called a billiard ball model, where he simply said atom is something like this, but he did not go in depth of it. And by now we already know, of course, atom is indivisible and indestructible, but we know an atom is composed of subatomic particles. They are called as protons, neutrons and electrons. So that is why Dalton's atomic model, it fails to explain these subatomic particles. It fails to explain why chemical reactions take place. It fails to explain the involvement of electron or electron transfer in the rearrangement of these atoms. That's why the next model came. The next model came in 1904 by J.J. Thomson. Now, J.J. Thomson gave a different model. Instead of the billiard ball model, he gave the concept of a plum pudding model. His model of atom is called as plum pudding model. Now, he said that yes, atom is indivisible. Atom is the final constituent, or matter is made up of atoms which are indivisible, indestructible, but it has charge. It has charge, right? And J.J. Thomson said that atoms, it consists of something called as electrons, and these electrons are negatively charged. And because of the transfer of these electrons, the chemical reaction or rearrangement of atoms, it does take place. Yes, true. But now, if there are electrons, if there is negative charge, then it also should have positive charge. So J.J. Thomson, he knew that overall an atom is neutral. That means it will have neutral charge. If there are electrons, then there has to be some sort of a positive body or a positive charge also. And in a very simplistic way, J.J. Thomson explained, since there are electrons, these negatively charged bodies are electrons, and these electrons, they are diffused, or they are spread in the cloud of positive charges. This red thing is a cloud of positive charges, and in it different electrons are there. A very simplistic model. But slowly and steadily our knowledge did refine. Dalton did not talk about electrons or positive charges. He simply spoke about an atom. But J.J. Thomson spoke about electrons, presence of negatively charged bodies. But even this model, it does not explain everything because there are many limitations to Thomson model. Of course, he came up with the negative charges, that is electron, yes, but he failed to explain how the positive charge, those are held inside the electrons. Because if the positive and negative charges, they combine, they neutralize each other. But then why atom is reacting again? Why some element undergoes multiple reactions? It fails to explain. It fails to explain the stability of the atom. Because by this time, the concept of nucleus had not evolved. The concept of nucleus, it did not evolve. J.J. Thomson mainly failed to explain the concentration of positive charges somewhere in the middle of the atom. He said that electrons are basically spread in the spherical cloud of positive charges, but it's the other way around basically. It's other way around. We know that by now. But this is called plum pudding model because it looks like a pudding. Right? It looks like a British pudding, but this is the pudding, and there are the constituent or the nuts. They are like the electrons, right? Right. The next model or more refinement, it came with Rutherford's model. Ernest Rutherford, he conducted certain experiments to understand where are the charges exactly residing. What are the characteristics of the atom through experimentation? He tried to improve Thomson's model. Thomson had given this model, but there were many limitations, and they were Thomson's plum pudding model. It was refuted by Ernest Rutherford. Why? Because he conducted an experiment. He conducted an alpha ray scattering experiment. He scattered alpha ray on a gold foil, and he observed how these alpha rays are deflected. Now he observed that when alpha rays are passed through this gold foil, some of the alpha rays, they did not deflect at all. In fact, he said majority of the alpha rays, they did not deflect. That means when I talk about a gold foil, now we are discussing about gold atom. In a gold atom, many alpha rays, they did not scatter at all. They simply pass through the gold foil as it is. But there were some alpha scattering. There was some alpha scattering which was observed. Whenever alpha ray interacted with the electron, it scattered in some direction. When it interacted with the positive charges, it scattered in some direction. And he observed that many a times the alpha scattering was exactly 180 degree. That means the scattering was reversed also. So based on this experiment, Rutherford came up with a conclusion. He concluded that in an atom, basically the gold foil, it consists of some sort of a central charge where the charges are concentrated, and he named it as nucleus. This is also called as the nucleus theory or atom theory, which talks about nucleus. Now Rutherford explained that the positive charges are held at the center of the atom. These are the positive charges, and many alpha ray, they interact with this, they are scattered, yes, but many alpha rays, they are also reflected back exactly 180 degrees. And he said electrons are revolving around this nucleus in circular orbits. This is also called as the planetary model of atom. Means the nucleus is like the sun, and electrons are revolving like the other celestial bodies or the planetary bodies, satellites, etc. And he said that alpha rays, they do interact with electron also, but this scattering was minuscule. That's why he said that most of the charges and most of the mass of this particular atom is concentrated in the center, that is nucleus. He said the bulk of the mass and bulk of the volume itself is concentrated in the nucleus, and electrons, they basically revolve in a circular orbit around the nucleus. Very similar to how planets are revolving. Again, we refined our knowledge. But there are certain limitations to Rutherford model also. The first and biggest disadvantage or limitation of Rutherford model is he also failed to explain the stability of an atom. He failed to explain the stability. Although he said, yes, nucleus is at the center, and he said the electrons are revolving in a circular orbit. But he also said that when electron revolves in this orbit, in the circular orbit, he said the revolving electrons, they also emit energy. Now, please try to understand this. If this is going on, if they are accelerating, if they are emitting energy, then there would be one point where this electron is going to lose all of its energy and it is going to collapse in the nucleus. Then what? If it collapses in nucleus, what happens? Why are these electrons exactly revolving in these circular orbits only? How are they stable? Why are they emitting energy? All these things were not explained. Apart from that, he also failed to explain in totality the chemical kinetics of a reaction. As I told you, the electron interaction. If it loses energy, then it is going to fall. How is it stable? There was no answer. And then came one of the best models that was developed by Niels Bohr. Now, Niels Bohr model, it is inspired from the planetary idea itself of Rutherford. Rutherford's model has been refined by Niels Bohr. Now, Niels Bohr said that in an atom, of course, like Rutherford said, Ernst Rutherford, nucleus is at the center and nucleus has positive charges. Now, if there are positive charges, then nucleus should also contain something else, because if there are positive charges considered, you do know positive charges, they repel each other. If there are protons, then they will repel each other. So there are protons also, and this nucleus is maintained because of charges called as, because of constituents or entities called as neutrons. So nucleus consists of protons and neutrons together, which are held very tightly. And now electrons are revolving. Like Rutherford said, electrons are revolving in a circular orbit. So this is also a kind of a planetary model. But now Niels Bohr described that these electrons, they revolve in different shells. That means they revolve in different orbits. And these orbits, these electrons are held in this orbit by electrostatic force. But why do these electrons emit some sort of energy? For that, Niels Bohr explained that many times electrons, if they are in the ground state, he described an electron to be in ground state if that electron is in its own shell. He explained that around the nucleus there are different shells, K shell or K orbit, L orbit, M orbit, N orbit. So different orbits or different shells, they were named differently, and every orbit or every shell has different energy. According to Niels Bohr, the farther the electron in the orbit or in the shell, it will have more energy. And he said many a times an electron, it might jump from the lower energy state to a higher energy state. This is called as excited state. Now in the excited state, the electron cannot remain perpetually there. So it will try to come back to its original state. And when it comes back to its original state, it has high energy. It has to come to lower energy state. It releases photons. It releases the energy. So this is what was explained by Niels Bohr, and this is one of the closest explanation. This is the accepted notion that we already know. So Rutherford's model was further refined by Niels Bohr, and Niels Bohr spoke about different orbitals or different shells in which there are electrons. And in fact, based on this itself, we have developed the different shell configurations. Apart from this model, more refinement did come to the Schrodinger's quantum atomic model. Now this is called as the quantum atomic model. Although this is not mentioned in NCERT, if I recall it correctly. So Schrodinger's quantum model, it simply says that yes, of course, there is nucleus, and this nucleus consists of protons. These are positive charges. Neutrons are also there. Neutrons are chargeless, but they do have mass. Neutrons provide stability to the nucleus because it is holding positive charges together. And he said electrons can be seen as a cloud around nucleus, not exactly as shells, but they can be seen as a cloud, because electron would be traveling at the speed of light. Electron would be moving very, very fast, and it is as if the negative charges, it consists of an electron cloud. Now this model was further refined by a lot of quantum physics laws, right? Although Erwin Schrödinger, initially he solved the Schrödinger's equation giving the notion of electron in a central electric field. He spoke about nucleus, right? Nucleus and electron is in a nuclear field. So he solved the equation, Schrödinger equation. Apart from that, quantum atomic model was further strengthened by hypothesis by de Broglie. He said that all particles in the matter, all particles in the atom, that is the electrons, they can be perceived as matter waves with a definite wavelength, that is the de Broglie wavelength, right? And based on this itself, we can talk about Aufbau principle. Aufbau principle, it gives you the idea of why an electron is present in that particular shell. Apart from that, the quantum atomic model talks about electron cloud. Now, when we talk about electron cloud, can I pinpoint that an electron is present here? If it is revolving, it may be present here, it may be present here, it may be present here, it may be present here. And what is the energy of this particular electron? And for that, Werner Heisenberg, he gave Heisenberg's uncertainty principle. It states that the energy and the position of an electron cannot be defined exactly. I cannot know where an electron is and what is the energy both together at one point of time. That is called as uncertainty. The more I know about the energy of an electron, the less I know about its position. And the more I know about its position, the less I know about its energy. Apart from that, Niels Bohr's ideas were also taken. So eventually, what we know today, the solid sphere or the billiard ball model of John Dalton. From there, we move towards J.J. Thomson, that is the plum pudding model. From there, we move to the planetary model given by Ernest Rutherford, Niels Bohr, and then eventually Erwin Schrödinger, giving the quantum atomic model. These are the characteristics of it. This is for your reference. I'll be sharing the PDF of this particular lecture on my Telegram channel on the ID @Rahul Sai 222. You can always refer to it. So what have we established till now? We have established that atom consists of a nucleus which has positive charges and electrons are revolving around it. And electrons are in different shells, different orbitals. So how are these electrons distributed? Now, according to Niels Bohr and according to the other quantum atomic models, the electrons are distributed in different shells according to different principles. The maximum number of electrons present in any shell, it can only be 2n square. That means 2 into, if it is a first shell, then there would be only 2 electrons in it. If it is a second shell, that means if we talk about different shells here, K, L, M, N orbit. So K orbital, it is going to have only 2 electrons. L orbital, it is going to have the next number, that is 8 electrons. The next orbital, it is going to have 18 electrons, and these electrons are shared according to their energy in different suborbitals on the basis of Aufbau principle. On the basis of this itself, we will be talking about the reactivity of these atoms and elements. But the other rules include the maximum number of electrons that can be accommodated in the outermost orbit is 8. This is called as an octet. That means every atom or every element, it tries to obtain this octet. If there are exactly 8 electrons in the outermost shell, it is going to be most stable. Apart from that, electrons are not accommodated in a given shell unless their inner shells are filled. That means first the K shell has to be filled, then only the L shell would be filled. These are some of the rules and regulations. And based on this itself, we talk about the concept of valency. Valency. I gave you an example in our previous interaction that valency or valence electrons are like the hands that we have. I told you humans have 2 hands. That means I can grab 2 things. I have this slide mover on one side, the pen or the stylus on the other side. But imagine an octopus. Octopus has 8 tentacles. So it can hold on to 8 things together. So its valency is more. So valency or valence electron is like the number of electrons it can catch or number of electrons it can give away so that it reaches the most stable phase. My most stable phase is holding these 2 things. I can hold more things, but they may fall off. So valency or valence electrons is the same kind of concept where the atom, it tries to achieve something called as an octet. That means in its outermost shell, outermost orbit, if 8 electrons are reached, it is going to be stable. So valency is the electrons in an atom which are arranged in different styles, and the electrons that are present in the outermost shell, that is called the valence electron. And the number of valence electrons, it defines your valency. For instance, if you look at different atoms, hydrogen has 1 proton and 1 electron. And remember, hydrogen is the only atom which does not have any neutron. All the other atoms you'll find neutron. Hydrogen has only one proton and one electron, right? One proton and one electron. So what would be the valency of hydrogen? Its valency would be 1, because it would like to lose that electron to someone. If there is another atom or an element which is trying to look for one electron, hydrogen is going to immediately react with it. That's the basic understanding of valence electrons. Similarly, if you look at the structure of lithium, beryllium, boron, carbon, you will find that the best example would be neon. Now, if you look at neon, you will see that it has a nucleus. Yes, there are 2 electrons in the K shell, and there are exactly 8 electrons in the L shell or L orbit. Now, this is going to be most stable. That is why neon, it does not react much. Why? Because it has already achieved the octet. Now, the concept of octet means if there are electrons in it, say hydrogen has 1, it would likely lose it, because there is a very low probability that there is some other atom or an element which is likely to lose 7 electrons. Now, for hydrogen to reach the most stable phase, now for it, the first shell would be adding one more electron to it. But let's take some other example. Say what is the probability if there is only 1 electron in the outermost shell? Then either it can accept 7 electrons to achieve stability, or if it has 1 electron, then it can lose 1 electron to achieve that stability, isn't it? Then what is the probability? What is the higher probability? This one, because I wouldn't find an atom or element which is likely to lose 7 electrons, because that would love to accept 1 electron and reach its octet stage, right? And that is how you'll understand when you look at these atoms. There's a list given in the NCERT where hydrogen, for example, hydrogen, the atomic number is 1, the number of protons is 1, there are no neutrons in it, its valency would be 1. Similarly, for helium, its valency would be 0, because its outermost shell is going to have exactly 2, and the outermost shell is already filled, right? Because the K shell is already filled. But if you look at any other element, for instance, look at nitrogen, oxygen, fluorine. Now let's look at these 3 numbers where you'll understand that its valency. Carbon has a valency of 4, oxygen has a valency of 3, nitrogen has a valency of 3, oxygen has a valency of 2, and fluorine has a valency of 1. Now the question is, why fluorine has a valency of 1? Let's look at fluorine here. Why fluorine has a valency of 1? If you look at its first shell, K shell, there are 2 electrons in it. In the next shell, there are exactly 7 electrons here. Now the question is, will fluorine lose these 7 electrons, or will fluorine accept 1 electron? The more probability is it is going to accept 1 electron to complete its octet. That means its reactivity will be very, very high. The same case with neon. Neon would have 0. Wherever you will find 0, they are the most stable atoms or elements which do not have a lot of reactivity. I hope the valence electron or valency concept is clear to you. Just remember the idea of octet. That means the outermost shell, it has to be fulfilled. In the K shell, if there are 2 electrons, it's fulfilled. In the L shell, if there are 8 electrons, it would be fulfilled, the octet, right? And to get these 8 electrons, either it will accept or it is likely to lose. All right, right. Let's move on. Now we have established what is the structure of atom. There is a nucleus which has protons. These protons are held together tightly. That is why there are neutrons also. Protons are positively charged, neutrons no charge, but neutrons do have mass. Then there are electrons which are revolving. Okay, again, according to quantum atomic model, there is an electron cloud with a probability of electron finding anywhere in that particular region. So the atom is composed of proton. Proton is present inside the nucleus. It has a positive charge. It has a mass also, definite mass. A neutron, this is present inside the nucleus. There is no charge. There is no charge. It has mass. In fact, neutron is the heaviest of the subatomic particles. Please remember, neutron is even heavier than proton. Clear? There is a small difference between mass of proton and neutron. Remember, mass of a neutron is slightly higher than mass of a proton, and because of this difference, it is called as mass defect or mass deficit, we get the nuclear energy. We'll talk about this in our subsequent discussions. And then there is electron. Electron is outside the nucleus. It has negative charges. Its mass is almost negligible because it is of the order of 10 to the power of minus 28. All right. Now, based on this, protons, neutrons, and electrons, structure of atom is defined. Now, we also defined number of atoms, they lead to formation of an element. Now, elements are defined based on the number of protons and neutrons in it. Every element, we have seen the periodic table, every element is defined through two characteristics. When we write an element, we write the atomic number below and we write the atomic mass or mass number above. So if I write one particular element, I signify it as the X, and I told you how is the nomenclature held. There are certain rules and regulations. We normally take the first letter or the first two letters or first and the third letter. I have told you about that. The English names, what is the nomenclature rules. I defined this particular element by atomic number and atomic mass or mass number. What is the atomic number? Please remember, atomic number is the number of protons present in that particular element. Number of protons in the atom of that element. Atomic number. Mass number is number of protons plus number of neutrons. Please remember, in this atomic mass and atomic number, there is no concept of electron. The electron or its characteristics are not used in calculation or in finding of atomic number and atomic mass or mass number. Clear? So you must have seen here in this particular list, if you look at this, if I say hydrogen has how many number of protons, that would become its atomic number. Just look at this, you will see the number of protons, it is going to be exactly same. The atomic number is going to be same. But the number of neutrons, when you add these two, you will find the mass number. That means for hydrogen, if I add this plus this, that means the atomic mass number or atomic mass would be again 1. That is why I write hydrogen as 1H1. Similarly, helium, it has atomic number of 2. That means number of protons is 2, number of neutrons is 4. So how do I write helium? I would write helium as 2He4, because the atomic number of protons is 2, number of neutrons is 2. Add these two, you will get 4. Similarly, if you look at oxygen, number of protons is 8. So its atomic number becomes 8 and its mass number becomes, just add number of neutrons, just add these two, you will get, for oxygen, you will add 8 plus 8, you will get 16. Right? So this is atomic number, this is the atomic mass to designate that particular element. Is it clear? Now, many a times what we see is there are certain elements which have same atomic number but different atomic mass. Many a times we see there are different atomic numbers but same mass number. And those are called isotopes and isobars. Remember, isotopes are the elements which have same atomic number but they have different mass number. Classic example would be carbon. We know that carbon 12 is also present. We know carbon 13 is also present. We know carbon 14 is also present. So these are the isotopes of carbon, and this isotope of carbon is used in radiocarbon dating. Now, what is the meaning of this? All the three are carbon. All the three have same atomic number. That means all the three are going to have same kind of chemical characteristics, right? But there is an addition of neutron. In carbon 12, there are 6 neutrons. In carbon 13, there are 7 neutrons. In carbon 14, there are 8 neutrons. Because this is constant, that means it is number of protons. So number of neutrons has increased. So isotopes are one which have same atomic number but different mass number. When you reverse it, you will get isobars. Now isobars are atoms with different atomic numbers but same mass number. Same mass number. Right? You can get, say for instance, now if you look at this, we have carbon 14, I told you, but we also have nitrogen, right? So isobars. There are different atomic numbers but same mass numbers. So isotopes are those where the atoms have, basically these are the atoms of same element, they are not of different elements, but these are the atoms of different element. I give you example, carbon 14, then 7 nitrogen 14, different elements. They have same atomic numbers, they have same mass numbers, right? Here atomic number is same for isotopes. Here carbon 6 carbon 12, 6 carbon 13, 6 carbon 14. My example here would be 6 carbon 14, then 7 nitrogen 14. A very good example here, right? But do remember that isotopes, the chemical properties of isotope are similar, but physical properties can be different. But for isobars, they have different physical and chemical properties. MCQs can be formed on these. Clear? Right. So this was the basic discussion of structure of atom, valence electrons, and isotopes and isobars. That's the end of our chapter 4. We'll meet next time in our subsequent discussion. Let's begin our discussion of the fundamental unit of life. What that is? A cell. We all know our body is composed of billions of cells, right? Our eye has different kinds of cells. Our skin has different kind of cell, right? The epidermis, the mesodermis, inside layers, there are different kinds of cells. Heart has different kinds of specific cell. So what is a cell? A cell is the fundamental and structural unit of life. In fact, when we talk about unicellular organisms, for a unicellular organism, this is life itself. A cell represents complete life. But for a multicellular organisms, cells slowly turn into tissues, tissues turn into organs, organs, they set up themselves in some sort of a system. We have different organ systems because of which our body is running smoothly, our metabolism is running smoothly. So cell is the fundamental unit of life. And right from the beginning of, I would say, mid 19th century, 20th century, there has been extensive interest in finding out about this fundamental unit of life, that is cell. Scientists have been working on this. In our previous interactions, we discussed that cells are like the bricks, very similar to how we construct a building using bricks. Our body is made up of different cells, which are nothing but the bricks of this particular body. If you take out a simple onion peel and watch it under the microscope, you will find a structure like this, a very similar to brick structure, like a brick construction. As I told you, during the 19th century, 20th century, there was a lot of interest for finding out more about these cells. Initially, people started to view using the magnifying glasses, simple kind of microscopes. But by 20th century, we developed compound microscopes like this, where a small sample can be kept here and viewed from the eyepiece, and we saw beautiful structures of cells, and we were able to divide and distinguish among different cell organelles. If you look at the discovery of cell, it has seen a very interesting journey. Very earlier, during 1665 itself, Robert Hooke was the first person who found out or observed cells in a cork slice using a very primitive microscope. But for the first time, Anton Leeuwenhoek in 1674, he improved the microscope and discovered living cells in pond water. And for the first time, Robert Brown, he gave the idea of nucleus. In 1831, he observed different cells under the microscope, and he said that every cell has a nucleus, which is like the central processing unit of that cell. The entire cell biology, or the concept of cell, was ultimately given by Schleiden and Schwann in 1830s. So many different kind of scientists have worked over this. Robert Hooke, Leeuwenhoek, there is Purkinje also. Purkinje in 1839, he coined the term protoplasm. Protoplasm for the fluid substance of the cell, that means cytoplasm plus the nucleus. He termed it as protoplasm. You must have heard about Purkinje fibers. We'll talk about that also in future. Why I'm discussing this? Many a time certain factual questions might appear about discovery of cell, discovery of the cell theory, cell biology, Schleiden and Schwann, and it was further expanded by Vichru. So today we have a great knowledge of different kinds of cells. Now, if we look at if you look at categorization or classification of cells, the functional and structural unit of life, we find two kinds of cells. One is a prokaryotic cell. We have discussed about that before also in our 6th, 7th, 8th interaction. Prokaryotic cell and eukaryotic cell. Prokaryotic cells are nothing but primitive cells. Now, whenever I mention about prokaryotic, I want all the UPSC civil services aspirants to remember it by bacteria, because we will be talking about bacteria. We will be talking about bacterial diseases, antibiotics, etc. in our future interaction also. So whenever there is a mention of bacteria, you need to remember that bacteria is a prokaryotic cell. And how do we differentiate between prokaryotic and eukaryotic? By understanding the development of its nucleus. Prokaryotic cells, they do not have a truly developed nucleus. In a eukaryotic cell, we do know that the nucleus is enclosed. If this is the cell, then this is the nucleus, and nucleus has an outer membrane, in fact a double membrane of the nucleus itself. But in prokaryotic cells, this is a classic idea of a bacteria, where you can see, let me just show you this picture, where yes, there is a cell membrane or a cell wall, which is the outer layer. There might be a cell wall also, but if you look at its genetic material, this genetic material is completely spread out through the cell. Whereas if you look at a eukaryotic cell, nucleus is somewhere here and the nuclear material is only enclosed within this particular part. Apart from this, prokaryotic cells, they lack cell organelles. That means there are no advanced cell organelles that are found in a prokaryotic cell. But do remember, prokaryotic cells, they do have ribosomes, special kind of ribosomes. We'll talk about ribosomes in some time. They have ribosomes for protein synthesis. In prokaryotes, you do find ribosomes, but not the other cell organelles. Apart from that, these prokaryotes are generally smaller. In the prokaryote, nucleus or a true nucleus is absent. In eukaryote, it is present. Both are, again, membrane bound organelles are missing. Outer membrane is present. Of course, the cell membrane is present in both. Please try to remember this. Cell membrane in this also, in this also. But the membrane bound organelles are missing. They are absent here. They are present on the other side. Cell structure is mostly unicellular. Apart from that, cell size is rather smaller, about 0.1 to 5 micrometers. The eukaryotic cell is a little larger, and eukaryotic cells are found in animals, plants, fungi, protists, and prokaryotic cells are nothing but bacteria. All right. Now, when we talk about this eukaryotic cell, as I told you, it is more advanced cell, where the nuclear material or the chromosomes or genetic information is enclosed within the nucleus. There are different or complex cell organelles which are present. That is why I told you. Let's take example of humans. I told you that there are billions of cells in our body. We can talk about a nerve cell, we can talk about a fat cell, we can talk about a blood cell, muscle cell, there is sperm, there is ovum. But overall, the structure of these cells can be different. But there would be a cell wall, there would be a nucleus, there would be specialized cell organelles in it. If we look at the cell structure, this is animal cell, this is a plant cell. In our previous interactions, we have discussed there are certain differences between the two and a lot of commonalities for sure. The differences are mainly connected to plastids. The differences are connected to cell wall. The difference is also connected to vacuole. We said plastids are only present in plant cells. Cell wall is present in the plant cell. Vacuole in these plant cells are large. Apart from that, when you look at the other cell organelles in both these, you will find a lot of commonality. You will see that both the cells will have nucleus, both the cells will have mitochondria, both the cells will have your endoplasmic reticulum, they will have your Golgi complex or Golgi apparatus, they will have plasma membrane, they will have ribosomes, they will have lysosomes, they will have mitochondria, and they will have cytoplasm. Yes. So let's talk about these cell organelles which are common to both these, and we'll also talk about some special ones here. That is the agenda for today's class itself. Let's begin. The first thing, cell membrane. Be it plant cell or animal cell, or even for that matter prokaryotic cells, they all have a cell membrane or a plasma membrane, which is the outer covering or the outer coating of the cell. within this cell membrane or plasma membrane, different parts are there. For example, let's say this is nucleus. It is housed inside the cell membrane. This cell membrane is similar to the door of your house, right? I am just giving an analogy, meaning if something has to enter the cell or if something has to exit the cell, it has to pass through the door. It has to pass through the cell membrane. The cell membrane is made up of different proteins and lipids, and it is semi-permeable. That means it is going to allow things to go out. It is going to allow things to come inside the cell. Why? Because our body runs on metabolism. And for metabolism, what we need to do? We need to eat food. The energy has to go or enter this cell. Then whatever cell is going to metabolize, the waste materials are produced, and the waste material has to come out of the cell also. That means it has to be semi-permeable. And how does this help, or how does this occur exactly? The semi-permeable membrane, that is the cell membrane or a plasma membrane, it allows things to pass through it through diffusion or through osmosis. Now, for example, you all know I'm breathing right now. I'm breathing in the air. That means I'm utilizing oxygen. My lungs are now filled with oxygen, and this oxygen, whose concentration is now more in some lung cells, it has to be transferred to other cells. Oxygen, which is high concentration here, it is going to move into the cells where there is low concentration. That means the gas transfer, oxygen and carbon dioxide transfer, it occurs through the concept of diffusion. There can be osmosis also. Diffusion and osmosis are quite related. Diffusion, it occurs when there is no kind of semi-permeable membrane, and gas transfer, it occurs because of diffusion itself. And osmosis is a kind of specialized diffusion which occurs through a semi-permeable membrane, and here solvent transfer takes place. Solvent transfer takes place. Meaning, if my body wants water, when I consume water, the water has to enter the cell, and it has to pass through the cell membrane. It has to pass through the plasma membrane. How does it pass? It passes through osmosis. And that is why we see whenever a cell is put into different kinds of solution, it acts in a different way. For instance, if I put a cell in an isotonic solution means where the amount of solute and amount of solvent both are in some sort of equilibrium. For example, blood. If I put RBC in a blood cell, for that it becomes isotonic solution. Nothing is going to happen. That means the amount of water that is going out of cell and the amount of water that is coming into the cell, it will remain same. For plant cell, yes, it is going to remain flaccid because it will have more and more water in it. But as soon as I put the cell in a hypotonic solution, what is going to happen? Hypotonic solution means the outside environment has more solvent and less of solute. That means the solvent is going to come inside the cell. If it is a plant cell, the water is going to enter it. It is going to become more and more turgid. And if I put a cell in a hypertonic solution means where the solute is more, and in the environment solute is more, solvent is less. That means the water is now going to be lost from the cell, meaning the cell is going to lose water. This is called as plasmolysis. And this process is basically called as ketolysis. Okay, just for your reference, it's called ketolysis, meaning the water is lost if I put a cell in a hypertonic solution and the water is gained in a hypotonic solution. All right. This is the job of your cell membrane or plasma membrane. Now, in plant cells specifically, I told you this is the cell membrane. I'll write it as CM. And outside the cell membrane, especially for plant cells, in fungi also, and in some bacteria, we find something called as cell wall. Now, the cell wall is mainly a means of protection. The cell wall, it is made up of different proteinaceous materials. It is made up of proteins and lipids, predominantly proteins itself. It protects the cell from mechanical damage and different kind of infections. It acts as a barrier. As I told you, if I put a cell in a hypotonic solution or in a hypertonic solution, it has to protect itself. How does it protect? It protects itself through the concept of cell wall. And please remember, cell wall is absent in the animal cell. It is present in plants, it is present in many fungi, it is present in many bacteria as well. Its main job is to protect the cell. You can see here the cell walls, it helps the cell to withstand very dilute hypotonic external media without bursting. If it is a very low hypotonic solution, there is a possibility the cell might burst. It will become turgid, more and more water, and eventually it might burst. Now, to protect itself, there is cell wall, and that is why you must have seen many of the bacteria, they can survive extreme conditions. Acidophiles, thermophiles, they can survive extreme conditions also, right? Cell wall. Cell wall also helps in regulating the osmosis. It maintains the osmotic pressure. Apart from this, every cell has something called as cytoplasm. Now, this is the cell membrane. This is the nucleus. This is the common drawing I'll be drawing it while explaining. Then there is cytoplasm, some jelly-like fluid inside the cell. This blue jelly-like fluid inside the cell, it is called as cytoplasm, right? Now, the job of cytoplasm is to house these specialized cell organelles and to maintain the fluidity. It is a jelly-like substance which consists of different salts, waters, and other organic molecules. It helps in survival of the cell. All right. So we discussed about cell membrane, cell wall, cytoplasm. Let's move on and talk about the central processing unit of the cell, which is nucleus. I told you, if this is cell membrane, the nucleus is enclosed. All right. The nucleus has double membranes. It has two membranes, and you will find genetic information in this, both in plants and animal cells. The nucleus is like the control center of any cell. Any activity by the cell, it is going to be controlled by the nucleus itself. The nucleus has a small nucleolus in it. It has two layers. It has two membranes, and that is the difference between eukaryote and prokaryote. In prokaryote, you will not find these membranes. There is a double membrane, and this membrane, it also allows movement of information, movement of material. This nucleolus contains your genetic information. The job of the nucleus is to house something called as chromosomes, or if the cell is not dividing, condensed form of chromosomes in form of chromatin or in form of thin wires is found. Whenever the cell is dividing, this chromatin, it divides. And these chromosomes, they are nothing but the information carriers of our genes. They are information of our inheritance. And protoplasm, the term protoplasm basically refers to the fluidic part of the cell. Cytoplasm plus the nucleus, it is called as protoplasm. Purkinje give this name. Nucleus is the main center of the cell. For example, if there is any activity, if the cell has to grow, if the cell has to divide, the nucleus is going to send it information that it's the time for dividing. Favorable conditions have reached, and the cell is going to divide from 1 into 2. That information is found here. All right. Apart from this, cell also has specialized organelles called as endoplasmic reticulum. Now, this is the cell membrane, this is the nucleus. Very close to nucleus, we find different kinds of endoplasmic reticulum, which is like a communicating link between the nucleus and the other cell organelles. The nucleus has DNA. DNA communicates with the entire cell. How DNA communicates? Through this endoplasmic reticulum. This sends information for protein production to ribosomes and other cell organelles. So endoplasmic reticulum is a large network of bound tubes. Let me just show you the image where you can just look at this particular picture of the animal cell, and you will see there are two kinds of endoplasmic reticulum: smooth endoplasmic reticulum and rough endoplasmic reticulum, just connected to nucleus, both of them. All right. Right. So endoplasmic reticulum, its job is to ensure that it provides some sort of a skeletal framework to the cell. It provides stability to the cell. So it has different membrane bound tubes or sheets. There are two kinds of endoplasmic reticulum we find in a cell: smooth endoplasmic reticulum and rough endoplasmic reticulum. Take the pen here: smooth endoplasmic reticulum and rough endoplasmic reticulum. Now there is a difference among these two. Whenever I say endoplasmic reticulum, two kinds of ER can be found out. First one, smooth. Whenever I say smooth, there are no ribosomes present on this endoplasmic reticulum. But when I say rough endoplasmic reticulum, ribosomes are attached to it. Now, what are these ribosomes? See, these ribosomes are very important cell organelles in both plant and animal cells. It can also be found in prokaryotic cells, specialized ribosomes. Their job is to produce specific kind of proteins. And where do we get information for this? The DNA is going to send information to ribosome through the endoplasmic reticulum itself that this protein has to be produced. And you do know protein is extremely important for our body. Whenever I say human body is composed of water, yes, but when I talk about the next constituent, it is going to be protein itself. Protein is found in your muscles. Protein is found as chemicals. Your hormones are proteins. Protein is present in your blood, the globin protein. So protein is very important for us. Protein synthesis through ribosomes, and these ribosomes are attached on the rough endoplasmic reticulum. We can see them in the microscope, and these are, again, rough endoplasmic reticulums are the sites of manufacturing proteins. The smooth endoplasmic reticulum, it helps in production of fat molecules. It helps in production of fat molecules or lipids. Some of the proteins and lipids, they help in building of the different membranes that we saw, cell membrane, plasma membrane, etc. Some other proteins and lipids that are produced by endoplasmic reticulum, they also act as enzymes and hormones. And as I told you, endoplasmic reticulum, it helps in production and utilization of both proteins and lipids. It also helps in production of enzymes and hormones, which are needed for the cell for metabolism. Also, it serves as a channel for transport of materials. It also provides stability to the cell by giving it some sort of skeletal framework. Apart from endoplasmic reticulum, there is one more very important organelle called as Golgi complex or Golgi apparatus. You will see that endoplasmic reticulum is many a times connected to these Golgi apparatus. Golgi apparatus, they are a means of communication. If say endoplasmic reticulum is like a messaging unit from nucleus, it takes all the messages. Golgi apparatus or Golgi complex is a means of taking all this communication to other organelles of the cell. The name Golgi apparatus, it comes from a scientist, Camillo Golgi. Can you guess Camillo Golgi was from which country? Just take a guess and let me know in the comment section. Okay, so Golgi apparatus is again a bound organelle of eukaryotic cell. It consists of stacked pouches called cisternae, and these cisternae, they are basically means of transportation, modifying and packaging different proteins and lipids throughout the cell. They are a means of transportation and packaging. So Golgi apparatus, again located next to the endoplasmic reticulum, they are a means of communication. Yes, there are several kinds of Golgi apparatus. Plant cell can contain hundreds of Golgi apparatus. In many cases, complex sugars are made simple in some Golgi complexes. Some Golgi apparatus and complexes are also useful in production of lysosomes. So what are these lysosomes? Lysosomes are basically the waste disposal system of a cell. Lysosomes are responsible for production of certain kinds of enzyme which help in waste disposal or digestion. Digestion or digestive enzymes are developed and they are capable of breaking down the organic material. Many a times when a cell itself has lost its utility, that cell also has to be dissolved, or the cell also has to burn down, and for that lysosome produces huge amount of enzymes so that cell itself it digests or it disintegrates, it decomposes. That is why many times lysosomes are called as the suicide bags of the cell. Apart from this, there is one more important organelle called as mitochondria. Mitochondria is called powerhouse of the cell. This is where the cellular respiration takes place. It is a place of cellular respiration. Now you all know that every day we have food, and when we have food we consume carbohydrates, proteins and lipids. These carbohydrates, proteins, and lipids, how can they be utilized? They have to be turned into a common parameter which our body can use. And that common parameter or that common currency of our body is ATP, adenosine triphosphate, which is produced by the mitochondria. This mitochondria is going to use chemicals, right? Basic chemicals. That means the saccharides, the amino acids, or the fatty acids that we consume, carbohydrates, fats, lipids. It uses oxygen in the reaction. Then it is going to produce adenosine triphosphate. Mitochondria, they have two membranes. The outer membrane is basically the membrane of mitochondrial organelle, but the inner membrane is highly folded. If you look at this inner membrane, it is highly folded. Why? Because the reaction has to take place. The Krebs cycle has to take place here, and ATP has to be produced. And for that, chemicals are utilized, oxygen is utilized, and ATP is produced here. So mitochondria, it produces the ATP, which is called as the energy currency of our body. And mitochondria, please remember this, it contains or it carries its own DNA information. You can see here, when I just look at this particular mitochondria, it has its own ribosomes. It also has its own DNA. It also has its own DNA. You can see mitochondria, it has its own DNA and ribosomes, right? In our future interactions, when we talk about biotechnology, we'll talk about mitochondrial diseases. We'll talk about issues connected to mitochondria. Please remember, mitochondria has its own ribosomes for protein synthesis. It has its own DNA information also. Apart from mitochondria, plastids are another important cell organelles specifically present in plant cells. Now, plastids are basically colored pigments or colored bodies in the plant cells which help them in photosynthesis or some other specific operation. One particular plastid, green color plastid, it is called as chloroplast. It contains chlorophyll. It contains huge amount of magnesium, which helps in photosynthesis in plant. That is why plants are called autotrophs, because they can undergo photosynthesis, they can produce their own foods. But please remember, plants do not contain only one kind of plastid called as chloroplast. They can also contain different kinds of plastids like leucoplasts, like amyloplasts, etc. From a perspective of plant body or plant cell, these plastids or chlorophyll, it can be considered similar to mitochondria because they are the areas of photosynthesis. They produce food. All right. Plastids specific to plant cells. Apart from this, there is an organelle called vacuole also. And in plant cell, if this is the plant cell, vacuole is generally very big. These vacuoles are storage spaces. These vacuoles are storage spaces. Why do they use? You can see the root word here also, vac. The root word is vacuum. These are storage spaces. What do they store? Please remember, vacuoles can store anything. Vacuoles can store gas, vacuoles can store water, vacuoles can store nutrients, vacuoles can store even waste material. Very important pointer here. Vacuoles in the plant cells are bigger in size because the requirement of plant is more. It can store water, it can help in gas transfer, CO2 and oxygen transfer for plant. It can also store waste material. In plant cells, the vacuoles occupy about 50 to 90% by volume itself. Clear? Right. So there are vacuoles also. Apart from this, whenever we talk about cells, we do know that cells divide. Now you can see that I met with a small accident and there is a small cut here on which I have applied the band-aid. Now what is going to happen? Today you might see a small amount of scar or small amount of injury there, but maybe after 8 days, maybe 10 days, when I remove this band-aid, you will not see anything. I would be healed. Why does this happen? Because cell undergoes division, and the eukaryotic cell, it undergoes two kinds of division. One is the normal mitosis. Now this applies to all the eukaryotic cells which are not gametes. Please remember, mitosis, it applies to all the somatic cells. What is this mitosis? Mitosis is a process of cell division where you will find that the cell undergoes different kinds of phases. We'll talk about these phases in our subsequent interactions. But when I talk about mitosis, the first phase is called as interphase, where the chromatin or chromosome is duplicated. All the chromosomes are duplicated. Then it undergoes 4 different phases: PMAT, that is prophase, metaphase, anaphase, and telophase. Undergoing these phases, ultimately one cell, it divides into two daughter cells, and it is because of this it will be healed. So mitosis is a division of somatic cells which is responsible for our growth, which is responsible for healing. The significant contribution of mitosis is cell repair. Our body constantly loses cells, our body constantly needs cells, right? And for that, the cell has to undergo mitotic division. Mitosis leads to division of a cell into 2 diploid daughter cells, meaning there is no change in the chromosomal information. Please note here that the cell where it has started, imagine if I talk about human cell, it has 23 pairs of chromosomes, correct? It has 23 pairs of chromosomes. That means totally 46 chromosomes. In mitosis, when this cell divides and 2 different cells are created, meaning these 2 cells will have 23 pairs of chromosomes. They are going to have completely 46 chromosomes. It's not half. That is why it's a diploid daughter cell. 2 diploid daughter cells are produced. There is another kind of cell division in cells in sexual animals, or especially with the gametes. It's called as meiosis. Meiosis is a specialized kind of cell division where a cell divides into haploid daughter cells where the chromosomes are halved. In organisms which undergo sexual reproduction, a gamete or a set of chromosome comes from one parent, another set of chromosome comes from another parent. The 2 are going to fuse, form zygote. Then the organism which is born, the offspring, it is going to have complete set of chromosomes. It happens through the process of meiosis. Now meiosis takes place through 2 kinds of division, where a single diploid cell, that means where you have 46 chromosomes, this particular cell, it divides into 4 cells which are haploid. 4 cells which are haploid. That means these 4 cells are going to have 23 chromosomes each, half the chromosomes than the parent cell. And this is responsible mainly for inheritance, meaning in our body there should be constant genetic information or inheritance based information. Half set of chromosomes come from father side, half set of chromosomes come from the mother side, and an offspring or the next generation individual, they will have complete set of chromosomes, half from one side, half from the other side. Now this happens because of meiosis. Now please remember that mitosis and meiosis, mitosis occurs in somatic cell where DNA replication takes place in interphase. We'll talk about these phases in our subsequent discussion, subsequent classes, right? Meiosis, it takes place through 2 kinds of division, where ultimately the result of daughter cells that are produced. For mitosis, it produces 2 diploid cells. For meiosis, it produces 4 haploid cells. Let me explain it clearly again. In mitosis, please remember, in mitosis, you will see that complete set of chromosomes can be seen here in the 2 daughter cells. Complete set of chromosomes. But when you talk about meiosis, you will see that 4 haploid cells are produced where only half the chromosomes are transferred. These half chromosomes will join with the other half coming from the other counterpart. That is half from father, half from mother. Please remember this cell division process, because this is the base of our biology knowledge, and we are going to understand more and more about these things in our subsequent discussions, because biology is very important for us. A lot of questions do appear from this. All right, so this was about the fundamental unit of life, that is the cell organelles and cell division, mitosis and meiosis. Let's begin our discussion. As I told you, our interaction today is about tissues. In our previous discussions in class 6, 7, 8 and now also in 9th, we have understood the fundamental and the structural unit of life is cell. And I told you, for unicellular organisms, a single cell represents entire life. But for multicellular organisms, they are composed of group of cells. Our body is made up of billions of cells. And when these cells or some cells, they combine to perform some sort of a specific function, we call it tissue. Now, this is the basic organization of a multicellular organism. When we talk about plants or animals, different cells, they combine to perform some specific task or some specialization. We call them tissue. Tissues move into an advanced structure called as organ, and then these organs, they make our entire organ system, that is human body. And in our previous lectures, when we discussed in 7th standard, 8th standard, we spoke about some organ systems. We discussed about digestive system, circulatory system. Those are all made up of different organs. So this is the organization or levels of organization. From a cell, we move towards a tissue. From tissue, we move towards organ, and organ in a system, it runs your metabolic system or metabolic activity. For humans, there are different kinds of systems. For plants, there are different kinds of systems. Plants undergo photosynthesis. Now, we perform different metabolic activities. So, today's discussion is about this particular stage, tissue. First things first, what is the meaning of tissue? As I told you, cell is a structural and a functional unit of life. Here, discussion is connected to multicellular organisms. Different cells, when they perform one specific function together, it is called as a tissue. You can see here the definition: a group of cells that are similar in structure and work together to achieve a particular function in a multicellular organism, that is called as a tissue. For instance, our skin. Skin is a kind of a tissue. Skin is composed of millions of cells. That is why I find a layer, and this layer performs certain specific functions. It is some kind of an innate immunity model in our body, meaning it does not allow external particulate matter or external stuff to enter into our body. It helps in secretion. It acts as sweat gland. Basically, sweat glands release sweat. Right now, I'm sweating a little. The sweat here is coming through the skin itself, through the pores. So, cells combine to form a tissue to perform specific function. Tissues together, they become organ, and then our body runs as an organ system, a composition of different organ systems. Right? That's the basic idea of tissue. Now, the question is, do multicellular organisms, when I talk about multicellular, we will focus on plants and animals. Of course, when we talk about bacteria or any other unicellular organisms, they do not have these complexities like tissues. Yes, we might find them in a colony. For example, fungi are found in a colony. Bacteria can also be found in colonies, but very seldom do we find them as multicellular organisms or multicellular entities. That is why our discussion is connected to plants and animals. The question here is, when I said tissue, do I find similar kind of tissues in plants and animals? Of course not, right? Why? Because the characteristics of these two organisms is completely different. You know, plants are stationary. You know, plants are autotrophs. Animals are not stationary. Animals are mobile, and animals are heterotrophs. They look or search for food. So their tissue structure is also based on these characteristics. That's why when we look at a plant tissue is organized in such a way that it helps towards the stationary habit of plants. Meaning, the tissue is not going to help the plant in movement. For instance, in our body right now, I'm moving. I'm doing some sort of gestures. Why? Because I have muscles. Muscles always work in a pair and they help in my mobility. But I do not find muscular tissue in plants. I do find muscular tissue in humans, animals, yes. But muscular tissue are not required in a plant. So in a plant, we find tissues which strengthen or which help in this stationary habit. For animals, they work for mobility. For example, muscular tissues. And that is why the organization of plant is rather simple. The tissues that we find in plants are again simple. More complex kind of tissues are found in animals. And when we look at plants, since they are stationary, they need protection. They need protection from wind, they need protection from other environmental factors. And that is why their tissues are, many of their tissues are dead. For example, the bark on the tree. You must have seen that the bark on the stem of a tree is very hard. Those are composed of dead tissues. That means dead cell, they make up dead tissues for protection. The same thing does not apply to animals. In animals, most of the tissues are living. Yes, some of the tissues, they might not have life. Yes, some of the tissues may be dead, some of the cells may be dead, some of the cells may be simply proteinaceous or some sort of chemicals, but majority of the tissues are living. Apart from that, in plant, the tissues are responsible for growth, and growth is confined in certain areas. But in animals, it is not the case. The growth is not limited only to some areas. And also, please remember, the tissues in plant, they grow continuously throughout their lifetime. They continuously grow. But in humans, in animals, it is not the case. As soon as maturity level is reached, cell division slows down. The tissues, they do not grow. In fact, the tissues, they start to deteriorate or degenerate, right? We see a lot of degenerative development, especially in the spinal cord, when we enter the older age, or in elderly people, we see a lot of degenerative related diseases. Why? Because the growth is not continuous. Apart from that, you do understand, since the plant tissue, it helps in stationary habits, energy required for maintenance of these tissues is rather low. And for humans, for animals, the energy required for maintenance of these tissues is quite higher. That's the basic difference. And today's interaction is about understanding these plant tissues, which help a plant in growing, which help a plant in maintaining that stationary growth. Let's talk about different plant tissues today. What are the kinds of plant tissues that I find? See, this is the classification of plant tissues. We broadly classify them into two categories: meristematic tissue and permanent tissue. Now, meristematic tissue itself, when it matures, it becomes permanent tissue. Meristematic tissue is responsible for growth, and meristematic tissue is further divided into three different categories. There are two written here: apical and lateral, but there is also intercalary meristem. We'll talk about that. Apart from that, permanent tissue are further divided into simple permanent tissue and complex permanent tissue. Complex permanent tissue, they help in transportation of material. We know plants are autotrophs. They need water, they need minerals, they need oxygen. So transporting of material, it happens through complex permanent tissues. Whereas growth and other photosynthetic activity, it happens mostly through simple permanent tissue. So this is the basic characterization. It will help you to remember from exam perspective. Now, let's enter into the tissues, plant tissues, one by one. We'll first talk about meristematic tissue. Now, this is a typical meristematic tissue where we find three categorization. I told you meristematic tissues are found in three places. One is at the apex as well as the bottom, that is at the zenith also, at the nadir also. That means at the top it will help grow, and at the bottom also you will see apical meristem. It will help the roots to grow so that they search for water and minerals. So apical meristem is normally found at the apex on either side. This helps in growth. This helps in lengthening of the plant. Apart from apical meristem, we also find intercalary meristem. Now, intercalary meristem is generally found at nodes. Now, you already know, if I draw a simple kind of plant, you will find they have roots, they have stem, they also have different kind of branches, and they have leaves, correct? So, at these internodes, wherever branches are spreading out, wherever leaves are spreading out, wherever fruits are developing, at these internodes, I find intercalary meristem. And there is lateral meristem, which helps in broadening or development of the stem. So there are three kinds of meristematic tissues which are extremely important for growth of a plant, and this you will see continuous development of these tissues. So cells will be continuously added to this, tissues will be developing, and the plant grows eventually into a tree. A tree also continuously grows. What is the difference between these three? As I told you, apical meristem, it is actively located at the tips or at the apex. Now, tips we find at the top also, at the bottom also. That means at the top and at the roots. Both the sides, growth is going to take place. The intercalary meristem, it helps in dividing cells, especially at the internodes. Internodes means at the leaves, at the branches, at the bases of the leaves, at the bases of the branches, etc. Say, for example, tendrils, so thorns, etc. There you will find intercalary meristem. And the lateral meristem, it helps in lateral development of the plant. That means it is going to help in the development or transition from roots to stem. You will find mostly lateral development of stem and the roots. So please remember that the lateral meristem is found in roots also, all the three kinds of meristems. Similarly, in root also, in shoots also, because you know in root system also there are different hairs that go in search of water. So these kind of meristems, they eventually help in initial growth of the plant. So the apical meristem, it aids in height. The lateral meristem, it helps in widening. That means it helps in increasing the girth. And the intercalary meristem, it helps in growth of the internodes. It helps in development of leaves. It helps in development of branches. It helps in development of different nodes connected to the plant. So this is meristematic tissue. Apart from this, we also find epidermis in plants. Now, epidermis is like the outer coating or outer layer of a plant. It's like the skin of the plant. Mostly, classic example can be found out from your leaves, but epidermis is found almost everywhere. If I take a cross section of a stem, you can see here the outer layer is cuticle, which is basically a composition of dead cells for protection of plant. But as soon as I enter the next layer, this is the epidermis. I can simply give an analogy that epidermis is like the skin of the plant. Now, when I enter a little inside, when I do a cross section and I'm reaching towards the middle, I find different kinds of tissues. Now you will see epidermis, then you will see simple permanent tissue, then in the middle you will see complex permanent tissues. You can see some of the examples: collenchyma, parenchyma, phloem, xylem. We'll talk about all these, but right now we'll discuss about this epidermis. Now, epidermis, what is the help of this, or why is it needed? Epidermis is the outermost layer of plant cells. It is found out on stem also, on leaves also. Classically, we'll take example of leaves and we'll talk about epidermis from the perspective of leaves. Epidermis is usually a single layer, is usually a single layer. Sometimes it can be two layers also. This is a classical leaf. Now, I told you on the leaf, the outer protective layer is called as cuticle, right? Now, as soon as we enter inside, we will find just below the cuticle epidermis. Many times leaves can have upper epidermis and lower epidermis, and within these you will find the mesophyll cells. Mesophyll cells have chloroplasts in it, which basically help in photosynthesis. You do know C3 photosynthesis, C4 photosynthesis, they take place in mesophyll. Why? Because mesophyll has chloroplast in it, and chloroplast contains chlorophyll, which aids in photosynthesis. Although it's written here, many a times epidermis is usually a single layer, but it can differ. In leaves, you can see different layers also: upper epidermis, lower epidermis. Then in between, you can also find mesophyll cells. Along with it, epidermal cells can also be found on roots. Now, in roots, they have a typical function. In roots, they have a function. They have a development. They bear long hair-like structure on the root, so that the root seeks water. If the root is seeking water, the hair or the epidermis is going to increase the surface area on the root, so that more and more water and more minerals are caught by the plant roots. All right. Now, epidermis basically protects against water loss. I gave you example here from the leaves, and if you look at the leaf, you know the epidermis's job are multiple. Its functions are multiple. First of all, it tries to protect the plant from water loss. It also regulates in the gas exchange. We know for photosynthesis, plant requires carbon dioxide. It releases oxygen. That means gas exchange has to take place. And for that gas exchange, epidermis helps. It also helps in secreting certain metabolic compounds. And in roots, especially, it helps in absorbing water and mineral nutrients. It also helps many plant roots to excrete also. And we see that there are a lot of adaptations that happen in the epidermis depending on the environment in which the plant is developing. For example, in a forest area, we do have epidermal cells on the plant leaves, especially having some sort of a waxy or a water resistant layer on the outer surface. You must have observed this. Now, next time when you look at a plant, a tree, simply take a leaf and you will see a waxy layer on that leaf. Why is it? To protect it from water loss by excessive transpiration, to also protect it from different insects, to also protect it from different microbes. All right, so it basically protects from parasitic fungi, from mechanical injury to the leaf also. And since epidermis are tissues which are made up of cells, you will very seldom find that there is any sort of intercellular spaces. There are no intercellular spaces in the epidermis. It is very closely attached. When we go to a desert, we call them xerophytes. In xerophytes, plants which live in very dry habitats, what happens is the epidermis, it develops a very thick waxy coating. This kind of waxy coating is found on almost all the plants, but in deserts, very thick waxy coating is found out of cutin. Now, this is responsible again to reduce the transpiration losses. In many aquatic plants or hydrophytes, we call them, in hydrophytes, we find some sort of a different development in epidermis. Now, when we look at epidermis, this is the epidermal layer, upper epidermal layer, lower epidermal layer. In between, you can find mesophyll cells, and below that you will find stomata or stoma. Now, this helps in gas exchange. This is the entire layer of epidermis itself, upper, lower epidermis, and you do have the stomata. All right. Now, when you look at the hydrophytes, you will find in hydrophytes, stomata are on the opposite side. Why? Because they are submerged in water itself. For gas exchange, the stomata would be present on, more and more stomata would be present on the upper side. Apart from that, epidermis also harbors the stomata cells. The stomata cells are called as guard cells. If you do a cross section of a leaf, you will find in the epidermal layer itself, you will find a pair of cells, something like this, bean shaped or kidney shaped, right? Two bean shaped paired cells are found. These cells are called guard cells. Now, these guard cells together, they form stomata, and stomata is responsible for transfer of water. That is, transpiration happens through the stomata itself. Gas exchange happens through the stomata itself, meaning the plant takes in carbon dioxide via stomata, it leaves oxygen via stomata, it also leaves excess water through transmission by stomata. That means the epidermis is also responsible for maintaining the stomatal functions. And as I told you, depending on the environment, depending on the ecosystem, the stomata in most of the desert plants, they remain closed during the daytime because they do not want to lose the water. Whereas in hydrophytes, stomata is always open because the water availability is very, very high. So based on the ecosystem, you can find the adaptation of epidermis in different kinds of plants. All right. So this is about the meristematic tissue. Meristematic tissue, we discussed apical, intercalary, lateral, and we discussed about epidermis. Let's move on towards the permanent tissues. Now, I told you in permanent tissue, we find two kinds of categorization. Permanent tissue are of two types. One is simple permanent tissue, the other one is complex permanent tissue. Now, what is the meaning, first of all, of this permanent tissue? Please remember, permanent tissue are tissues wherein the cells, they lose the ability to further divide. That means they are mature kind of cells or a combination of mature cells that lose the ability of further division. They are permanent. They have some specific function which they keep on performing, and many, especially the complex permanent tissues, they are composed of dead tissues itself. And that is why you need to understand, when I talk about permanent tissues, where do they come from? They actually come from meristematic tissue itself. As the plant matures, as the plant develops, many meristematic tissues, they transform into permanent tissues. Permanent tissues, simple and complex. Let's first talk about simple permanent tissues. Now, simple permanent tissues are of three types. You might find these words a little complicated, but I hope you will remember these. There are three simple permanent tissues: parenchyma, collenchyma, and sclerenchyma. Now, to remember these, whenever you go out next time, when you watch a tree, try to find out or try to categorize the tissues or cells by looking at them, right? So parenchyma, collenchyma, and sclerenchyma. The structure of these tissues is something like this. In the parenchyma tissue, there are a lot of intercellular spaces. In the collenchyma tissue, there are seldom any kind of spaces. They are very tightly bound, and mostly they are arranged in a cylindrical form. Both parenchyma and collenchyma, they are mostly in form of cylindrical structure or cylindrical form itself, but try to realize that there are a lot of intercellular spaces in the parenchyma tissue, but in collenchyma they are a little less. And sclerenchyma, please remember, when I say sclerenchyma, they are nothing but tightly bound dead tissues of the plant. Let's look at some more details of this. When I talk about parenchyma, I told you parenchyma tissue is made up of living cells. Remember, this is made up of living cells. They may vary from plant to plant, right? Depending on the morphology and physiology of the plant, the parenchyma may vary. For example, in hydrophytes, we find parenchyma a lot as erenchyma. Why? Because in these tissues or in these cells, a lot of air is held. Why? Because I want the plant to be floating over the water. Similarly, in many of the plants, parenchyma, it appears as chlorenchyma, meaning these parenchyma tissues or parenchyma cells, they will be having chloroplast, and once they have chloroplast, that means there is chlorophyll in it. They help in photosynthesis. So the job of parenchyma cells is varied depending on the plants, but they act as a means of storage of food and water, many times storage of even gases, especially in the hydrophytes. Parenchyma cells, living cells, erenchyma, chlorenchyma, the categorization of that. Apart from that, we have collenchyma. Now collenchyma are mostly living cells, photosynthetic cells. They have protoplasts in them, and if you look at them or if you look at them in the microscope, you will find them more in the cylindrical form, and they help in the growth. They help in the growth of height of the plant. Collenchyma tissues can be seen mostly in young stems, and in these young stems, many of the collenchyma cells, they have chloroplast in them. They do undergo photosynthesis. All right. And please remember, the difference between parenchyma cells and collenchyma is that in collenchyma, they do not have too much of intercellular space in them. These collenchyma cells, they also provide a lot of assistance to young herbaceous parts of the plant. When the plant is very young in the herb form, then collenchyma cells are more and more, it provides stability to it. And as the tissues mature, as the growth takes place, we reach into sclerenchyma. Sclerenchyma tissues are more mature, and please remember, they have secondary cell walls which are very usually thick and composed of lignin. And most of the sclerenchyma cells, they are non-living or dead cells. So that is why sclerenchyma are non-living dead tissues. They can be in form of fibers, they can be in form of sclerids, or they can be in form of trachea, that means vessels. We'll discuss about these also when we move into the complex permanent tissue. Sclerenchyma fibers can be seen especially in composition of xylem itself. These sclerids are normally found, when you take a seed, is there an outer coating outside it? Yes, to protect the seed. It is mostly made up of these sclerenchyma tissues or sclerenchyma cells. Most of the seed coats or fibers, or you can give example of coconut. On coconut there are a lot of fibers, and most of those fibers are dried sclerenchyma fibers. So sclerenchyma, dead cells, fibers, sclerids, or vessels. Vessels meaning long tubular structures can be formed, and when these tubular structures are formed on both the sides, these are dead cells. These are dead cells or dead tissues, sclerenchyma, which help in transport. They may form these trachea, or they may form these pipe-like structures for both xylem and phloem. Now let's look at the differences. As I told you, parenchyma, please remember, they are the soft part in the plant. Sclerenchyma, they are the mature hard part, mostly dead. Remember, parenchyma are non-specialized, unspecialized cells, whereas collenchyma are specialized cells, living cells. Both of these, they are living cells. If you look at these specializations, sclerenchyma is for protection. Collenchyma, there are a lot of chloroplasts in it. That means it helps in stability, it helps in photosynthesis as well. They consist of very thin wall. The parenchyma has very thin wall and a lot of intercellular spaces. The collenchyma usually has thin cell wall, but sclerenchyma has thick and a rigid cell wall, and it is made up of dead cells, dead tissue. You will find a lot of lignin in it, whereas in parenchyma the cell wall is made up of a lot of cellulose. Apart from this, when you look at function wise, parenchyma has intercellular space in it. Collenchyma has no or very little space, cylindrical shape, stacked together kind of tissues or cells. And here also there is no intercellular space. But please note, parenchyma is living, collenchyma is living, but sclerenchyma, it consists of dead cell when they reach maturity. And the job of all the three is different. The parenchyma cells, it helps in photosynthesis, it helps in storage. The examples I gave you, erenchyma, chlorenchyma. The collenchyma, they provide mechanical support. In many of the plants, they also undergo photosynthesis. They also help in stretching or growth of the plant. Whereas sclerenchyma, they help in providing mechanical support and they help in transportation. Why? Because they provide protection to the seeds, they provide protection to the fruits, they set up trachea. That means they create hollow pipe like structures for transportation of material in the plant. The mature sclerenchyma. So these are the three kinds of simple permanent tissue. I'll repeat: parenchyma, collenchyma and sclerenchyma. Now let's move on to complex permanent tissue. Now this is more simpler, right? Simpler in the sense, just from the point of view of remembering, because from school days we do know xylem is a pipe which carries water for the plants, phloem food and water, food and other minerals. Yes, so complex permanent tissues are two kinds. One is xylem vessel, the other one is phloem vessel. You do know xylem is a one-way traffic of water, and one-way traffic of water plus the minerals that are absorbed by the plant roots. Whereas phloem is a two-way transport of everything, two-way transport of water, food, storage, mineral, gases, everything. It's a two-way transport of water and nutrients. You can see water and food are transferred through phloem. Now let's talk about these complex permanent tissues of xylem and phloem one by one. First one, complex permanent tissue, xylem. Its main function is what? Its main function is to transport water. From roots, it has to reach to the tip of the leaves. Many a times trees can be almost 50, 60, 100 meters height, and it has to reach from the ground level to the top level. So xylem, it transports water. It also transports the minerals that are required for a plant, right? Nitrogen is needed, phosphorus is needed, the other nutrients are needed. So these minerals are taken through the xylem and they are provided in all the leaves or all the parts of the plant. Xylem basically is composed of three different kinds of structures of cell. Xylem tracheids, you must have seen tracheids in sclerenchyma. Xylem vessels, again trachea of sclerenchyma, and xylem parenchyma. All right, so xylem, it consists of three constituents: xylem tracheid, xylem vessel and xylem parenchyma. When we look at the functions of these three, xylem tracheids, as I told you, they are lignified. That means dead cells which form a kind of a conduit. So these are lignified and dead cells which with a bordered pits, so that water and other nutrients can pass through. Since these are tracheids, these are fiber kind of structures, they help in stability of the plant as well. Apart from that, there are xylem vessels. Now these are the sclerenchyma trachea, the mature trachea, xylem trachea. They are long, tubular, again lignified cell wall. It's like a pipe, and at the end of these there are pipe like projections or pipe like opening. And in most of the angiosperms, that means flower bearing plants, we do find these xylem vessels. They are like openings. They have pits also, so that water can be released everywhere. They also have openings at the ends. Apart from that, there is xylem parenchyma. Now, as by the name itself, you do understand parenchyma are loosely, or there is a lot of intercellular space in these parenchyma cells or parenchyma tissue. And for xylem also, yes, these are made up of living cells. Now, why are they made up of living cells? Because xylem also needs food and water. That means xylem as a tissue, yes, it may be composed of a lot of vessels, tracheids, but xylem also needs, we find a primary xylem and secondary xylem based on the maturity. We'll talk about these in our subsequent classes when we reach class 10, etc. But xylem also needs food and xylem also needs water. That is provided by the xylem parenchyma. All right. So xylem, water and mineral transport. Another complex permanent tissue is phloem. Phloem is responsible for transport of food, transport of water, transport of nutrients, transport of everything actually. So phloem is composed of different kinds of structures or different kinds of entities like sieve tube. You can see a phloem. Phloem has phloem parenchyma. By now you must have guessed what is the job of phloem parenchyma. I hope. There are sieve tubes, there is a sieve plate and different companion cells to it. A xylem is composed of sieve tubes, companion cells, fibers or xylem tracheids, then phloem tracheids and phloem parenchyma. Now, what is the job of these sieve tubes? By the name itself, you can see these are living, but they do not have nucleus at the maturity. Slowly and steadily, nucleus disappears. They are more like a conduit. They are composed of cellulose, which help in transport of water and food. They help in conduction mainly of food material, sieve tubes. And at the end of each sieve tube, there is a sieve plate. That means the food material has to pass from one sieve tube to another sieve tube. Apart from that, there are companion cells. Please remember, companion cells are living cells. These are living cells. They are thin-walled. In many of the gymnosperms, these things are not present. And along with sieve tubes and sieve plates, companion cells, they help in transport of food material. Apart from that, there are phloem fibers. Phloem fibers are also called as bast fibers. Now, these are mostly dead cells or thick-walled cells which provide mechanical support to the plant, mechanical support to the phloem as well. And finally, there is phloem parenchyma. By now, you must have understood what is the job of phloem parenchyma. Phloem itself needs food products, and food and water is supplied to phloem by phloem parenchyma. It also it stores a lot of products like mucilage, tannins, and resins. All right. So this is about the complex permanent tissue. I hope that you have gotten the clear-cut idea. Let me just give you a small summary kind of a discussion. Plant tissues are divided into meristematic tissue and your permanent tissues. Meristematic tissue itself transform into, or they develop into, permanent tissues with the growth of the plant. Meristematic tissues are responsible for the growth. You find apical meristem at the apex or at the tip. I can say at the tip. These are responsible for growth. There is lateral meristem, which is responsible for growth of stem. That means widening of the stem. Apart from this, there is one more meristematic tissue. It is called as intercalary, and this is normally found at the different nodes, the development of leaves and branches. On the other side, you have permanent tissues. Now, permanent tissues are further divided into simple ones and complex ones. Simple ones, parenchyma, collenchyma, and sclerenchyma. Parenchyma and collenchyma both are composed of living cells or living tissues. Both help in photosynthesis. Sclerenchyma is mostly composed of dead cells. They provide stability or structure to the plant. Apart from that, there are complex permanent tissues, xylem and phloem. Xylem is for water transport. It is one way, water and mineral transport. Phloem is for food and other transport. It is a two-way transport mechanism throughout the plant. It transfers the products that are developed by the photosynthesis. When photosynthesis occurs, the nutrients are used, the energy is transferred, or the food is transferred throughout the plant through the vessel called as phloem. It is a complex permanent tissue. Clear? Right. So this is the first part of our discussion. In our subsequent lecture, we'll talk about animal tissues. That's the end of today's discussion. As I told you, our discussion is about tissues. We have discussed this in our previous interaction also. I told you different kinds of cells, when they club together for some sort of a specialized function, they become tissues. Different tissues, they ultimately then lead up to organ, and our body is made up of organ system. Our entire body is organ system. All right. And we also discussed about the differences between tissues, plant tissue and animal tissue. And I told you plant tissues are not very complex, right? Plant tissues are designed, or plant tissues are in such a way that they help in the stationary habit of the plants. They are rather simple. But when we talk about animal tissues are more complicated. Animals are mobile. They move from one place to another place. They need different kinds of tissues which enable their movement. Our sensory organs are also quite heightened. We need different kinds of tissues for our sensory organs. So our tissues are more complex, and the growth of these tissues is not limited to any areas, and for that we need continuous energy to maintain these tissues. Right? For example, if you go out for running, what happens? Your muscles will get exhausted, so you need more energy to keep yourself going on. So more energy is also required. But you do understand that animal tissues, after reaching a stage of maturity, they do not show any kind of further growth, but they do show degeneration. We have discussed that before. All right. So today's discussion is about animal tissue. Animal tissues are basically divided into 4 different types. The first one is epithelial tissue. Then we have muscular tissue. Then we have connective tissues. And finally, we have our nervous tissue. And among them, there is different sub-classification. We'll understand one by one. Epithelial tissues are further divided into simple squamous, cuboidal, epithelial, granular epithelium. We'll talk about different kinds of epithelial tissues. We'll also talk about muscular tissues. 3 kinds of muscular tissues are found: striated, smooth, and cardiac muscles. 3 kinds of muscular tissues. Connective tissues are various. In fact, connective tissues are many in our body. Blood itself is one of the kind of connective tissues itself. There is blood, there is muscle, there is bone, right? There is ligament, there is cartilage. There are so many things, so many tissues which are basically connective tissues. And then we also have nervous tissues for sending electrical impulses or signals to our brain. So let's discuss these tissues one by one. First one, epithelial tissue. Please remember, by the name epithelial, many times what aspirants think, epithelial is only connected to skin, right? Many times that confusion is mainly because of the term epidermis, right? Epidermis is external skin, dermis skin. But epithelial or epithelium are tissues. Yes, of course, they form the basis of your skin, but epithelium is present in almost all your organs, even in internal organs also. So epithelium is basically a kind of a protective tissue which is found in most of the bodily organs and cavities. All right. Epithelial tissues, they are all made up of epithelial cells which have specific functions. Some might protect you, some help in secretion, some help in absorption, some help in filtration. There are so many different kinds of epithelial tissues. As I told you, epithelium, it is a type of body tissue mainly forming the covering, internal covering as well as external surface covering. Many of your glands have epithelium and they have different kinds of function. We'll talk about them one by one. But what are the different kinds of epithelial tissues found? These categorization are made on the basis of cells, the epithelial cells that are present. If the epithelial cells are like squashed cells, they are called as squamous epithelium. And if these squamous epithelial cells are again arranged in a stratified fashion, they are called as stratified squamous. Many times epithelial cells are in form of a cube. They are called as cuboidal epithelial cells. And if these cuboidal cells are again stratified, that means if they are jumbled up together, they are called as stratified cuboidal. Many times epithelial cells can also be in form of columns. They have single nucleus columns. They are called as columnar epithelial cells. Many times you also have stratified columnar cells. And in many areas, we also have some sort of cilia or microvilli which have specific functions or specific roles in these epithelial cells. In general, broad classification has been made into these 4. cuboidal epithelium, where it consists of epithelial cells which are in shape of a cube having single nucleus, cube shaped cells. You'll find them in your kidney, in your different tubes, in your small glands. They also secrete stuff. They secrete hormone, secrete other things. Apart from that, squamous epithelial, as I told you, squamous means it is a single layer of cells like a squashed cell. They are present in lungs, heart, and blood vessels. Columnar epithelial cells, they are in form of column, they are elongated. They are normally found in your alimentary canal, in your GI tract. In fact, the columnar cells having microvilli, can be found out in your small intestine, in your AI tract. Right? They absorb stuff, they also secrete. Apart from that, there are stratified squamous epithelium. These are stratified, that means squashed cells, but stratified. You can find them in your esophagus and your mouth. Apart from this, epithelial tissues are also categorized as transitional epithelium. It is also called as urothelium. This transitional epithelium, it looks something like this. It is found mostly in the urinary tract. Apart from transitional epithelium, there is also glandular epithelium. Now, these are found mostly in different glands that we have. We have pituitary gland, right? We have a hypothalamus, thalamus, pancreas, so many glands we have, and these glands are responsible for secretion. They secrete hormones, proteins, and other chemical substances. And many kinds of epithelial tissues, as I told you, there is columnar epithelium, and this columnar epithelium, if it has some sort of a cilia, they help in sensation. So we have olfactory epithelium also, predominantly in our ear. In our ear, we have olfactory epithelium, which has some sort of a microcilia, or they also have specialized kind of extension which help in perception, which help in, say, hearing sound in perception. All right. So epithelial tissues, they have different kinds of functions. As I told you, it's not just about skin, of course, skin, but internally also, internal organs, internal lining, they are made up of epithelial tissues. And many a times epithelial tissues, they work as protective measure. Classic example being skin. It gives you your innate immunity. It does not allow things to get inside your body. Many epithelial tissues, they secrete, especially the glandular epithelium. They secrete enzymes, hormones, fluids. Many epithelial tissues, they absorb stuff. Epithelial cells in your lungs, they help in gas exchange. Epithelium in the small intestine, they help in absorption. Epithelium also helps in your excretion, predominantly in kidney. Apart from that, they also have a function of filtration. Many epithelium tissues, they help in respiratory tract filtration. They also have sensory reception. As I told you, the cilia that you have in your, that is the olfactory epithelium, they have stereocilia in ear. It is a classic example of epithelium which gives you some sort of sensory reception. All right. So this is the first kind of tissue, that is epithelial tissue. Let's move to the next one. Let's talk about connective tissues. By the name itself, you do understand connective tissue means it connects one part to another part, or they have a job of connecting. So connective tissues are comprised mainly of fibrous cells, and when I say connection, that means cells would be rather less. They will have more and more extracellular matrix. That means they are going to have some sort of specialized job. Some will have extra amount of protein, some will have extra amount of fat, some will have extra amount of specific thing, because it has some specialized job. All right. So connective tissues, generally they bind us together. They bind our body together. Say for example, muscle is a connective tissue. They also form the framework. My bones, they are nothing but my framework. So I have to connect bone to muscle, so I need another kind of connecting tissue. In my entire body, I need some sort of transport of oxygen and carbon dioxide. For that, I need blood. So connective tissues, they bind the structures together, they form the framework, they support the body, they support different organs, they support body as a whole. Many store fat, many store proteins, many help fight diseases. So connective tissue, they occur throughout your body with different kinds of functions. All right. So connective tissue, a specific trait about them is that the number of cells would be rather less, but they have extracellular matrix, or they have some sort of intercellular matrix, which is a characterization of them. Now, what kind of connective tissues do we have in our body? We have different kinds called areolar connective tissue. Blood is a connective tissue, please remember that. Osseous tissue, that is bone. We have adipose tissue, it has fat. So let's talk about one by one. First one, connective tissue, blood. Blood is basically a fluid which has different kinds of cells. The blood is considered as a connective tissue which is composed of different kinds of specialized cells. There are RBCs for transport of oxygen and carbon dioxide. There are WBCs which provide immunity to you. There are again platelets which help in your blood functions, which help your blood to clot, stop when there is some sort of injury. So they help in transporting gases, they help in transporting hormones, salts, etc. So blood is also a kind of connective tissue. Apart from that, a very important kind of connective tissue is your bone. Your bone or the osseous tissue, it basically forms the framework of your entire body. Over this bone, there can be other connective tissues which are connected to it. Bones are mainly composed of calcium and phosphorus. Please remember that bone, for hard bones, you need calcium and you need phosphorus based compounds. Apart from blood, apart from bone, there are so many other examples. For instance, bone itself has different types. Compact bone, there is spongy bone. Compact bone comprises of external layer of bone which is very, very thick, which is hard, but spongy bones are mostly lighter in weight because they are a little spongy. Bone marrow, inside the bone there is bone marrow in it. This is composed of blood. So bone marrow is a soft connective tissue which produces the blood cells, RBC, WBC, etc. Again, the bones and other muscles, other muscular tissues, they are connected through other connecting tissues called as cartilage, ligament. Now ligament, it is a fibrous connecting link between two bones. They hold the bones together, they keep bones in place. There is cartilage, it is a soft kind of connection between two bones to reduce the friction between the bones. So we have different kinds of connective tissues under bones itself. Apart from that, we also have areolar connective tissue. Now areolar connective tissue is a connection between skin and muscles. It is also found around blood vessels, around the nerves. All right, it looks something like this. Areolar tissues, they mainly help in repair of the tissues or repair of the cells. Apart from this, we also have adipose tissue. Now adipose, name itself is adipose, adipocytes. Now these help store fat mostly. We do need fat, we do need lipids, because we need absorption of vitamin A, D, E, K, and for that lipids are extremely important. These lipids are stored in the connective tissue called as adipose tissue. Adipose tissue is found under your skin, it is found in your internal organs, it is also found in your internal cavities, even in your bone marrows. So what did we understand till now? We discussed about the first kind of tissue, that is epithelial tissue, then the connective tissue. So connective tissues, they connect bone with other muscles as well, right? So epithelial, connective, and then muscular tissues. Now muscular tissues are made up of muscle cells. In our body, we find three kinds of muscular tissue. Now whenever we discuss muscle, everybody thinks about this muscle, right? We go to gym, we build our muscles. Now these muscles are called as skeletal muscles or striated muscles. Skeletal muscles or striated muscles. The skeletal muscles which are connected to your bones, that is the connective tissue, they are normally striated in terms, they are more like fibers in a very striated, in a jumbled or in a twisted kind of a form. They help in storing fat, they help in your mobility. Apart from skeletal muscle, we also have smooth muscles and cardiac muscles. So in our body, we find only three kinds of muscles. One, muscle which is connected to your bone. In majority areas you find that, but we also have two kinds of specialized muscles. Smooth muscles, which are mostly present in your internal organs, and then specialized cardiac muscles, which are your heart muscles. Please remember, the skeletal muscles, they are striated. The cardiac muscles, they are also striated. Striated meaning they are in they are like fibers, more like twisted or jumbled fibers. So let's talk about these one by one. As I told you, skeletal muscles, these are striated muscles. They are attached to the bones. Bone is a connective tissue. Please remember. Again, these skeletal muscles or skeletal muscle tissue, they have a very important peculiarity. And I want you to remember this from exam perspective. Skeletal muscles, these are fibers. These are fibers. They are striated. They are cylindrical. Remember, they are multinucleated. That means there is more than one nucleus present in these muscle cells. Also, they are under voluntary control, meaning if I am going to move my hand, it depends on me whether I move it in this direction, this direction, this direction, because it is under my control, right? It's under my control, my brain's control, right? Apart from that, these skeletal muscles, they are capable of undergoing some sort of anaerobic respiration for a very short time, meaning when the body is exerted, skeletal muscles, they do not need oxygen to carry out their work for very short time. You must have seen many a times that the skeletal muscles, when they are exerted extremely, that's why they are multinucleated, because they give you energy. But say you must have seen sometimes you have cramps. Why do you have cramps? Cramps are nothing but overexerted or overexerted your skeletal muscles, which have undergone anaerobic respiration for a very long time. So what do? You provide more oxygen to it. How? By heating them. More blood supply is provided. Water is provided. Heating is done. So cramps they go because more blood reaches to these muscular tissues. One of the examples. Please remember this. Apart from that, there are smooth muscles. Smooth muscles, they are non-striated muscles. They are non-striated muscles, right? Mostly found in the alimentary canal, in the urinary bladder, in your blood vessels, etc. Again, these are not in under your control. These are involuntary muscles. They are not under our control. We cannot control them. They work automatically. They are all governed through the central system itself. We cannot move them intentionally, just like we move our muscles, etc. We cannot move them, right? They are called involuntary. Please remember, again, they have single nucleus, and the nucleus is mostly located at the center. They do not look twisted. The third kind of muscle is cardiac muscle. Now these are specialized muscle. We know cardiac muscle, they are the heart muscles. These muscles never stop. They are not under our control. They are involuntary. We cannot start or stop them on our own. They have to run throughout our life. These muscles have specialized job, that is to provide pumping action to your heart. If the heart stops, life stops. That's why these are also, remember, these are striated, meaning they are like elongated fibers, a little twisted fibers. They also have only single nucleus in these cardiac muscle cells, and they are not under our control. Clear? Muscular tissue. Apart from these tissues, we have nervous tissue. Now nervous tissue is responsible for relaying the messages from our brain to other parts of our body. They are also present almost everywhere in our body. All these things, they work in conjunction together. Now nervous tissue, it is composed of basic cells called as neuron. Neuron is the basic unit of nervous tissue. Neuron has single nucleus. It has a dendritic structure so that we connect different neurons. In fact, our body has billions of neurons to relay signals from our brain. Now we do know our central nervous system consists of the brain and your spinal cord. Spinal cord has different segments, and from brain and spinal cord, your peripheral nervous system begins and different nerves spread through it, so that the central nervous system, it relays messages to all the neurons. For example, if I am moving this hand right now, what is happening is my brain is sending a signal to the motor neurons in my hand to move the hand something like this. All right. So the basic unit of these nervous tissues is a neuron, which has dendritic structure towards the nucleus side. It also has axon, and this axon has nerve endings which is connected to the next neuron. It forms a connecting link like this. So the cells that make up the central nervous system and peripheral nervous system, they are called as nervous cells, and nervous cells, they make nervous tissue. All right, so they basically help in relay, as I told you, they relay or transfer the impulses from your body. Their structure, they move through dendrites. Dendrites basically receive the impulses, and axon, they send out impulses, right? These receive the signal, and axon, they send out the signal out. There are different kinds of neurons which are found in a body. There are three kinds of neurons: sensory neurons, interneurons, and motor neurons, and they form nervous tissue, right? Sensory nervous tissue, interneuron tissue, and motor neuron tissue. Clear? Right. So these are the basic kinds of animal tissues that we have: epithelium or epithelial tissue, connective tissues, we have muscular tissues, three kinds, and then you have nervous tissue. Okay. Diversity in living organisms. Now, here we are going to discuss about how are we going to classify living organisms. Earth is the only planet which is called as biosphere because it has life, and this life is present in various forms. What is the meaning of this biodiversity? Biodiversity means diversity of life form. We see in our environment, in our biosphere on Earth, we see different kinds of organisms, right? If you look at humans only, there is so much of diversity among humans, so many different features, different races, different characteristics can be seen. Forget about humans, look at the animals. Among animals itself, you have the feline category. For example, you have tigers, you have lions, you have cats, you have different kinds of animals. Different microorganisms are found on Mother Earth. There is immense biodiversity, especially between the two tropics. Why? Because warm and humid tropical regions, they support biodiversity, and that's why it is said that in Mother Earth also a large amount of biodiversity can be seen, especially in these tropics. It doesn't mean biodiversity is not present above the tropics or below the tropics. It's there, but maximum biodiversity can be seen in this, and that's why we see that no two people are similar. Somebody has more height, somebody is a little short, somebody is well built, somebody is very slim, very athletic. So we see so many diverse features among living organisms. Look at any kind of species. Look at different dogs, horses, etc. There are so many different categories, different variants among themselves. The big question in front of all of us was, how do we categorize or how do we classify these living organisms? How do we do it? It's quite bewildering that there is a lot of variety to life. Now, what I want to do, I want to understand, or I want to classify life forms into different groups. How can I do it? How can I do it? Many people have tried it. For example, Aristotle. Now, Aristotle, he went for a very simple kind of categorization. He said there are some living organisms which live on earth, that means on the land. There are some which are in water, aquatic animals, aquatic plants. Then there are some which are basically airborne, like the birds. A simple kind of categorization, right? Many people have tried it. Many people have tried it on the basis of different characteristics. For instance, we have also discussed how can we classify things. We classify things on the basis of the most fundamental and structural unit of life, that is cell. How do we classify them? Is a cell prokaryotic or a eukaryotic cell? You know, prokaryotic cells are not non-advanced cells. They are mostly primitive cells. Yes, they do have cell wall, they do have cytoplasm, but their genetic information is very little. Their genetic information is not bound by a nuclear membrane. Those are called prokaryotic, meaning they do not have a true nucleus. Whereas advanced species or advanced organisms, they have a eukaryotic cell in them, meaning they have specialized cell organelles. They have mitochondria, they have Golgi complex, they have vacuole, etc. But this prokaryotic cell or prokaryotic organisms, they do not have any kind of specialized organelles in them. One of the means is this classification, starting with prokaryote and eukaryote. But we do see it is just for the cellular organisms. Say prokaryotic versus eukaryotic, a much simpler kind of classification. But we started to ask more questions. Yes, what type of cell? This is one of the means of classifying. But Is an organism unicellular or multicellular? Yes, we can categorize on the basis of that also. Does it produce its own food? Is it an autotroph? Is it a heterotroph? Or is it a saprotroph? We can also categorize on the basis of this. Yes. We can also categorize on the basis of specialization that organism has. Does a living entity have any kind of specialized organs? We have, right? See, this is a very big speciality among humans, or I would say apes and primates, that we have opposable thumb. Because of this opposable thumb, we are able to do, or we are able to perform so many tasks which other animals cannot do it, just because of this evolutionary development. One of the basis of classification can also be evolution. Charles Darwin also tried it, right? So different people have tried different explanations for categorization or classification of living organisms. We can also ask, what is the level of organization and development of those organs? So based on these kind of questions, based on these kind of parameters, categorization or classification of living organisms has been done by some biologists. It started with Ernest Haeckel, Robert Whittaker, and Carl Woese, who tried to classify all the living organisms in very broad categories. Now what they did was, all the living organisms, all the living things, they categorized basically into 5 different kingdoms, and they named those kingdoms as Monera, Protista, Fungi, Plantae, and Animalia. These are kingdoms, and these kingdoms were further subdivided into subgroups or subcategories, reaching way till the end of species. Many scientists have contributed. For instance, the Monera family or Monera kingdom was ultimately subdivided into Archaebacteria and Eubacteria by Woese. So such subcategorization has also been done. So today, when we enter into the field of taxonomy is basically classification of living organisms according to some parameters, some characteristics, and we have gone for taxonomy of each and every species. And under taxonomy, what do we look for? What is the hierarchy that we have created? From 1990s, we have also created one more level called domain, which is the topmost level, which is based on what kind of cell that organism has. Is it eukaryotic or prokaryotic? So first domain, then we reach into kingdom. 5 kinds of kingdoms have been categorized. Under that, we have created subgroups or subcategories. Under the kingdom, we have phylum, we have class, below that we have order, below that family, genus, and ultimately species. Now if we look at us humans, if you look at us, what domain do we belong? We belong to the domain of eukarya. That means our body is composed of eukaryotic cells. We are under the kingdom Animalia. Our phylum is Chordata, because we have our spinal cord, right? We have Chordata. Under that, we come under the class Mammalia, because humans give birth to young ones on the basis of that characteristic. Then there is order called as primate. Under primates, we belong to the family of Hominidae, and under that we belong to a genus of Homo. Ultimately, we are called Homo sapiens. This is our species, human species. Very similar to that, we have created different classifications of different living organisms, different order, different genus, different families. Different scientists have contributed towards that. So a classification has been done into different subgroups, reaching up to the level of species. Now species is the last stage, which is nothing but a categorization of all the living organisms in that species. They are able to interbreed and they are able to perpetuate their population among the same species. All right, that's the basic categorization. Now to understand this, domain as a taxonomic unit was rather added lately in 1990s. The early taxonomies, they did not have domain. They directly started with the concept of kingdom, but now we do find a domain. Domain is basically eukarya or prokarya, right? It is divided into eukaryota or eukarya, archaea, and bacteria. Below this domain, we have kingdom, and initially there were only 2 kingdoms, Plantae and Animalia. But with the development of microscope, compound microscope, with the scientific development, we started to realize that there are many microorganisms in and around us. Then we created more kingdoms. Today we have 5 broad kingdoms: Monera, Protista, Fungi, Animalia, and Plantae. And later biologists, later researchers have further contributed to it. For instance, as I told you, Monera is further divided into archaea and eubacteria. These days we also talk about cyanobacteria. Similarly, Protista was further divided into Chromista and Protozoa. In Protista, we had algae before, right? The green algae especially, they have been removed from Protista and they have been added into kingdom Plantae. Such changes have been made. So first, it's domain, then we have a kingdom, then we have a phylum. Phylum is the next level of kingdom of classification, which is based on similar physical similarities. And in animals, in Animalia kingdom, we have 34 different phyla. In Plantae, we have 13 different phyla. Similarly, in Protista and in bacteria families, we have different phyla. Below phyla, we have different classes. Classes is again under the phylum, we have divided them into classes. For instance, in animals, in Animalia kingdom, we have a class of Mammalia. Humans belong to the Mammalia class. We have a class of aves, that means birds. We have a class of reptilia, the reptiles belong to it. Below class, we have created an order. Class is further divided into order. Order, for example, in Mammalia, there are more than 20 orders. Different kinds of mammals are found. For example, primates, we can come under primates. Then there is carnivora, cetaceans. Then there is Chiropetra. Chiropetra, for instance, bats, right? Bats come under Chiropetra. Below order, we have different families, right? Families are organisms within a family that have more thing common than any other classification. So in a family, different kinds of living organisms, they have similar kind of traits. For example, when I say feline, right? When I say feline category, feline or Felidae is a family. Under the feline family, we have different cats. Tiger belongs to it, right? We have different feline cats belong to it, right? Basically, cat species. Similarly, you have Canidae. To Canidae, the canines or dogs, foxes, wolves, they all belong to this family. Now, below family, we have genus and species. Genus is basically generic name for that particular organism, and below genus, we have specific species based name. For humans, genus is Homo and the species name is Homo sapiens. And species are those which can interbreed among themselves. They have ability to breed with other organisms in the same species. On the basis of that, the division has been done. All right. So this is how we have classified the entire living organism school. Now the question is, what are these different kingdoms? What kind of subcategorization has been done? The important things would be discussed. First kingdom is Monera. In fact, this is our basic knowledge. We'll be building on this in our class 10, class 11 discussion also. Monera, it's basically the kingdom of microorganisms. And when I say Monera, please remember, Monera are prokaryotes. They are prokaryotes. So these are Monera. Under Monera, we see microorganisms, mostly unicellular organisms, which do not have a well-defined nucleus. That means their genetic material is completely spread out into the cell. They do not have a nuclear membrane. The classic example of this is bacteria, bacterial cell. You can talk about Anabaena. These are the microorganisms from Monera kingdom. And if you look at Monerans, they are generally unicellular organisms. The subcategorization is a little less compared to the other kingdoms. Then these are found almost everywhere, mostly in the moist environment. They are found extensively, but you can find them anywhere. You can find them deep inside the ocean. They might be parasitic. They might be based on chemicals, right? They might be producing their own foods also. All right. Monerans, they do not possess any membrane-based organelles. They don't have any organelles. Now, this is the classic example of that, bacteria. A bacteria does not have any specialized organelles. It does not have any mitochondria or any lysosome or any Golgi complex or endoplasmic reticulum. Yes, it does have a cell membrane. It does have a cell wall. Many bacteria have a cell wall. They do have cytoplasm in it. They have your genetic material in it, but that genetic material is spread throughout. They do not have any kind of nuclear membrane around them. But they have ribosomes. They have special kind of ribosomes which are called as 70S ribosomes. We'll talk about them in our subsequent discussions. And their DNA is naked. Now, when we talk about monerans or the kingdom of Monera, it can be further subdivided into these three categories. One is archaebacteria, which are very, very primitive bacteria. Now, since they are archaebacteria, ancient bacteria, they can survive extremes. They can survive extreme temperature, extreme pH. We have acidophile bacteria, which can survive in extreme acidic medium also, right? So bacteria which are found mostly in extreme habitats. You will find bacteria even near or in and around volcanoes also, right? Apart from that, there is eubacteria. These are the true bacteria. These are the true bacteria which have a cell wall which is made up of peptidoglycan. Apart from that, there is cyanobacteria which has been categorized. Cyanobacteria are these blue-green algae or which are able to produce their own food. They are able to undergo photosynthesis. So you can say that these bacteria are basically autotrophs. That means they can produce their own food because they have some sort of chlorophyll. They have bacteriochlorophyll. They have specific bacteriochlorophyll because of which they are able to produce their own food. All right. So this is kingdom Monera. The second kingdom is kingdom Protista. Please remember, when I say kingdom Protista, only one kingdom is prokaryotic. Kingdom Protista is not prokaryote. Many times aspirants get confused because there is pro in this. They are not prokaryote. Please remember, these are eukaryotic organisms, eukaryotic living organisms. So protists are eukaryotic unicellular organisms which might have a flagella or some sort of cilia on their outside. They can further be classified into algae, diatoms, flagellates, etc. Classic example of protists, they include algae. Although the green algae which are able to perform photosynthesis, they have been removed from protista and they have been put into plantae. But many algae, they are still part of protista, protists. Amoeba, paramecium, these are some of the examples that come under protista family. Under the protista family, we need to understand that these are eukaryotic organisms. They have true nucleus. Protists, they are generally found in water. They are aquatic microorganisms, but can also be found in soil or wherever there is moisture. You will find protists there. Apart from that, most protist species, the protista species, they are unicellular organisms, but there is no hard and fast rule like that. Some protists can also be multicellular. One of the classic example being, I can give example of kelp, right? Kelps, they come under protists. You must have heard about that. Kelp are multicellular protists. All right. And again, under the kingdom protists, we can subdivide them as plant-like protists, fungi-like protists, and animal-like protists. These are some of the subcategorization of that. Not very important, but please remember, amoeba, protozoa, flagellated protozoas, ciliated protozoas, they all come under animal-like protist subgroup. All right. So please remember examples of amoeba, paramecium, different protozoa. For instance, there are many protozoas which lead to diseases in humans. So whenever you read about protozoa, they belong to protist family. All right. Don't forget about that. For instance, malaria is caused by a protozoa called as plasmodium. So do remember about that. So this is about the protista family. Then there is fungi. Fungi is relatively easy. You must have read about it. You know about this. Fungi are, please remember, eukaryotic organisms. They can be unicellular. They can also be multicellular. All right. They are eukaryotic. In fact, fungi are most close kind of cells. They come very close to plant cells. They also have cell wall in them. But please remember, fungi, they do not have these complex tissues. We discussed about plant tissues in our discussion, right? Plants have complex tissues. So fungi do not have any sort of complex tissues. They do not have any vascular tissues, etc. There is no concept of xylem, phloem, etc. All right. Fungi can be, I can give many examples of that, because in our day-to-day life, there is no need that there are microorganisms only. I don't need a microscope to see them, because a colony of fungi can easily be seen even with naked eyes, right? We know some fungi can be problematic for humans. Some fungi are extremely beneficial for us. We can produce bread, alcohol, etc. Saccharomyces cerevisiae, yeast is one of the example. Penicillium mold, we get antibiotic from that. Then there is agaricus mushroom. Many mushrooms are also edible. Many mushrooms are also narcotic substances. So please remember that fungi can also be sub-classified into different categories. Fungi can be saprophytic, meaning they feed on dead and decaying organic matter. They are called as saprophytes. They can also be parasites, right? Fungi that feed on other living organisms. They feed on the hosts, or fungi can also get into some sort of symbiotic relationship. We can give many examples of that. For example, lichens are one of the examples of symbiotic relationship. We can also give example of mycorrhiza. In fact, this is the picture of lichen itself. Fungi that feed on other living organisms but do not harm the host. They do not harm the host. They get into a symbiotic relationship. Mycorrhiza, lichens, etc. But in general, fungi, classification of kingdom fungi can be subcategorized into different fungi groups like Oomycetes, Zygomycetes, Basidiomycetes, Ascomycetes, depending on if there is sexual reproduction which is known, sexual reproduction if it is known, then you can find Mycelium aspetate, then you find Mycelium septate. There are so many examples. There is no need to mug up these words, but why I am telling this is the kingdom fungi has different phyla in it, different species in it. We are not supposed to get too much into details of these from exam perspective. So we discussed about kingdom Monera, prokaryotes, kingdom Protista. They are not prokaryotes, they are eukaryotes. Examples: amoeba, paramecium, other protozoan unicellular species. Then fungi. Fungi, again, very important. We'll be discussing, we'll be building on this knowledge again in our subsequent classes. When we enter 10th, 11th, we'll talk more about protists, fungi, and Monera as well. But there are two more kingdoms: kingdom Plantae and kingdom Animalia. Kingdom Plantae, they are categorized as autotrophs because they have chlorophyll in them. They are able to produce their own food. Under kingdom Plantae, we have different kinds of subcategories. We'll talk about that. And under Animalia, they are heterotrophs. Yes, of course, they are multicellular eukaryotes with special kind of organs. So under Animalia, we have different kinds of subgroups. We have different families, different orders, different genus, different species. We'll talk about them. So this discussion is going to continue. Today's discussion is the end of part 1, where we simply focused on different kingdoms. In our subsequent discussion, in the part 2, we are going to talk about different subcategories of kingdom Plantae. Then in the part 3, we are going to talk about different subcategories in kingdom Animalia. So this is our discussion. Basically, different living organisms, they have been categorized as prokaryotes and eukaryotes. Under prokaryotes, there is kingdom Monera. They come under the domain of prokarya, that is kingdom Monera. Then on the other side, you have eukaryotes. Under eukaryotes, you have unicellular protista, protists, amoeba, paramecium, protozoa, etc. These are the examples. Under multicellular, you have kingdom Plantae. Under multicellular itself, you have fungi, and then you have kingdom Animalia. So we will be discussing kingdom Plantae separately in part 2, and we'll be discussing Animalia, kingdom Animalia, in part 3 distinctly. Very important from exam perspective. So that's it in today's interaction. We'll meet very, very soon in our next class with part 2. Thank you. We said that there is a lot of biodiversity on Mother Earth. That is why we call it biosphere. We find different organisms. Among the different organisms, there are different characteristics. And we said biodiversity is quite extensive, especially in between the tropics, between Tropic of Cancer and Tropic of Capricorn, because of moist and humid climate, right? We established this. Then we said, how do we classify these? Right? It is quite bewildering that there is a lot of variety of life on Earth. So to categorize it, different people have used different methods. I discussed about Aristotle's method, things on land, things in water, things in air, etc. But ultimately, we said that human life has been divided into these classifications, right? Mostly Ernest Haeckel and Whittaker's classification, where living organisms have been divided on the domain of prokaryotic and eukaryotic cell. Domain prokarya, we have the kingdom Monera. It has been divided into 5 major kingdoms: kingdom Monera, kingdom Protista, which is unicellular, but they come under eukaryotic cells. Then you have kingdom fungi, which do not perform photosynthesis. Then you have kingdom plantae and kingdom animalia. 5 major kingdoms. And we also discussed that through the taxonomic developments, different biologists, different scientists have added subcategories or subgroups also. We discussed the taxonomic subgroups, especially for Homo sapiens. All right. Today, we are going to specifically talk about kingdom plantae. In our previous discussion, we discussed about Monera, right? These are prokaryotes. We discussed about Protista. These are eukaryotes. Examples are amoeba, Paramecium, other protozoans. Then we discuss fungi also, right? Fungi also. Today, specifically about kingdom plantae. Now, what are the characteristics of kingdom plantae and how do we characterize this kingdom plantae? Kingdom plantae, the name itself says these are basically the green plants which are able to undergo photosynthesis because they have chlorophyll in them. Now, when we look at the categorization, how have we categorized kingdom plantae into different subgroups and subcategories? We have seen that we look at the plant and we see if that plant has differentiated and distinct parts, then we classify them in subgroups. We see if they have specific vascular tissues, do they have xylem and phloem? We categorize on that as well. Then we categorize, do plants bear seeds or not? What kind of fertilization takes place there? So on different characteristics, we have subdivided kingdom plantae. But in general, there are certain general characteristics of kingdom plantae, which you already know. We have discussed this in class 6, 7 also. If it is a plant is composed of eukaryotic cell. It is not prokaryotic cell. We know plants are generally multicellular because unicellular organisms, we have discussed this, Monera, Protista, etc. Plants are multicellular. Plants are stationary. They are non-motile. That means they stay at one place. Now you must be thinking, sir, what about these aquatic plants which move with water? Technically, they do not move. They move because of the movement of water. Remember, they are non-motile. But remember, they are eukaryotic cells which have cell walls. Very important point. They also have, majority of them, they do have transport system, that is vascular tissues, xylem and phloem, and other complex, permanent and simple tissues also. They are autotrophic. Why? Because they contain chlorophyll. They can undergo photosynthesis. They produce their own food. Their method of reproduction can be different. It can be asexual or it can be sexual reproduction as well. And please remember, many of the species of plants, I would say barring angiosperms, many plant species, they do go alternation of generation. Now, what is the meaning of this alternation of generation? It depends on what kind of reproduction the plant follows. Alternation means many a times plant, if it is reproducing asexually, that means it will have a haploid genes or it will have haploid cells. But alternation of generation means if plants are able to alternate between sexual reproduction and asexual reproduction, then at one point of time they will have haploid cells and then at the other point they have diploid cells, and we will see some sort of circulation between these things. That is called as alternation of generation. In many plant species we find alternation of generation. So these are some basic characteristics of kingdom plantae. Now, how do we further subcategorize this kingdom plantae? Kingdom plantae is further subcategorized as thallophytes. How? Thallophytes are basically those which do not have differentiated parts. We'll talk about that in detail. We'll categorize them in another 5 subgroups. Thallophyta, then we have bryophyta, right? Or bryophytes. These have differentiated parts, but they do not have any vascular tissue. That means they do not have complex tissues like xylem and phloem. So we have thallophyta, we have bryophyta, meaning no differentiated parts. Differentiated parts, among that no xylem phloem, one group. And those who have xylem phloem, those who have vascular tissues, among that the ones which do not produce any seeds, they are called as pteridophytes. Now these pteridophytes are the ones which undergo this alternation of generation a lot. Apart from that, we have the ones which produce seeds. These are called phenograms, and under phenograms we have gymnosperms which bear naked seeds, and then angiosperms which bear fruits. That means seeds are enclosed. Seeds are enclosed. Basically, seeds are enclosed within the ovary. And then angiosperms are further divided into dicots and monocots. We'll talk about them one by one. This is the basic categorization. I hope that you do remember. Please revise this and remember this. Especially, I would say bryophyta, pteridophyta, gymnosperms, angiosperms. We will be talking about them in our subsequent discussions as well. That's the basic categorization. Let's jump into the first classification, sub-classification under the kingdom Plantae, that is Thallophyta. Now, Thallophyta, first characteristic is they do not have any differentiated body parts. Now, when I say a plant, what does a plant have? First, I'm drawing a simple herb. You will see that it has roots. This is the ground level. It has roots. It has a tender stem, correct? This is stem. These are basic roots. Then, if I simply draw some sort of green leaves, then you will see branches and leaves. And these leaves will have chlorophyll. In herbs, even stem will have chlorophyll. They will also undergo photosynthesis. These are basic characteristics. And on this, you can also find leaves, fruit, etc. This is the basic understanding of a plant. But remember, Thallophyta, it is not going to have any of these. No roots, no stem. In fact, no specialized leaves as well. So basically, these are like microorganisms which are capable of undergoing photosynthesis. There are many examples of this. You will find many green algae which are put into this particular family of Thallophyta. As I told you, algae were basically before in Protista group, Protista kingdom. Now they are in Plantae, especially photosynthetic algae. There are many examples. Pyrogyra is one of the examples which has chloroplast. Yes, there is Cladophora, Eulothrix, Ulva, right? There are so many examples which you can see. These are the pictures. Colonial algae, they come under Thallophyta. The common stonewort, they come under Thallophyta. Spirogyra comes under Thallophyta. Why? Because they do not have root, they do not have stem, they do not have leaves. That means their job is not differentiated. The organs are not formed at all. These parts are not there. So what are the characteristics of these thallophytes? They do not have any vascular tissue. They do not have any root system, extensive root system or stem system. But they do need water. That means they are mostly present in moist and wet location. Of course, they are green. That means they have chlorophyll. They are autotrophic. They can produce their own food. What kind of food they produce? They use carbon dioxide. They use sunlight. They need water. Then they produce basic glucose. And excess glucose that is produced by these Thallophyta, they are stored in form of starch. All right. Again, thallophytes can show sexual reproduction as well as asexual reproduction. Whenever there is sexual reproduction, the sexual cells are very simple and single celled, and there is no concept of development of embryo here. Clear? These are thallophytes. These are some of the examples. So from now on, whenever you see any water body where there are some sort of green algae, then those are thallophytes. So that's why I always suggest or advise students that whenever you're walking somewhere, you're watching something, right, in your free time, just look at things and try to understand what are those. So thallophytes are these organisms. Next is bryophyta, right? Now bryophyta are also called as amphibians of plant kingdom. Why? Because we can find them in water, we can find them in moist condition, we can find them even in dry condition. Again, you will see that they have some structures. If you look at this particular picture, you will see yes, there might be some kind of stem, there might be leaves, but no other vascular tissues, meaning they do not have any kind of vascular tissues. There is no xylem, there is no phloem, there is no development of these complex tissues. Please remember this: no xylem, no phloem. There can be many examples of this. Liverworts, you must have seen mosses, right? Mosses, especially in your wet conditions, you must have seen whenever there is extensive rain, you see some green kind of structure, something, a growth, something like this. These are very common. Liverworts are also very common because they have simple leaf-like, stem-like structures, and many of these bryophytes, they might not have roots. I'm not telling that in bryophytes roots are completely absent, but in majority of bryophytes you would not find extensive root system. They have simple leaf-like, stem-like structures. They do not have any xylem, phloem. Yes, they are green. That means they contain chlorophyll. They undergo photosynthesis. But for support of stem, for development of leaves, very primitive kind of leaves, they have something called as rhizoids. Now these rhizoids, they help in absorption of minerals, they help in absorption of water. They do not have xylem and phloem. Yes, they do show sexual reproduction, and this sexual reproduction, it depends on availability of water. Very, very important pointer. This reproduction depends on availability of water. Many times we see these bryophytes growing whenever there is rain. You must have seen when you go to your terrace, or when you see a side wall, you must have seen some kind of green growth or some kind of plants which develop, which have basic leaves and basic stem. Those are all examples of these bryophytes. So for next time, do watch them. All right. Right. So we discussed about thallophytes and bryophytes. Next is pteridophyta. Now pteridophytes have differentiated organs. That means pteridophytes have roots, pteridophytes have stem, pteridophytes have your vascular system also. They have vascular system, meaning they also have xylem and phloem. But what is missing in them? Just look at these plants. What is missing in them? They do not have any flowers. They do not have any flowers. They do not develop any seeds. And next time when you just go to a garden, or if you have a garden, if you have any sort of ornamental plants, observe those ornamental plants. Most of them would be pteridophytes. Most of them would be pteridophytes, because if it is not producing any sort of flowers, then they are pteridophytes. And please remember, when I characterize this, I gave a term called as phenogram. Here you see the ones which produce seeds, they are called as phenograms. But all the three, thallophyta, bryophyta and pteridophyta, these three are called as cryptograms. Cryptograms. Why? Because their sexual organs or sexual reproduction is actually hidden. That's why they are called as cryptograms. And the opposite of that, seed producing plants are called as phenograms. Cryptograms and phenograms. Another classification has been done. But when you look at pteridophytes, you will see that they have differentiated roots, they have differentiated stem, they have differentiated leaves, they also have special tissues for conduction of water and food. That is, xylem and phloem is present. There are many examples. You can look at many of these plants where you do not see flowers. They would be most probably pteridophytes. There are certain characteristics of that. They will have all the things, but they will have no flowers. Of course, no flowers means no seeds. Their leaves are also known as pinna. They do have vascular system, xylem and phloem. They also show alternation of generation. In fact, pteridophytes, which are the plants which we can see, they show alternation of generation. Many a times the plant will have haploid cells, the plant will also have diploid cells, depending on the sexual reproduction. They show sexual as well as asexual reproduction. They also show sexual reproduction, would be right. All right. So there are many examples of this. Next time when you watch in a garden or something, do make a note of that. Pteridophytes. Then the next set of classification is rather easy. We are talking about phenograms. Under phenograms, we have two. One which produces naked seeds. These are called gymnosperms. In fact, you must have seen a lot of gymnosperms in and around you. Especially if you're staying in high altitude places, you will see pine trees, you will see cycas, right? You must have seen pines. Now, what are these pines? These are actually seeds itself. They are naked seeds. These do not produce any flower. They do not have any flowers, right? So flowering is not seen extensively. And when you look at these plants, gymnosperms, they will have male, for example, pine tree, male pine cone and female pine cone. These are basically naked seeds, gymnosperms. Gymnosperm basically means, gymno means naked, sperm means seed, right? Examples of pine, deodar, etc. You will find many. We'll be talking about them again in our subsequent discussion in 10th and 11th also. And the counterpart of gymnosperms is angiosperms, one which produces flowers. These are quite extensively seen. They undergo sexual reproduction. Angiosperms, meaning the seeds which are covered. The seeds which are covered. That is why, take any kind of crop, take any kind of fruit. Say there is mango, right? Mango season is about to get over. You have mango, the fleshy part, and inside there is a seed, right? Talk about any kind of food grains, right? Talk about wheat, talk about rice, talk about any chickpea, Bengal gram, etc. Any kind of gram. Those are all angiosperms. Why? Because first the flower will come, and then the fruit is going to be formed. And in that fruit, Fruit is basically mature ovary. Inside that you have seeds. The seed is covered with some sort of a fleshy part or some sort of protective layer. Those are called angiosperms. Majority of the plants that you observe in your day-to-day life are angiosperms. And angiosperms are further divided into two categories. One is monocot and another one is dicot. Right? Monocot stands for monocotyledons and dicot is dicotyledons, meaning the seed that is produced, it cannot be broken. Seed cannot be broken further. Monocot seed, it cannot be broken further. But when you break a dicot seed, it can be broken into two pieces. You must be having a lot of pulses, right? Every day you have dal, right? Dal makhni, dal Punjabi, dal tadka, etc. What is a dal? That dal is a dicotyledon seed. That is a dicot seed. That means first it comes as a whole, but you break it into two for your consumption. But there are many monocot seeds. Monocot seeds are like, say, wheat. Wheat is monocot. Rice is monocot, which cannot be broken into. Corn is again a monocot seed. So we find angiosperms, flowering plants, which lead to development of fruits. The seeds are protected by some sort of a layer. It can be monocot or dicot, right? Monocot seeds, they look something like this. Dicot, there will be a layer which you can break into two. And whenever you see a monocot seed plant, its roots are always fibrous, whereas a dicot, it has a taproot system. Similarly, leaves. For a monocot plant, the leaves have parallel venation. The leaves have parallel veins. Whereas in your dicot plants, the leaves have reticulate venation. They have net-like veins. Apart from that, when you take a cross section, the vascular bundles in dicot plants are in form of a ring, whereas the vascular bundles in a monocot plant, they are rather scattered. Apart from that, when you look at the flower of monocot and dicot, for a monocot plant, they always come in pairs of 3. That means there can be 3 petals, there can be 6 petals, there can be 9 petals, right? 3, 6, etc. But when you look at a dicot flower, it will have 4 or 5 parts, or 4 or 5 petals, or in the multiples of 4 and 5 petals, right? So these are basic differences. Now, to sum up our discussion of kingdom plantae, let me give you certain examples. As I told you, whenever a plant is developing, there is bryophyte. Bryophytes do not have any vascular system. They are land plants. Examples are mosses. Then you have pteridophytes. Pteridophytes are again land based. You will see they are seedless. They have vascular system. They have xylem and phloem. Example is fern. Then there are phenograms, that is gymnosperm and angiosperm. Gymnosperms are naked seeds. Angiosperms are which when give you flower and fruits. There are many examples you can see here. Plants that do not make any kind of seeds, if it has no true roots, stems or leaves, it becomes algae, that is halophyta. But if it has some roots, stem and leaves, it becomes your bryophyta, that is mosses. And if it has roots, stems and leaves but do not produce any seeds, then it becomes your pteridophyta. And if a plant produces seeds, then they are gymnosperms, naked seeds. They are angiosperms, seeds that have covering on it. Basically, they produce fruit, right? Inside the ovary, inside the mature ovary, we find the seeds. This is the categorization of kingdom plantae. All right. So that's the end of our part 2 discussion. In the subsequent discussion, we'll talk about kingdom Animalia. Chapter 7. It deals about diversity in living organisms. We discussed about what is biodiversity, where the biodiversity is maximum. It is found in between the tropics, between Tropic of Cancer and Capricorn. And we also discussed about how there was a lot of difficulty in classifying these living organisms. We discussed about Aristotle, we discussed about other people. Then finally, we came to a more scientific taxonomy of living organisms, which was developed by Haeckel and Whittaker. They divided living organisms into 5 kingdoms. And what are those 5 kingdoms? Under the domain of prokarya, we have kingdom Monera. These are basically unicellular organisms, prokaryotes, archaea, archaebacteria, eubacteria, cyanobacteria. Then under eukaryotes, if they are unicellular, we have protista, paramecium, amoeba, right? These examples, other protozoa. Then if they are multicellular, then we divide them into fungi, those which cannot produce their own foods. These are not autotrophs. And then under the multicellular, those who have cell wall, we divide them into kingdom Plantae. And in the previous discussion, we discussed kingdom Plantae. And the multicellular organisms without cell wall with advanced organ system, they are animalia. So today's discussion is about kingdom animals. So we are going to talk about this animalia kingdom, which we further classify on the basis of certain characteristics. What are those? We decide if they are eukaryotic. Yes, they are multicellular, they are heterotrophic, they do not have cell walls, but they are further classified on the basis of their body design and what kind of differentiation do we find in them, right? One of the major distinction factor is the concept of column, right? Column is this true cavity in our body. For example, we have a gastrointestinal tract, right? I have food through my mouth, and if I look at my GI tract, from mouth to esophagus to stomach to small intestine to large intestine, we have discussed about this. Then there are linings, there are triple linings around these. So we have true column in our body. So on basis of such differentiation, we categorize or we subcategorize kingdom Animalia. But in general, animal kingdom has certain general characteristics. Please note, general characteristics. There can be some outlier or some exceptional examples. Generally they are eukaryotic, composed of eukaryotic cells. Eukaryotic means they have true nucleus. Their genetic information is stored inside a nucleus which has a membrane, not like prokaryotes where the genetic material is spread throughout the cell. The second characteristic is they are multicellular. Majority of the animalia are multicellular, and generally they are motile. That means they are able to move. They are not stationary. They can move. Now we can move because we have legs, right? There are many organisms which have different kinds of movement or movement mechanism, right? Apart from that, the cells, they are eukaryotic, but they do not have cell wall. They do not have plastids. That means animals are not able to produce their own food. They are not autotrophs. They are heterotrophs. They rely on plants. They rely on other organisms for their food. Apart from that, they have well-developed organ systems. Generally, animals have well-developed organ systems. There is a lot of differentiation. And finally, majority of them, they do undergo sexual reproduction. So these are certain general characteristics of kingdom Animalia. Now let's look at the subdivision or categorization, because we'll be looking at these one by one from the NCERT perspective. As I told you, animals, if an animal is only at a cellular level, that means there is no tissue development, there is no differentiation into different organs or tissues, they are classified as porifera. We'll talk about that. Then if tissue is organized, what kind of tissue is organized? If there is no body cavity, we have two categories, that is colenterata and platyhelminthes. If there is a pseudocolum, as I told you, if there is no true cavity inside the body, they are categorized into colenterata, platyhelminthes and nematoda. But if they have a true cavity, they are called as columate. If they have true cavity, and they are further subdivided into Annelida, mollusca, arthropoda. And if the column is formed from pouches pinched from the endoderm, there is advanced differentiation. Then we have echinodermata, then we have chordata. Now when we divide this chordata, we will get protochordata and vertebrates. We are the vertebrates, and we have different classification in vertebrates also. Now I'm quite sure by now you are a little flabbergasted. You're thinking, sir, how do I remember all these things? These names are highly complicated, right? There is no need to mug up these things or focus on say very typical kind of words or tough words to remember. But from exam perspective, I would like you to just keep a track of this classification and certain examples, especially from the vertebrate class. All right, so let's begin our discussion. As I told you, the first classification is at the cellular level, that is porifera. Now from the name itself, the root word here in porifera is pore. That means these organisms, they are made up of pores, or they have holes in them. Have you seen a cartoon or animated series called as SpongeBob and SquarePants? So remember SpongeBob, right? SpongeBob that SpongeBob SquarePants, right? That is nothing but an example of porifera itself, because they have holes in their body. Generally, they are non-motile, although SpongeBob does move. Generally, they are non-motile. They are attached to some solid supports. They have pores, and how do they feed? That water enters through their body. They do not have any true column. They do not have any true cavity. So water circulates throughout their body, and water provides them food and oxygen. Mixed with water, food and oxygen is basically from that itself. All right, and these animals are covered with hard outside layer or some sort of a skeleton, right? But there are a lot of pores. Many examples can be seen. There is Spongilla, there is Cycon, there is Euleptecula. These are all examples of porifera. They have pores in their body. SpongeBob, right? Let's talk about next classification. There is Colenterata, or it's also called as Nidaria, right? So these animals, they also live in water. They are aquatic animals, right? These are some of the pictures. You must have seen Hydra. If you cut Hydra, it can grow. Colenterata example is Hydra and sea anemone. Their body is not symmetric per se. These animals, they show some amount of differentiation. Yes, there is a body cavity, but it is not a true cavity. Their body is made up of only 2 layers of cell. Our body is made up of 3 layers of cell. We are triploblastic, but these are only diploblastic. There are only 2 layers of cells, outer layer and an inner layer. So many of these species like Hydra, sea anemone, they live in colonies. Wherever there are corals, you will find these animals. All right. Again, they are also dependent on water for the food and oxygen requirements. Next is Platyhelminthes. I'm quite sure you must have heard about Platyhelminthes, although you did not know probably the name Platyhelminthes, but you must have seen examples, especially of tapeworms. These are parasites which are found inside our body, inside human body or inside animal body. There are many examples of Platyhelminthes. There is Planaria, there is liver fluke. Then there is tapeworm. Tapeworms can be very long. They can be from few centimeters to even meters they can reach in terms of their length. They are complexly designed. Please remember, they are complexly designed, and their body is symmetrical, meaning if I draw a line right from the midway of this particular animal or organism from the planaria, I will see that there is symmetry on both the sides. And these animals, from here we will see, from Platyhelminthes, every other organism in kingdom Annula, it will have 3 kinds of layers. They are basically triploblastic. They are called triploblastic organisms. There are 3 layers of differentiation. In these animals, you do have cavity, but there is no true form of cavity. You do not find that GI tract kind of cavity, but there is some kind of cavity, and in general they are quite free living, and they are generally, when they are found inside human body or animal body, they are endoparasites. They live on other organisms. They rely on other organisms. For example, flatworms, they are parasitic, right? These are Platyhelminthes. Now, apart from Platyhelminthes, we have 2 other subclassifications: nematoda and annelids, right? Nematoda and annelids. Now, nematoda, you must have seen nematoda also. These all give you diseases if they are found in your body. Example is Ascaris and Wucheria, right? Ascaris and Wucheria. Now, these are also some sort of parasite, but they give you large diseases. Nematodes are, again, they are bilaterally symmetrical. When you cut them, you'll find some sort of symmetry in their body. They are also triploblastic. They are generally cylindrical in shape, and they do not have any real organ. All right. You must have seen many of the parasitic diseases, such as worms causing elephantiasis, right? Filaria, etc. These worms are found in our intestines as well. But very similar to nematoda, there is another subclassification called annelids. Now, annelids are earthworms. You must have seen these earthworms or leeches or nares. There is a very small difference between these nematodes and annelids. You can see here, the annelid body, first of all, it is tapered on both the ends, but you do not find that the annelids, they are not tapered. They are not tapered like them. Apart from that, yes, these also have a triple layer. a triple layer. Yes, they are triploblastic, but their body is segmented. Their body is segmented. You can see different segments here, and there is differentiation on the basis of these segments itself. From head to tail, they have segments, and they can live in different habitats. You can find them in fresh water. You can find them in marshy waters. You can also find them even inside the soil. All right, these are annelids. So there's a difference between nematoda and annelids. All right, majority of these nematodes, they are actually parasites. Right, remember this. Majority of these nematodes are parasites, but annelids, all of them are not parasites. Some of them can be parasites, but majority of annelids, they are non-parasitic. All right, they're non-parasitic. That's the major difference. Apart from that, we have arthropoda. Now this is one of the largest groups under Animalia. You must have seen many of the arthropods. Now, arthropods, classic example being the prawn, right? Prawns, crabs, etc. You find so many examples of these. Arthropoda, the meaning of arthropod is jointed legs. Wherever you find these animals with jointed legs, they come under the subcategory of arthropods. And arthropods are also bilaterally symmetrical. You cut any arthropod, right? You cut a cockroach, you cut a butterfly, or you make a half or equal cutting of any prawn, you will see that the body is rather bilateral. All right, they're bilaterally symmetrical. And remember, in arthropods, they have open circulatory system. This open circulatory system, the entire blood, it reaches a place called as hemocol, and the oxygen is transferred, and the blood is filled in the coulombic cavity. As I told you, it's called hemocol, right? All the blood is mixed here, and the gas transportation. There are many examples: butterflies, spiders, scorpions, crabs, prawns, etc. So many examples of arthropods. Right? If you're a non-vegetarian, you might even like consuming these arthropods. Especially many people do enjoy prawn, crabs, etc. Apart from that, we have mollusca. Now, mollusca are aquatic animals. The classic example among mollusca is octopus. Their body is also symmetrical. They are bilaterally symmetrical. They have a coulombic cavity, but it is reduced. They have a true column, but it is reduced. But they do not have too much of segmentation in them. All right. Apart from this, they also have well-developed circulatory system, which is open. They also have kidney-like organs for their excretion. Many a times, these mollusks, they can have limb-like structures which are used for movement. Classic example being the octopus, the uniopilla. You can see these examples, mollusks. Apart from that, we also have echinodermata. Echinodermata are mostly aquatic organisms. By the name itself, echinodermata, please remember them to be circular aquatic organisms, right? Echino means hedgehog-like, spiny mammals, right? They are spiny. They're spiny skinned organisms. Examples being your sea star, sea urchin, feather star. They're mostly round in shape. And these animals, they do have a true coulombic cavity. They are triploblastic, and they are peculiarly found in water system. They also have different calcium carbonate structures as their skeleton, very similar to the arthropods. They also may have calcium carbonate based exoskeleton. Apart from this, there is one more. When we enter into the realm of chordata, that means having vertebra, having your vertebral column. One classification is protochordata. Protochordata means where the vertebral column is not completely developed. One of the classic examples of protochordata is this balanoglossus, where there is a notochord. There is a notochord, meaning there is a vertebral column, but it is not well developed. Yes, this vertebral column, it is connected to the nervous system. Nerves may be spread, but in the protochordates, the notochord present at all the stages, it is not completely developed. They may not have a properly developed vertebral column, but they do have they do have the presence of vertebral column, but not a well developed vertebral column or the chordata. Protochordata organisms or animals. And finally, we enter the most important realm or most important subgroup called as vertebrates, vertebrata. Now, these animals, they have a vertebral column and an internal skeleton. That means they have a notochord, they have nervous system, they have a dorsal nerve system. They are also triploblastic, 3 layers of skin. Many times, if there are aquatic animals, they do have gills or pouches for breathing, for respiration, and they are also columnate. Columate means they have a true column. They have a true column. That means they have a true body cavity which is protected by triple layers. And we divide vertebrates into 6 different classes: cyclostomata, Pisces, fishes; amphibia, reptilia, aves, and mammalia. These are the 6 sub-classification under vertebrates, right? They are vertebrata, meaning they have vertebral column. The first under vertebrates are cyclostomata. Now, you must have seen a classic example of cyclostomata would be, I would say, eel, right? They are eel-like structures. They do not have any jaws. Yes, they do have vertebral column. They do have vertebral column. They are elongated eel-like structures with circular mouth, slimy skin, and scales, mostly aquatic. This is the example of that petromyzon, a jawless vertebrate, that is petromyzon, something like this, mostly aquatic organisms. Apart from cyclostomata, we have many aquatic animals under Pisces. Now, Pisces is a subgroup which basically includes all the fishes. All the fishes. Now, fishes are aquatic animals. They do have a vertebral column. They have 3 different layers. They have true column. They have developed organ system as well. But their outer layer is scaly. You can see if you take any kind of fish, any kind of fish, say it is a stingray or any kind of electric fish, whale, etc. First of all, they have some sort of symmetry. They are bilaterally symmetrical. They have a vertebral column right through the middle. On outside, they have scales. Their body is scaly. Apart from that, their body is hydrodynamically developed, meaning for easy swimming, their shape is such that they can pass through the fluid very easily. Apart from that, for respiration, they have developed gills, very similar to how humans have nose, right? We need oxygen. They also need oxygen, but they take in the dissolved oxygen from the water, and that is why they have well developed gills. And there are many examples of this, right? They also have other developed tissues, other complex tissues, like they have cartilages, tendons, like ligaments, etc. If you are a non-vegetarian, you must, if you have consumed fish, you must have seen they have a very fine bone structure, right? Very fine bone structure. That's basically through the vertebral column. They also have the nervous system developed, right? Pisces. Now, apart from Pisces, there is another subgroup of amphibia. Now, amphibia are amphibians. That means these amphibians, they can be found in water also. They can be found on land also. There are many examples of this. There is frog, there is toad, there is hyla, tree frog, there is salamander, right? Remember, but there is one specific thing about them. These organisms, they also have scales on their body. They also have scales on their body. Again, amphibians can have gills or lungs. They can have gills or lungs. And for their reproduction, they lay eggs. They are not mammals. They lay eggs. And where do they lay their eggs? They lay their eggs in water. Very, very important pointer for amphibia. Amphibians, they live on land and in water also. They have outer scales. They may have gills or lungs, or they may have both also, right? And they lay eggs inside water. Then there is a school, or there is a subgroup of reptilia. Now, these are reptiles. Now, these reptiles are cold-blooded. They also have scales, but they breathe through lungs. They do not have gills because they stay outside. All right. So they have lungs for breathing. They have lungs for the gas transfer. There are many examples: chameleon, king cobra, turtle, etc. All these are examples. And remember that these reptiles, they lay eggs, but they lay eggs on the land. That is why you must have seen these turtles, right? The example being those olive ridley turtles. Every year there is a nesting season. They come and they come and nest, right? Gahir Mata is one of the places where you'll find a lot of eggs laid by these turtles. So turtles, lizards, crocodiles, etc., they all fall under this category. All right, meaning they do not need water to lay their eggs. Yes, they might be present in water. Many times you must have seen snakes inside water, turtles inside water, but for breathing they have to come out. All right, they are excellent swimmers as well, right? This is reptilia. Apart from reptilia, we have another subgroup, aves. Now aves, it basically translates to birds. Now birds have a vertebral column, but the bones that comprise of this vertebral column, they are hollow. The bones of birds are hollow. Why? Because they need to be light in weight, because they are airborne. They also have feathers. They have design of a feather. They have a four-chambered heart. And they have feathers. On the feathers, there is some sort of a waxy layer to protect them from dust, from water, etc. All right, and all birds, they fall under this particular category, and they can fly. And finally, it's us, mammals. Now, when I say mammalia, first of all, they are warm-blooded. And they do not lay eggs. They give birth to young ones. Meaning, directly they give birth, and they also have mammary glands so that they nourish their young ones. All right. So mammals, they have four-chambered heart. They have glands for production of milk. Their skin has hairs. They also have sweat and oil glands. They have a vertebral column, a well-developed vertebral column. They have a well-developed organ system, the nervous system, right? There are only a few mammals like the platypus, and there is echidna. Platypus and echidna, they lay eggs. These are few mammals, they lay eggs, but majority of the mammals, they do give birth directly to the young ones. That is why we divide them into the mammalian class. So mammals, humans are example of mammals. Dogs are example of mammals. Dogs, right? Cow, rats, bats, whale, all these things are examples of mammals because they give birth to young ones. All right. So this is the classification of kingdom Animalia. A little complicated. There is no need to mug up these complicated words as well, but just try to remember this particular classification where you see that how do we divide Animalia, kingdom Animalia. As I told you, it is dependent on the level of differentiation. If there are simply cellular organization level, it is called porifera. As soon as tissues develop, then we develop them into other schools, that is Coelenterata, Platyhelminthes, Nematoda. Then if they are columnate, that means if they have true column, then we divide them into annelid mollusks, Arthropoda. We have Echinodermata, we have Chordata, Underchordata, Protochordata, and vertebrates. Under vertebrates, 6 important schools. We have Cyclostomata, Pisces, Amphibia, Reptilia, Aves, and mammals. Remember certain examples, that would be more than enough, that would suffice from exam perspective. All right. Right. So that's the end of today's discussion. In the subsequent class, we will discuss the topics from physics. Motion. Now, what is the meaning of motion? Motion means anything which is in movement, which changes its position from point A to point B. Motion means any body changing its position from one location to another location. And motion is a part of our life every day. In fact, right now I'm simply standing stationary. I'm talking, but I'm stationary. But if you look at it from a macro perspective, the entire universe is moving. We know the Big Bang, universe is expanding. The earth is revolving around the sun. Earth is rotating on its own axis. The planets are moving around the sun. So everything is in motion, right? Motion, it forms the basis of universe itself. The atoms, in the atoms, the electrons are moving. In our body, blood is moving continuously. So things are in motion at every point, at every second. But how do we describe this motion? Motion can be very complex. But in this particular discussion, we'll talk about motion in a straight line. We'll try to define certain parameters. How do we assess motion? How do we calculate different parameters or different dimensions connected to motion. We'll talk about motion in a straight line. It can be a motion in circular path. We'll talk about circular path, or it can be a motion in any other kind. For instance, it can be oscillatory motion, it can be vibration. Motion can be different types. We have discussed about that in class 6, class 7. We'll build that knowledge. Today's interaction would be to understand motion of objects in a straight line. We'll try to express certain parameters. We'll try to define certain dimensions or variables, like what is distance, what is displacement, what is speed, velocity, all these things. Right, let's begin. First thing, how do we describe a motion? As I told you, motion can be very complex, but one of the simplest idea to describe a motion is an object moving from one point to another point. It may be in a straight line, it may not be in a straight line, it may be in a circular path, it may be vibration, oscillation, etc. But simply, a motion is something where an object is moving from one place to another place. That means now this particular point, it is called as the initial reference point. Say for instance, today, to reach to my class, now I had to come from my home till the class to the office. So what is the motion? I have covered a distance from place, that is my home, till here. So I need a reference point, right? Now, when we say motion, how do we describe it? From a reference point, we see how far it has moved, from where to where it has moved, how fast it has moved. That means how much time did I take to reach. For instance, I reached from my home to office. How much distance I covered, how much time I took to cover this particular distance. I use these dimensions, these variables to describe the motion. Was it uniform? Say for instance, if I came in 10 minutes, I covered a distance of 2 kilometers or 3 kilometers in 10 minutes. Was it by uniform motion? Was it non-uniform motion? All these things would be understood. Apart from that, in which direction did I move? I came from home to office. What was the direction? Was it due east? Was it due west? Or was it some other direction? Apart from that, what was the rate of the movement? Now, these are some of the variables that we need to understand to describe a motion. Now, let's talk about motion of an object in a simple straight line. As I told you, motion, the first parameter is how far something has moved, how far it has moved. Now, this is a reference point A and reference point B. As I gave you example of myself reaching from my home to my office. Point A is, say, my home, and point B is my office, right? Now, I have reached from here to here. We define two parameters to understand this motion. One is called as distance. Distance is a scalar quantity. Here, I do not look at the direction. I only look at how much distance, how many meters have I covered. All right, say I started from my home. I took avenue A, and then I turned towards left, then I turned towards right. I don't look at these directions. I reach from point A, from one road to another road, from one road to another, point B. This is the amount of distance that I covered. Again, distance is a scalar quantity where I do not bother about the direction that I take. It simply talks about the magnitude of how much ground I have covered, or how much ground the object has covered. From point 1 to point B, how much distance I have covered. There is another variable or another dimension that we can define, that is displacement. Now, displacement is a vector quantity. This distance is used to calculate my speed. We'll talk about speed in some time. Displacement is used to calculate my velocity. So by this you already understand speed is a scalar quantity, velocity is a vector quantity, because distance scalar, displacement is a vector quantity. Vector means it needs to have some sort of direction. For example, I told you I came from my home to my office. This was the route that I took. But if I draw a straight line from A to B, that becomes your displacement, and this is the direction of displacement from point A to point B. So this is the magnitude, this is the distance, or this many meters I have covered, and in this direction, that is how displacement is defined. It's a vector quantity. So how far does it move? Through distance and through displacement. Always remember, displacement always has a straight lined path. Distance can have any kind of path, any curved path. Distance is the total ground or the total meters it has covered to reach the destination. The next aspect is how fast does an object move? How have I reached I've reached from office home to office. How? By how much speed? Now here characterization can be done through two bases. One is through speed and another is through velocity. Now speed is basically the calculation of your distance. Speed is basically the calculation of your distance that you cover, how much distance you have covered divided by how much time you have taken for traveling, the time of travel. This will give you the quantity speed. But when you talk about the idea of velocity, velocity is a vector quantity. For velocity, the time of travel, that means the denominator is going to remain same, but the numerator is going to change from distance to displacement. Clear? So these are the two variables that we use, speed and velocity. So speed is a scalar quantity, velocity is a vector quantity. It is ratio of distance by time, it is ratio of displacement by time, scalar and vector. Speed does not have any kind of direction. Speed does not have any kind of direction. That means, say for example, I come from my home to my office, which is say 3 kilometers, and I cover that distance in 1 hour. So my speed would be 3 kilometers per hour. In 1 hour, I am completing a journey of by a speed of 3 kilometers per hour. Velocity is a vector quantity. Its direction, that means it simply takes displacement, meaning from home to the office, a straight line is drawn which talks about displacement, and how much displacement has taken place in how much time, that gives you the velocity. All right, so very important. What does this signify? Speed in any direction would be same. Say for instance, if a speed in one direction is 25 meters per second, speed in other direction would also be 25 meters per second. But velocity has a direction. If this is positive aspect, if this is positive velocity plus 25 meter per second, then this would be negative velocity. And say imagine I reach from my home to my office by traveling on a cycle, right? On a cycle, and at one point of time, and I'm traveling at a speed of 5 kilometers per hour. The next moment I'm traveling by 3 kilometers per hour. The next moment 2 kilometers per hour. So what would be my average velocity? Sorry, average speed. Average speed would be total distance covered divided by total time taken. So average speed is, it's a complete distance covered divided by complete time taken. Whereas average velocity, it differs. Average velocity is your initial velocity plus your final velocity divided by 2. Since the vector quantity, it is u plus v by 2. Please remember these things. Again, there is no need of numericals or solving mathematical problems here, but you need to understand the concepts from a UPSC examination perspective. So we have understood two aspects. One is how far do we move? Second one is how fast does something move? Direction is also very important, right? So if velocity is needed for us, velocity is important, then any aspect connected to velocity, it is connected to direction as well. The next is, how is the rate of this particular movement? If I reach from point A to point B by maintaining a constant velocity, constant speed, it's called uniform motion. There is no change in speed or velocity. So uniform velocity, uniform motion or non-uniform motion is the next aspect. Meaning, if I divide the entire journey, let me take up the board here. Say this is point A and this is point B. Now, if I divide this entire journey from point A to point B, it has some distance, some time traveled. Say X is the distance that has been covered and T is the time that has been taken to cover this. And if I divide this entire journey into different segments, then I will see that during this particular period, the distance would be same, the time taken would be same. That means X1, T1 would be same. So this is called as uniform motion. When I divide this segment, if you take any kind of ratio of distance by time, all these would be same. That amounts to uniform motion. But if these things are different, it becomes non-uniform motion. And many a times in our life, we do not encounter with uniform motions a lot, right? Our normal transportation is actually through non-uniform motion only, right? But there are many examples of uniform motion. For instance, an oscillatory motion, a pendulum moving, a uniform kind of a motion, or something moving at exactly constant velocity. That can be example of uniform motion. But many times we do have non-uniform motion. A non-uniform motion is one where there is no, a non-uniform motion is one where the speed or the direction it changes continuously. But for a uniform motion, the direction remains the same, the speed also remains the same. So for a uniform motion, at any point of time, the average speed would be the instantaneous speed, because at any point of time on a straight line, the speed or velocity would be same because the direction is also same. But here the instantaneous speed and average speed would be different. If you draw a graph of distance and time, uniform motion would be defined something like this, and a non-uniform motion would be anything, not just this. An example is this, but anything can be non-uniform motion apart from the straight line that I have drawn here. All right. Now, to define some other parameters specially connected to non-uniform motion, we know in a non-uniform motion there is a change in speed or there is a change in velocity. Either the speed changes or the direction changes. That means velocity is changing, meaning the body is either accelerating or decelerating. And this rate of change of velocity in a non-uniform motion, it is called as acceleration. It's called acceleration. Now, acceleration is defined by change in velocity divided by the time taken. And in simple terms, acceleration is defined, or acceleration is denoted as acceleration is equal to final velocity minus the initial velocity divided by the time taken of the travel. Now, what does this acceleration signify? Acceleration, again, it depends on velocity. That means it's a vector quantity. It depends on the direction. It can be positive, it can be negative. So say I am a runner. I'm running a 100-meter race. Initially, my speed is say 4 kilometers per hour. Suddenly, I start running fast. I increase my speed to 5, 6, 7, 8 kilometers per hour. That means I am accelerating. But after I reach my end point, after I cross the line, finish line, I would be stopping. That means I'll be reducing my speed from 9 kilometers or 8 kilometers to 7, 6, 5 slowly. That is called as negative acceleration. It is also called as deceleration or retardation. Please remember, acceleration can be positive or negative. It is defined as rate of change of velocity. And the classic example of acceleration can be understood from gravity concept. So you must have seen this. Now, in our physics, gravitational laws, they do tell us about the force of gravity. The force of gravity, Earth's gravitational force, G, is calculated by G into M by R square. All these parameters are connected to Earth because any other body, its mass would be minuscule in comparison to Earth's mass, that we know. And when we calculate this, Earth's gravitational force or Earth's gravitational constant, it comes out to be 9.8 meter per second square. And this is the unit of acceleration as well. The SI unit for acceleration is meter per second square. Please remember this. And acceleration due to gravity is 9.8 meter per second square. What does this mean? What does this mean? This means that if I drop anything from a height, Earth is attracting that particular body with some kind of force, gravitational force, and because of which the body is accelerating. With more time, with more height, its velocity increases. For instance, if I drop a ball which is at rest, meaning its initial velocity would be 0. But after 1 second, it is going to accelerate to 9.8 meter per second. Its velocity is going to increase at 1 second. The very next second, this is going to double, 2 into 9.8 meter per second. The third second, it is going to increase to 3 into 9.8 meter per second. Huge. You must have seen this. That is why, say, imagine if a coconut falls from a coconut tree, and if it falls on your head, you're going to get injured. Why? Because it is falling from a height and it is traveling. Say, imagine if a coconut, this is not an apple, imagine this is a coconut, okay? At initial level, at t0, its velocity or initial velocity is 0. As soon as it falls, after 1 second, its speed increases to 9.8 meter per second. Next second, its speed is going to double. Third second, its speed is going to triple. The number of seconds it travels, its velocity is going to increase more and more. That is going to, it is going to accelerate more and more. And when we talk about the force with which it is going to fall, the force with which it is going to fall is equal to m into acceleration, how much it has accelerated, and that force would be immense. And if it falls on your head, that is why you get injured. Right? That's why you must have seen in many animated movies, or if you've witnessed any videos or any graphic videos in which an asteroid it comes, or a meteoroid comes into Earth and it hits, it's going to create a huge dent. Why? Because it is coming with a mass and it is continuously accelerating because of the action of gravity. And once it hits the impact, it is going to create a huge dent. Right? We have known about meteoroid lakes. Example is the Lonar Lake in Maharashtra. It has been created because of a meteoroid entering into Earth atmosphere, eventually hitting Earth with a huge speed because of the gravity. All right? Right. Now, apart from this, we can also describe motion through graphical representation. We understood distance, we understood time, distance, time, speed, velocity. So we can draw different kinds of graphs to describe motion. And this is very important. Many a times MCQs can be formed asking or setting up these graphs and asking you what kind of a motion is it. So first we can draw a distance and time graph. Distance is drawn on the y-axis and time is drawn on the x-axis. And if distance is remaining exactly same, that means the body is actually not moving, meaning the body is at rest. This is the distance time graph of body which is at rest. And if the body is in uniform motion, that means it is moving at a constant speed, constant velocity in the same direction, then the graph would be something like this. This is a graph of a body in uniform motion. And if the body is in non-uniform motion, then the graph can be anything. This is a non-uniform motion. This is a non-uniform motion, right? Anything. It can be any kind of drawing. But this is a graph where the speed is increasing, and this is a graph where speed is decreasing. All right. But please remember, there can be some questions which can be framed when I ask you that if I calculate the area under distance and time graph, what does it signify? Please remember, distance time graph area does not signify anything. It does not signify any kind of quantity which is measured. All right. Again, from mathematical perspective, we can come out or we can arrive at something for sure, but the area in the distance time graph, it does not represent anything that we measure connected to motion. But the slope, when I calculate the slope of a distance time graph, see, this is the graph, and when I calculate the slope of this particular graph, it will give me the speed of that particular object at that instant. For instance, at this particular time, if I check out the slope, then I will get the speed of that object. So we can describe a motion in graphical way by creating a distance time graph. We can also create a velocity time graph, right? Velocity to be drawn on the y-axis and time to be drawn on the x-axis. Now when I draw this, and if it is a horizontal straight line, that means the velocity is not changing. With time, the velocity is remaining exactly same, meaning it is a concept of uniform motion. If it is uniform motion, that means there is zero acceleration. Now this is a graph for uniform motion. Zero acceleration, it's not accelerating. Similarly, if I draw a graph where velocity y-axis, time is on x-axis, and if I draw a line like this, or if it is rising, then it is constantly accelerating, and if it is going down, it is constantly decelerating. That means velocity is reducing with the time. That means it is retardation or deceleration. But please remember, when I calculate the area which is under the velocity time graph, I get the displacement of that particular object. When I calculate the area under this, I get displacement. And similarly, when I calculate the slope under the velocity time graph, it basically gives me what kind of acceleration is there. Is it positive acceleration? Is it acceleration? Or is it deceleration or retardation? So the area under velocity time graph, it gives me displacement. The slope, it is going to give me the acceleration. Apart from that, we can also draw acceleration time graphs as well, although this is not mentioned in the NCERT, but we can always draw acceleration and time. And if it is a horizontal line, you do know it is constantly accelerating. Again, it is a non-uniform motion where acceleration is constant, and this one is uniformly accelerating, this one is non-uniformly accelerating body. And area under the acceleration time graph, it gives me the concept of velocity. And whenever I get a slope, I calculate the slope of this particular graph, this line, then this is going to give me a concept called as jerk. What kind of jerk is felt? Is it a positive jerk where the movement is going forward, or is it braking? You can feel the jerk because of acceleration, also because of deceleration also. So at any point of time on the acceleration time graph, I calculate the slope, it is going to give me the quantity called as jerk, that is the rate of change of acceleration. Clear? Right. Again, on the basis of this, different mathematical questions can be created, not very important for us, but they'll be very relevant in your physics concept, in your NEET, JEE, etc. All right. Now, apart from that, there is an idea of equation of motion. Now, for this, there is a lot of calculation, etc. It has to be done to prove these ideas, but equations of motions have already been defined. V is equal to u plus at, where this V is equal to the final velocity, u is equal to initial velocity. This a, it stands for acceleration, and t is the time instant. So there are three equations of motions which have been defined. V is equal to u plus at, that means final velocity is equal to initial velocity plus acceleration into time. Distance that is covered, it is equal to initial velocity into time plus half into at square, acceleration into square of the time, and v square is equal to u square plus 2as, or 2as is equal to v square minus u square. This is the third equation of motion. These are used in numericals. Many a times in examination, especially in 11th and 12th, you do get a lot of theoretical concepts on this. To prove how do you arrive at this, you can arrive at this from the graphical format or even through first principles as well. Now, whenever we are talking about a motion under the action of gravity, this a changes to g. That means v is equal to u plus gt for a motion under action of gravity. Similarly, s is equal to ut plus half gt square for a body under the action of gravity. Similarly, the third equation becomes v square is equal to u square plus 2gs, and g here is acceleration due to gravity. G is equal to 9.8 meter per second square. All right. Now, apart from this, we also need to establish some ideas about the circular motion, because we will be building on this in our subsequent classes. Wherever we get some basic ideas of physics which are relevant for us, we will be taking them. Uniform circular motion. Now, till now what we established is motion where something is moving from point A to point B, and if this point B is nothing but point A, we reached to a circular track. All right. Now, this is a rectangular track, this is different kind of shape track, and this is a circular track where once you start from point A, you will be changing your direction and you will be reaching to point A again. Now, this is called as a circular motion. A classic example being, you simply take a string, tie a stone to it and try to revolve that. You will get circular motion of the stone, right? Circular motion. And for any circular motion, the velocity or the speed, it is given by the distance traveled. How much distance are you traveling? For one complete rotation, you are traveling a distance of 2 pi r. And how much time do you travel to cover this distance 2 pi r? V is equal to distance by that particular time, where the distance is the circumference of that circular motion divided by the time taken. Now, generally, for instance, uniform circular motion can be seen on a track, on a running track, or uniform circular motion can be seen with your earth. Earth is revolving around the sun at a uniform circular rate. Earth is revolving around its own axis at a uniform rate itself. That is nothing but some sort of circular motion itself. All right. So this is the basics of circular motion. We will be building on this in our subsequent discussions as well. So please remember about scalar quantity. We have discussed that before. Scalar quantity is something which is only defined through magnitude. Vector is something which is defined through magnitude and direction. Distance is scalar, displacement is vector. Speed is scalar, velocity is vector. If velocity is vector, acceleration is also a vector quantity. Do remember all these things and about simple ideas of motion. In our subsequent discussion, we'll move ahead and talk about another topic. All right, today's discussion is about force and laws of motion. All right. Now, as I told you in our previous interaction itself, in this world, everything is in motion. In our body, blood is in motion. The entire universe is continuously expanding. Earth is revolving around the sun. So motion is something that has flummoxed many scientists, many people, many physicists, theorists, many philosophers as well. How do we define motion? How do we understand? What is the cause of this motion? Is force the cause of motion? So we have understood what is force as well. So we do understand for something to be in motion, there has to be some force acting on it, and that force need to be unbalanced, right? That is how something starts into motion. So we'll talk about forces, how motion starts, why a body will be in rest, and then we'll jump into the laws of motion given by Isaac Newton. Many physicists like Galileo Galilei, Isaac Newton, they have worked on this, and they have given us some established rules and regulations. First things first, what is force? We have already established force is either a push or a pull. In our previous interactions, we have also discussed and categorized different kinds of forces. Contact force, right? Muscle force is a contact force. Friction force is a contact force. But there are many non-contact forces. Classic example being gravity, right? If I drop this pen is going to fall down on the ground. Why? Because a non-contact force is working on it, which is called as gravitational force. We have discussed other non-contact forces as well. For instance, the electrostatic force, the magnetic force, all these are non-contact forces. So a force can be a push or a pull. It can be a contact force, non-contact force. And in our day-to-day interaction, we use force for some sort of motion. For example, this kid is moving this trolley. You must have gone for shopping, and in shopping cart, if you go to Reliance Smart or More Shop or any other shop, you will get a trolley like this. You put things in it and then you push. Now, how is this trolley moving? This trolley is moving because this kid is applying force in this direction. That is why the trolley is moving. Similarly, if I have to take something out from my cupboard or my drawer, what do? I draw this out. The drawer is being pulled out, meaning I am applying some sort of force on it. Similarly, the kids here are playing hockey. Now, whenever you hit this ball, this ball starts in motion. If you do not hit it, the ball will be at rest. So the question is, why this ball is at rest and why this ball is in motion? Because when something is in motion, there is always a concept of unbalanced forces. So we need to understand that if there is any body, there are different kinds of forces acting on it. And whenever these forces are balanced, then there is no change in the state of motion. If something is at rest, it will remain at rest. Now this picture, it classically explains what is the meaning of a balanced force. You can see here there are three people on this side and three people on this side, and they are pulling a rope, tug of war basically. And if the forces are balanced exactly in opposite direction, now in this side there is 300 Newton, this side there is 300 Newton, then the mean position of this rope, it is not going to change, meaning the rope would be rather stationary like this. The position would be exactly there. So whenever there is an object or a body on which equal forces in opposite direction are working and they are exactly balanced, that means there is no change in the object, or there is no change in the motion of that object. Clear? But if something starts in motion, or if the state of motion is changing, that means there are unbalanced forces which are acting on it. This is a classic example. There are three people on this side. That means they are employing a force of 300 Newton in this direction. But there is only one person this side who is applying a force of 100 Newton. Now what is going to happen? There is an unbalanced force here. What is the net unbalanced force? the net unbalanced force is 200 Newton due this side, meaning this person or this rope is now going to move towards this side with a force of 200 Newton. That means whenever a body or an object is set in motion, meaning the forces or under balanced forces, it was in rest, and as soon as these forces become unbalanced, it starts into motion. Again, classic example, whenever we try to push a box. See, we discussed about the frictional force. Now, these two people are employing a force on this particular cupboard or a box on this side, towards this side. Now, the friction force is acting. Whenever they are pushing it, the friction force is resisting the motion, meaning the amount of force that they have applied, the friction force is exactly balancing it, and the movement does not start. So what do? They try to push it more harder. Now, these two people are now using all the energy that they have, and again employing force F1, but they are not able to cross the frictional force. The frictional force Fn is again equal to this. That means the body will still be at rest. So this body is at rest. This body is at rest. Now you do know friction force depends on the contact, meaning there is some sort of interlocking happening between this surface and the box. That's why there is friction force which is acting. But these two people, they gather more energy. They take a few breaths and decide that we are going to move this block. Now both of them, they employ a force F2. Now this F2 is much higher than the frictional force here. Whenever the force F2 is higher than frictional force, meaning now the box is going to go in this side. It is going to move in this side, meaning there is now unbalanced force acting on the box. That is why the force is towards this direction. The box is also going to move. Clear? So if there is a change in state of motion of an object, that means there are some unbalanced forces which are acting on them. That's the idea of force. And based on this knowledge of balanced and unbalanced forces, we need to understand Newton's laws of motion. When a body gets into motion, what are the characteristics of that? Isaac Newton has given 3 laws of motion. The first law states every body continues to be in state of rest or of motion in a uniform straight line unless and until it is compelled by an external force to act otherwise. If a body is in rest, I put an unbalanced force on it, it starts to move. If a body is in uniform motion in a straight line, I apply a force, it is going to stop, right? That is the first law. The second law states the rate of change of momentum is directly proportional to the force that is applied, and the motion is in the direction of the force. The third law, my favorite, for every action there is equal and opposite reaction. So let's try to understand each law more thoroughly. As I told you, first law, it states that every body, every object, it tends to remain at rest or it tends to remain in a uniform motion along a straight line unless some unbalanced force is acting on it. The best way to understand first law of motion is I simply keep this particular pen. I simply keep this particular pen on the table. I've kept it, I've left it. I come tomorrow, the pen is there. I come day after tomorrow, the pen is there. I come after a month, the pen is still there. Why? Because balanced forces are acting on it. The pen is undergoing balanced forces. It's basically its weight and the gravitational force are acting on it, and it is at rest. It will remain in rest till what time? Till I apply some force and pick it up. Till I apply some force and move it to another direction or another position. So the tendency of a body, if a body is in motion, it tends to be in motion, or if a body is in rest, it also tends to be at rest. So first law of motion, it gives you 2 important features or 2 important characteristics. One is the idea of friction and another is the idea of inertia. Now let's try to understand both of these. Now when I talk about friction, Newton's first law, it basically lays the principle for friction, the idea of friction. Now what it says, every body continues to be at rest. Let's not talk about rest, but let's talk about uniform motion. Meaning, say I am a cricketer, I have hit a ball. I have hit a ball. Now the ball is in uniform motion. It is going in a straight line towards the boundary, but it does not reach the boundary. Why? Because there is some sort of an unbalanced force which is continuously acting on it, and that is called as friction force. Friction is a force which depends on the contacting surfaces, and friction is a force which always opposes the motion of that ball, right? So first law, it basically lays foundation to the frictional force. Frictional force is an unbalanced force that causes an object to stop, that causes or that brings an object to rest. That is the idea of friction. And the second important concept that Newton's first law gives is the idea of inertia. Idea of inertia, meaning if any body it is at rest, it tends to remain in rest only. Because even if you try to apply some force, let me just explain through this. Now, I gave you this particular example. Newton's first law, it clearly satisfies here, right? This particular box or a cupboard, it is trying to remain at rest only. If they apply the force, the frictional force is balancing it. It is trying to remain at rest only. It will move only when the unbalanced force, it is more than the counteracting force, in this case frictional force. So every body tends to be at rest. If it is in motion, it tries to remain in motion. Now that concept or that entity is called as inertia. Inertia. Now you must have seen this example that if something is in motion, I suddenly try to obstruct it. What is going to happen here? Now this body has stopped, but the ball here, they are in motion along with this trolley. As soon as I stop it, the balls try to continue their motion. This is called as inertia, and this kind of inertia is called inertia of motion. But if something is in rest, for example, I have kept a small playing card here on which there is a coin, and if I flick that card, along with the card, you expect the coins also to move, but the coins do not move. Why? Because the coins were at rest. Even if some force is applied, they tend to remain at rest. They tend not to move along with the card, and they fall down in the glass. Similarly, you must have seen while playing carom, you must have seen during your childhood, you must have played carom, and through this striker, when you hit hard on this pile of coins, you will see only the bottom coin will move, and the top layer or the top tower of those coins, it remains as it is. Most of the times you must have seen it. Why? Because inertia of rest is working here. The coins, they tend to remain at rest. That is the idea of inertia, which comes from Newton's first law. Now when we talk about inertia can be of three types. If a body is at rest, it tends to remain at rest. For example, this coin, it wants to remain at rest. The pile of coins, it tries to remain at rest. Similarly, if I take a carpet, you do know there is a carpet. On that carpet, there is dust. Now, those dust particles are at rest. The carpet is also at rest. But as soon as I give a push or I put that carpet into motion, you will see that the dust particles, they come out. Why? Because the dust particles, they tend to remain at rest only, and the carpet I'm trying to move, and the dust particles eventually settle, they come off. Why? Because of inertia of rest. Similarly, there can be inertia of motion, meaning if I am in motion, then suddenly if I brake, my inertia of motion, it pushes me forward. You must have seen that in a bus or a train or anywhere you are traveling. That is why they tell you to wear a seat belt. If you do not wear a seat belt here, what is going to happen? You are in motion, the car is in motion, along with the car you are also in the motion. But as soon as the car stops, suddenly the car motion has stopped, but you are trying to resist that motion because there is inertia of motion in you, and you will be thrown out of the car. That's why seat belts are extremely important, right? There is inertia of motion. There can also be inertia of direction. There can be three types of inertias: inertia of rest, inertia of motion, inertia of direction. You must have felt that again whenever you're turning, if you're going through a topsy-turvy road, or say hilly road, you must have seen they are like these wavy roads, and at the bends, at the turns, you tend to shift. See, if I'm driving, I'll move along with the direction of the train, basically opposite to the turn that I'm taking, because my body tends to resist the change in direction. And inertia of rest or motion or direction, everything, it depends on the mass of the body. Please remember this. It depends on the mass of the body. So first law of motion, every body, it tries to remain at rest, or it remains at rest, or it remains in uniform motion along a straight line, unless and until it is compelled by an external force, an unbalanced force, to act otherwise. The second law of motion, it talks about the concept of momentum. It basically lays the ground for calculating the amount of force. Force is basically mass into the acceleration. Newton's second law, it defines force to be equal to change in momentum per time, which ultimately leads again to this. The derivation of F is equal to ma, it comes from the second law of motion. And second law of motion is seen almost everywhere. What is the meaning of momentum? Momentum basically means mass into the velocity of a particular body. Momentum is calculated, it depends on mass and the velocity. M into V is basically the momentum. And this particular law, it leads ultimately to the derivation of the concept of force is equal to mass into acceleration. And in our day-to-day lives, everywhere we see this. The second law, rate of change of momentum, is directly proportional to the force, and the direction or the motion, it is in the direction of the force itself. That is what happens, right? You must have seen. Now, a cricketer, if he tries to catch a ball, the ball has certain momentum. Right? The ball has certain momentum, mass into velocity of that ball. Now, if I'm trying to counteract, if I simply hold it like this, the ball is going to get into the hands and pop out. But if I try to catch it like this, there is balancing of that force, and I try to counteract the momentum of that particular ball. Everywhere we use this concept, right? The second law of motion, I would say it can be employed almost everywhere. Here also, when you see a person is pushing this particular box or a cupboard, F is equal to m1 into a, m2 into a, depends on the momentum. F is equal to ma is ultimately derived from that itself. Say for example, any sport, let's talk about long jump. Now in long jump, what happens? A person is going to run for a specified amount of length. That means they are going to run, they are going to increase their velocity. The mass is same, they are going to increase their velocity, and from that particular point they are going to go for a long jump. Similarly, you must have seen, say if I want to push something, say if I want to push a car, what do? I take a step back, and I try to push it. I try to give momentum, I try to increase my momentum and transfer that momentum so that a body is set into motion. So second law is employed almost everywhere, it is used almost everywhere. It gives you the concept of F is equal to ma, mass into acceleration. It also defines force to be basically this, force to be equal to the change of momentum per time, ultimately leading to the concept of acceleration, right? All right. The third law of motion is my personal favorite. It's very easy. For every action, there is equal and opposite reaction. That means if a force is acting in this direction, there would be an opposite force acting from the other direction. The classic example of this being when you shoot a bullet, when you fire a bullet, you will see if I fire, the bullet is pushed towards this. The bullet is accelerating in this direction. When this accelerate, you will see I have imparted the push to this bullet by using a spring or a coil, and that spring is going to recoil, and that recoil is going to push you in the opposite direction. You must see, that's why whenever soldiers are practicing, or whenever soldiers are aim practicing, they do hold the gun by giving support to the shoulder, right? They hold it something like this, because when the bullet is going in the opposite direction, a force is shot here, and if you are not holding that gun properly, you cannot aim properly. For that to be balanced or stabilized, you give your support. There are so many examples of this. As I told you, bullet is one example, meaning the bullet is accelerated, there is a recoil in this direction. Similarly, if there is an action, see, first action is this particular boxer is pushing, this particular boxer is hitting on another boxer's jaw, but the jaw is also exerting a force. That's why you must have seen whenever if you must have seen in movies, etc., that if a person is beating some other person, yes, that person would be injured, but you will also get some amount of injuries on the hand that is beating. Why? Because for every action there is equal and opposite reaction. Similarly, when you are exerting, when you are just getting off a boat, you will see that the feet is putting a force this side, the boat would go this side. The boat exerts some force on the feet, and that's how you can move easily. The basic idea that we use in rocket propulsion, all the space-based applications, they use this idea of for every action there is equal and opposite reaction. Why? Because fuel is burnt and this exhaust or hot gas comes from this side, and if the hot gas comes from this side, the rocket moves up in the opposite direction. So this force of combustion, force of exhaust, is pushing the rocket in the opposite direction. It helps in takeoff. For every action there is equal and opposite reaction. So these are 3 Newton's laws of motion. Pretty easy. You have studied all these things in your school days. Let me just sum it up, right? Review of Newton's laws. The first law of motion, it basically gives you an explanation of friction as well as the concept of inertia. It states an object remains in rest or in uniform motion unless it is acted by an unbalanced force. The second law basically defines the force. Force is basically equal to ma, mass into acceleration. F is equal to mass into acceleration, or force is equal to change of momentum per time. The third, it gives you action reaction principle. For every action there is equal and opposite reaction, right? So these are 3 forces, 3 laws of motion, right? That's it. In this particular discussion, we'll meet again in our NCERT series with the next chapter. Please note that we are not focusing on any sort of derivation, any sort of theorem or theoretical stuff. We are trying to understand more and more through examples, through discussion for UPSC Civil Services preparation. Today's agenda is to discuss about gravitation. All right. In our previous discussions, we spoke about motion. What is motion? What is force? Different laws of motion. Today, we'll talk about gravitation, and we see that on Earth, we have Earth's force of gravity. Why am I standing still here? Why am I connected with the land? If I take this pen and if I simply leave it, the pen is going to fall down. It is going to fall down and it is going to come to rest as soon as it lands on the land or soil. Why does that happen? It happens because of a force called as gravitational force. One fine day, Isaac Newton was sitting under an apple tree. It's a story where an apple fell on his head. Then he started thinking, why did it fall downwards? And then he came up with the idea of gravity, the gravitational force. Now, gravitational force is always a centripetal force. That means which acts towards the center. A simple exercise can be conducted because Isaac Newton started to think that apple fell down on earth, but there is sun. Why is the sun not falling on earth? There is moon. Why is the moon not falling into earth? What is happening? So he theorized laws of gravitation. A simple exercise can be conducted, as I told. Take a string and attach a stone to it and simply rotate it in a uniform circular motion. You will see that this string will always be in tension. That means some sort of force is acting continuously, and as soon as the tension in the string, it goes down or it goes to a lower level, the stone is going to fall down. It is not going to follow the circular path, right? Now, why is this happening? The gravitational force is a centripetal force which always acts towards the center. That means if this is Mother Earth, the gravitational force always acts towards the center of that particular body. This was established by Newton. Now, there is another force which is a counter force to this centripetal force. It is called a centrifugal force. Centrifugal force means a force which acts away from the center of this circular motion. Remember, centrifugal force is a pseudo force. It's actually not a force per se, but it is a pseudo force to balance the centripetal force. In a uniformly revolving motion, centripetal force always acts towards the center. Centripetal acceleration is provided, and in a circular path, if you take the direction of that particular object, say for example this football, it continuously changes its direction. If it is in this, if it is at this instant, the direction is this side. If it is here, the direction would be this side. If it is here, the direction, that means the direction of motion is continuously changing, but the force that is acting everywhere, it is acting towards the center. Centripetal force. The opposite of centripetal force is centrifugal force, which acts away from the center. In fact, the centripetal force, it is a real force which we have seen during the gravitational interaction, or it is also seen during the electromagnetic interaction. So centripetal force is a real force, whereas centrifugal force is a pseudo force to balance the centripetal force. This is a pseudo force. Please remember this pointer. Very important. All right. Now, based on this knowledge, what we can establish is, imagine this is Earth, right? The moon is revolving around the Earth. Earth is revolving around the sun. And if there is no gravity, if there is no centripetal force which is acting, then in absence of such a force, what is going to happen? If I take the example of this stone, it is wherever the centripetal force now becomes zero, the stone is going to move in that particular direction. Imagine if there is no centripetal force acting between moon and Earth, then the moon would be getting out of the orbit in a straight line, right? Now this force is holding everything together. That is how we can explain the motion of moon around the Earth. This is due to centripetal force. There is some sort of centripetal force which is continuously holding moon together in a uniform motion, and once this force is gone, now this centripetal force is basically the balance between gravitational pull of Earth and gravitational pull of moon. So net force is acting towards this. And if centripetal force is absent, imagine centripetal force is zero, then the moon would be thrown out of the orbit in a straight line. But because of this centripetal force, which is called as gravitational force, moon is revolving in a uniform circular orbit around Earth. Same concept applies for Earth around the sun. And that is how Newton came with the universal law of gravitation. He was just thinking that because of the gravity between sun and Earth, Earth is right now balanced in its orbit around the sun. Same applies for Earth and moon. Moon is now in the orbit of Earth. Then he thought, if apple is falling on my head, that means some sort of force is acting on this apple, and that force is bringing it towards Earth. Meaning Earth and this apple are interacting. And Newton asked the question, if Earth is pulling that apple towards it, is the apple also interacting with Earth? And he said, yes. He came to a conclusion that every body in this universe, it attracts another body with a force called as gravitational force. Right? So gravitation, universal law of gravitation, it states that every object in universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the distance between them. That means the closer they are, the more is the force of interaction or force of attraction. This is the universal law of gravitation. Now, if you're thinking that if I am here and if there is another person standing here, am I attracting that person with the gravitation force? Yes, according to universal law of gravitation, every object, it attracts every other object with the gravitational force, and that force, it depends on the mass. So gravitational force, it depends on mass 1, that is, if body A is attracting body B, then it depends on mass of body 1 and body 2 and the distance between them. This is the gravitational force. So if you have to calculate, you will see the gravitational force of attraction or gravitational force between sun and Earth. This would be mass of sun, mass of Earth divided by distance, square root of the distance between Earth and Sun. So you will find with how much gravitational force the Sun is attracting the Earth, you'll get that value. And this G is basically a constant. So what Newton basically established is that the gravitational force between two bodies is directly proportional to the masses of that body. That means if there are two bodies, M1 and M2, then the force would be directly proportional to M1 and M2 both, but it would be inversely proportional to the square of the distance between the two. And eventually what we end up with is the gravitational force is directly connected to M1 M2 divided by the square of difference between these two. And if you remove this proportionality sign, you get gravitational constant. And this gravitational constant was eventually calculated by Henry Cavendish, who gave it a value of 6.673 into 10 to the power of minus 11 Newton meter square per kg square, right? That is the value of G. Now using this value, we can calculate the gravitational force or acceleration due to gravity of Earth as well, right? So no need to get into numericals connected to this from exam perspective, but simply if I have to calculate the gravitational constant, what do? I use the gravitational force into multiplied by the distance between the two bodies and m1 between the two masses. By using that, Henry Cavendish calculated that. Now this concept is very important. The universal of law of gravitation, it explains so many things. It explains how the gravity works, or why on Earth everything is connected to it. I'm standing on Earth right now. Why? Because of action of gravity. If I am at this location, if I throw a ball, if I leave a ball, in which direction the ball will go? Towards the center of the Earth. If I'm standing here, if I drop the ball, it will again act towards center of the Earth. If I'm standing here, if this is a flight and this flight is continuously attracted by the gravitational force of Earth, in which direction? Towards the center. That means always centripetal force acting towards the center of that particular body. So law of gravitation, it explains why all of us are binded to this Earth. It also explains why moon is moving around the Earth, why planets, why Earth, why Mars, why Jupiter, they are revolving around the sun, because of the same concept of gravity, gravitational force, or force of attraction between these two bodies. And it is quite measurable when m1 m2 are high. Please try to understand, because universal law of gravitation, it states that every body attracts another body with some sort of force, but as soon as mass 1, mass 2 would be very, very small, the value of this gravitational constant is of the tune of 10 to the power of minus 11. That means that force would not be registered if the bodies are extremely small. That force can be registered or can be felt if the bodies are very big with huge masses. For example, the gravitational pull of Sun is higher than any other planet. Gravitational pull of Jupiter would be higher than that of Earth, because the mass of Jupiter is higher than Earth. So that's the basic understanding. Apart from that, we also understand a lot of concepts from gravity. For example, why do we get tides? What is the reason for high tides? What is the reason for low tides? What are spring tides, neap tides? All these things would be understood by using the concept of gravity itself. So let's talk about some of the important concepts connected to gravity. I hope by now you have understood the universal law of gravitation. Let me summarize. Every object attracts another object with a force called as gravitational force. It depends on the masses of the two bodies and the distance between them, and of course the gravitational constant, which has a very small value of the order of 10 to the power of minus 11. Now let's talk about some of the ideas connected with gravitation. First thing is acceleration due to gravity. Now acceleration due to gravity, what is this? Now we all know acceleration due to gravity. If I drop something from a height towards the Earth's surface, it accelerates continuously. This we have already established. It accelerates every second with a speed of 9.8 meter per second continuously, meaning at time 1 second, it will be 9.8 meter per second. At time 2 seconds, it is going to be double of this particular value. Now how did we arrive at this particular value? Again, it comes from the laws of motion. Newton's second law of motion, it clearly states that mass into acceleration is equal to force. Now, when I say I drop a body, I drop this particular apple from some height. Now, the mass of this particular apple, imagine it to be m. Now, what is the force that is acting? Force is equal to mass into acceleration. From that height, it would be mg. Now, this force is equated to the gravitational force. Now, when I do this, I get the value of g. I get the value of g because the weight or mass of this particular apple is very, very small. I end up with a value of 9.8 meter per second square. This is acceleration due to gravity. And if I drop anything from some height, then it continuously accelerates till reaching till the surface, right? So acceleration of gravity can be understood, and we get the value of g to be this. This is the gravitation, acceleration due to gravity on Earth. But acceleration to gravity on other planets can be different because it ultimately depends on this particular mass. Meaning, the higher the mass of the celestial body, the larger would be the acceleration due to gravity on that particular celestial body. Now, this concept of G has also led us to understanding of laws of motion for a body which is falling. Now, we have already established the equations of motion. V is equal to u plus at. V square is equal to u square plus 2as. S is equal to ut plus half at square. And these change appropriately for a falling body. Wherever we have a, you will get it as acceleration due to gravity g, and wherever you have s, that is distance, now it becomes height. So v is equal to u plus at transforms to v is equal to u plus gt. Please remember gt. S is equal to ut plus half at square. It transforms to h, because now we are not talking about distance. Again, distance in terms of height. H is equal to ut plus half gt square. Similarly, v square, the square root of final velocity, is equal to square root of initial velocity plus 2gh. So accordingly, the laws of motion also change for a falling body. Another concept which is very important for us to understand is the difference between mass and weight. Now, mass, it depends on the matter. It depends on the matter. But weight of any body, it depends on the force that is exerted on that mass by gravity. So please remember, mass is basically depending on the matter. It never changes. For instance, if my mass is say 72 kg, my mass is 72 kg, it will remain 72 kg at all the places, be it earth, be it moon, be it anywhere. But my weight would be different depending on the acceleration due to gravity. Here is a classic example. Say imagine there is a body which has a mass of 50 kg or 50 kg approximately translates to 110 pound, right? How much does it weight becomes? Weight is a concept which is connected to gravity, right? Gravity. So a mass of 50 kg, basically a mass of 50 kg, it equates to 490 Newton weight. So the unit of weight is Newton. All right. Similarly, as I told you, it depends on the gravity. And if we calculate the weight of an object on moon to weight of an object on earth, the value translates to 1:6. That means if a body has a weight of 1, if a body has a weight of 1 Newton on moon, the same on earth would be 6 Newton on earth. So what have we established? Mass is the meaning of that matter. Mass is composed of protons, neutrons, atoms, basically whatever the matter is made up of. It never changes. Please remember, it never changes with the location. Mass of an object is always constant. It can never be zero, but weight of an object can be zero depending on the gravity. If gravity is zero, it can be zero. So mass of an object never varies with the location, but weight of an object, it varies with the gravity. With the gravity. Remember this. How do you measure our mass? By a balance. How do you measure the weight? By a spring balance. The unit is different. This is kg and this is in newtons. All right. Right. Now, Apart from this, as I told you, the concept of weight, it depends on the gravity. And if my weight on earth is x, my weight on moon would be 1/6 of that x. Why? Because the acceleration due to gravity of moon is less. So you can see wherever earth's earth's value we know 9.81 meter per second square. Now this is acceleration due to gravity on earth. But if we go to other planets, say for instance Mercury, its acceleration due to gravity is lower. Venus is more or less similar. But if you look at moon, it is 1/6 of the acceleration due to gravity on earth. Similarly, Jupiter, Saturn, Uranus, they have higher acceleration due to gravities owing to their higher mass. So this is a comparative chart of how much would be the weight on different planets. For instance, if the weight of one particular object on earth is say 100 newtons, then on sun, because of its gravity, hypothetically its value would be 2707 newton. Similarly, it would be lesser than earth on Mercury, lesser than earth on Venus, lesser than earth on Mars. So please remember, these three bodies are smaller than earth in comparison in terms of the mass of these celestial bodies. But as soon as you reach Jupiter, Saturn, Uranus, there if you see, for Jupiter it is 234 newtons, for Saturn it is 106 newton. All right, so please try to understand, almost similar kind of acceleration due to gravity is seen on Uranus as well as Venus, very close to 9 the value. I hope it's clear the difference between mass and weight. Weight depends on location, weight depends on gravity. All right. Apart from this, the gravitation can also explain the concept of tides. Now, if you live in coastal areas, you will see that your parents must have told you, or people told you, whenever there is high tide, do not venture into the seas. Why? Because the tides would be very high. But why do we see this? In a day, we see high tides and we see low tides. Now, why these tides occur? These tides occur because of gravitational interaction between Earth, Moon, and Sun. Majorly because of Moon's gravitational pull. As I told you, two bodies, if one body attracts another body with some sort of gravitational force, that means Earth attracts the Moon with some sort of gravitational pull. Moon also attracts the Earth with some sort of gravitational pull. And because of this, we see tides. For instance, whenever, because of the location of Moon, we see that in a day coastal areas experience two low tides and two high tides every approximately 24 hours. That is depending on the location of the Moon. On the location of the Moon and rotation of the Earth, we will see the Moon attracts the water, and that is why you get a tidal bulge, which is called as high tide. And at this location, you will also have a high tide region on the opposite side. Why? Because the tidal bulge here is less due to gravity than the center of the Earth. So in a day, you get two instances of high tides and two instances of low tides in 24 hours. Apart from this, because of interaction of gravity between Moon and Sun, we also have a concept of spring tides and neap tides. Whenever we get Earth, Moon, and Sun in a same line, we get spring tides. Spring tides, right? Moon can be on this side because you do know Moon, it revolves around the Earth. So whenever Moon is in straight line with Sun, you get spring tide. But as soon as the Moon, Earth, and Sun, they come in some sort of perpendicular projection. For instance, Moon is somewhere here, Earth is here, and Sun, it's always here. You do know that because Sun is stationary, Sun is fixed, and these things revolve around the Sun. So if a projection is something like this, then you will get neap tides. All right. So spring tides, neap tides, high tides, low tides, these are all concepts connected to your gravity, interaction of gravitational force between Earth, Moon, and Sun. So tides can also be explained using concept of gravity. Apart from this, there is one more very interesting concept of buoyant force. the force of buoyancy, which can be explained using the concept of gravity. Now we have already established the concept of pressure. In our previous discussion, we have seen pressure. What is the meaning of pressure? Pressure is the perpendicular force that is acting on one particular area, and this perpendicular force we call it as thrust. You know, thrust is a force that is exerted on a body, on a surface, perpendicularly. For instance, I'm standing right now on the ground. That means thrust is being acted upon on the ground, on the soil, because the force is acting perpendicularly. And what would be the pressure? What is the pressure that I'm exerting right now on the land, on the soil? That is perpendicular force. Thrust, it is measured in newtons. So thrust divided by unit area, that gives you pressure, and pressure is calculated as in Pascal, that you know. That is why you must have seen, for instance, say I'm standing right now on the land. Imagine I am now in desert. So when I stand in desert, probably my feet are going to enter into the soil, probably half a feet, 1 feet into the soil. Why? Because the pressure that is being exerted on sand is more, right? That's why you will see that your feet will enter inside. Now similarly, what happens is, now I lie flat on sand. What is going to happen? Nothing. I do not go inside the soil, right? Why? Because now the area is more. That's why the pressure is less. So I hope you get the concept of thrust, pressure, area. We have discussed this before also. Pressure is equal to thrust by area. Now why we discuss this? Why are we discussing this? Because pressure is not just exerted by solids. We have already established in our previous interactions that pressure is exerted by liquids as well as gases. We have seen this, that liquid exerts pressure. Classic example being this, right? You take a water bottle, then you put a balloon here. You will see, because of the pressure of this liquid, you will see water entering this. Or if you simply put two holes into this bottle, you will see the water is going to, it is exerting pressure, and because of this pressure you will see the loss of water. In fact, it exerts equal pressure in all the direction, and this pressure, it depends on the height of the liquid or height of the fluid, right? We have established this. Now based on this concept itself, we are going to understand another idea of buoyancy. You must have felt this, right? You must have felt, whenever you enter a swimming pool, you'll feel light. Why do you feel light? No, see, my mass is 72 kg. Weight would be approximately, say, if I multiply it by 9.8, let me just round it up to 10 meter per second square, I would be getting somewhere around 705, right? 705 Newton. So my mass is 72 kg. My weight would be 705 Newtons. But as soon as I enter into water, I'll feel much lighter. Now, if I have a spring balance, you will see that my weight would have reduced. From 705 Newtons, approximately 700 Newtons, it would have reduced. But why? Why? Because whenever a solid body is left in the liquid or in the fluid, there is always a buoyant force which is acting in the opposite direction. That is why you'll feel a little lighter, and that's why you must have seen some things float on the fluid, some things sink in. Why? Because this buoyant force may not be enough. For instance, if I take a simple beaker and first I drop a pin. Now this pin is made up of iron. Now this is water. Imagine this is water. Now what happens is, the pin, it is going to sink in. Why? The amount of buoyant force that is acting on this pin and the amount of thrust or the pressure that the pin is applying, it is more than that. That's why it is going to sink in. Now you must be already thinking, sir, then what happens to ship? What happens to other things which float? We'll talk about that in some time. But you will see the same kind. If a wooden cork is taken and if it is thrown in water, it is going to float. Why? Because there are two things which are working. First one is the weight of this. Let me just erase this a little. You will see that first force is the weight of this particular cork, which is already acting. But a liquid or fluid is also exerting some sort of buoyant force or the force of buoyancy. It is already acting on this, and you will see that more than this weight, the buoyant force is there, and that is why it is floating. That's why some things float on water, some things sink, and this buoyant force, it depends on the density of the fluid. It depends on the density of the fluid. Clear? So gravity is working on this. This is the mass of the object, so weight of the object would be m into g. So this m into g, if it is higher than the buoyant force, that is, say, let me just denote it as fb. If mg is greater than fb, this is going to sink. If fb is greater, then it is going to float. And this fb, it depends on certain things. It depends mainly on the gravity of the fluid. So based on this itself, Archimedes' principle has been found out. Archimedes, he came up with this concept of displacement of that particular fluid, and that gives you the buoyant force. Now he said, if I take an object, if I immerse that in a liquid, he realized that as soon as I immerse it, first of all, the water level in this beaker, it goes up, meaning it has accommodated that particular object. So he said buoyant force can be calculated. How? Simply by using a weight. If I immerse some weight in the water, this water is going to be displaced. That means the water column is going to rise. And once I calculate how much water has been displaced, that would be the buoyant force which is acting on that mass or object. So buoyant force, it basically depends on three things. That is, its formula is rho Vg basically. That is volume of the displaced fluid based on Archimedes' principle. How much volume is displaced? Apart from that, density of the fluid and the magnitude of the gravity. So buoyant force is equal to the density of the fluid into the volume that has been displaced on the basis of Archimedes' principle into the acceleration due to gravity. And there's a very interesting story behind this Archimedes' principle. Archimedes, a Greek scientist, one day he was taking bath in a tub, and as soon as he entered into the tub, he was working on this for a very long time, and as soon as he entered into the tub, he saw that the water from the tub, it fell out. Then he mentioned eureka. That means he got that idea. It dawned on him that the amount of force or the amount of weight that I'm putting in, similar amount of water is being displaced, and that water displacement can be taken as a reference, and I can calculate how much is the buoyant force from the fluid. And using this particular principle, he later on found out the purity of the golden crown of the king. So Archimedes' principle is a very interesting principle based on which we have developed so many ideas. I told you that if an iron nail is simply thrown in water, it is going to sink in. But a huge ship, why it does not sink? Because if I design it in such a way, so that the volume of the water displaced is minimum, then I can ensure that the buoyant force be more and more, right? I can see this. If the volume is higher, because it ultimately depends on rho and volume and g. So I ensure that I create such a design. That it basically displaces maximum amount of volume. That means the buoyant force is more and more, and I can see a ship floating. Similarly, you will see that I can create a submarine which sinks inside, and submarine's design is such that there is low buoyant force which is acting on it. Similarly, we have designed hot air balloons, we have designed hydrometers, even the lactometers which check the purity of the sample of milk. They are found out on the basis of Archimedes' principle itself. So Archimedes, just while taking bath, it was an accidental discovery. He just went into the tub, water fell out, he said eureka, and it is said that he was so ecstatic, people thought he was mad. He started to run he started to run, as he said eureka, and he started to run out, and people thought, what is going on? But he had found out a very important principle connected to buoyant force, which changed the trajectory of history itself. Today we work on the same principle. All right, so all these things are connected to gravity itself. Everybody thinks that gravitation is about simply earth attracting things. No, gravitation is a much bigger concept. Universal law of gravitation, it states that every object, it attracts another object, whatever, however small it is, it attracts another object. But the force of attraction is not considerable. That is why when we look at the physics model, you will see gravitational force is one of the weakest forces. All right, right. So that's the completion of gravitation discussion. I hope you have gotten good ideas from this chapter. In a subsequent discussion, we'll move to the next chapter. As I told you, today's interaction is about work, energy, and power. Now, how do we define work? In our day-to-day life, how do we define work? Right now, I am working, right? For me, working is this class, right? Taking this class. So this is this work? In our day-to-day work, say in our day-to-day life, for instance, if I'm reading, do I consider reading as work? Do I consider eating as work? Do I consider playing as work? Generally, in our normal parlance, in our day-to-day life, whatever requires some sort of mental or physical labor, that is categorized as work. And if you do something for passing your time, that is not considered as work, or at least useful work. That is the basic definition or basic idea of work. But we are going to discuss in this particular lecture the scientific notion of work. What is the meaning of work in scientific terms? Let's try to understand that, right? Now, work and its scientific conception, it is based on two concepts. It is based on the concept of force, and we have already established. So let me just give you a small recap of our Newton's laws. I told you second Newton's law, it leads to the idea of force, which is equal to mass into the acceleration. We have also discussed some other aspects connected to physics, where we have seen the idea of displacement. That means an object or a thing moving from point A to point B, displacement. All right. Now, work is connected to these two aspects or these two topics. For example, there is a pen. If I put a pen on my hand like this, and if I push a pen from here to here, is the work done? Yes. In scientific terms, it is done. Why? Because the scientific notion of work is based on the concept of force. You apply certain force on some object, and there is some sort of displacement. That is the scientific idea of work. So work is basically equal to the applied force into the displacement that takes place. If there is no displacement, according to the scientific definition, there is no work done. Let's say, for example, if there is a wall, I'm simply pushing the wall, the work done is zero. I am applying the force, but the displacement is zero. There is no work done. Useless work. That's the definition from our common day-to-day activities or day-to-day life, right? So what is the idea of work? Work is the amount of energy that is transferred. One notion is this also. We'll talk about this when we discuss energy. But scientifically, from a formula perspective, work is basically force that you apply into the displacement that occurs. Again, if we delve a little deeper, then we'll understand that work, which is equal to transfer of energy, it can be said to be the product of force and displacement. And if we are applying force at one particular angle, say for example, this is a block, I can pull the block in this direction, the angle of force and the displacement will be zero. But if you're applying force in this direction and the displacement is in this direction, then the angle between these two is used to calculate work. So work done is equal to force into displacement into cosine of the angle between force and the displacement. So on the basis of this scientific explanation or scientific idea of work, we can understand that work can be actually negative, work can be positive, or work can even be zero. For instance, this little girl is pulling this car by a thread. She's pulling this car towards her. That means she's applying some force. We established that force is a push or a pull. So she's pulling. So she's applying some force in this particular direction. And you can see that the car is also moving from point A. Say, imagine it moves to point B somewhere here. Then this is the displacement. That means there is positive work being done. Means the force and the displacement, they are in the same direction. This is called as positive work. But work can also be negative. For instance, if the car is already traveling in this particular direction and I go in front of it. Imagine I am the Hulk. I go stand in front of the car and I stop it. That means the car is moving in this direction. I have applied the force from this direction. The car has come to halt. That means there is some sort of change in motion. That means the displacement is negative, meaning the work done can be negative also. So work done can be negative, work done can be positive, work done can also be zero. As I told you, work done, it depends on force into displacement into cosine of the angle between force and displacement. So if force and the displacement, they take place in same direction, what is the angle between them? The angle is 0 degrees. If the angle is 0 degrees, cos 0 is 1. So it's basically to force into displacement, positive work done. Similarly, if force is applied in opposite direction and displacement takes in the other direction, then the work done is negative. Why? Because the angle between force and displacement now is 180 degree and cosine of 180 degree would be -1, which is negative work done. But imagine a scenario where you apply force in one direction, displacement is perpendicular to it, then the work done is actually 0. Why? Because the angle between them is 90, cosine of 90 is 0. So work done can be positive, negative, or 0. That's the scientific idea of work. Clear? Right. Let's move on to the next concept. That's energy. Now, energy is very important for all of us. Life is impossible without the energy, and ultimate source of energy, we say, is sun. Sun provides us light energy, heat energy, because of which life is surviving, right? Life is running, life is sustainable. Sometimes we say, I'm innervated, right? I've lost all my energy. I want to have Glucon-D. I want to have Gatorade so that I energize myself. So energy is also used in our daily parlance, right? And energy is again connected to the concept of work itself. Energy is the ability to do that work. So work and energy, I would say, they are analogous, or many a times we can define them synonymously also. As I told you, as I showed this, force is equal to mass into acceleration, force into displacement is equal to your work done. So energy is basically required to employ this force, meaning if I want energy, if I have energy, through this energy, what I can do, I can employ force. And when I employ force, I'll be able to displace things. And if I displace things, then the work is done. That is the meaning of energy. Energy is the ability to do work. You need energy to force an object to move. You need energy to stop an object which is moving. You need energy to displace something from one spot to another spot. So energy can be in different forms. Energy can be in various forms. For example, see, right now, I have energy because of which I am able to hold this pen. I am going to push this pen from here to here. Blowing wind can have energy. Light, photons have energy. So energy is almost everywhere. Energy is something that brings motion or change possible. All right. Now, what kind of energy do we find? There are different forms of energy. Right? We find there's light energy, there is heat energy, there are so many different kinds of energy, electrical energy, chemical energy, etc. But in general, we categorize energy into two broad classifications. That is potential energy and kinetic energy. And under that, you can see the classification: potential energy. Chemical energy is the example of potential energy. Stored mechanical energy, for example, spring or a bow, that is example of stored mechanical energy. The gravitational potential energy, nuclear energy, all these are example of potential energies. There is one more classification: kinetic energy. Kinetic means something which is in motion, something which is moving, which is in motion. So electrical energy is example of kinetic energy because electrons are moving. Radiant energy, photons are moving. Thermal energy, heat is moving from one spot to another spot. That means energy is being transferred. through the atoms, molecules. Motion energy, sound energy, again vibration is moving. So broadly we categorize energy into potential and kinetic energy. So let's talk about these forms. Kinetic energy, by name itself, kinetic, meaning it is by virtue of its motion. If something is in motion, then it will have kinetic energy. All right. So kinetic energy is energy of an object by virtue of its motion. A meteor or an asteroid moving, it has energy. If it comes and hits Earth, a crater would be created. I am throwing a ball. That means this ball has energy. This ball is in motion. It has energy. If it hits me, it's going to give me some injury. If I am walking, I have energy, or I have kinetic energy. I have some sort of momentum. If I'm falling, or if I throw some object from upwards, if it is in motion, then it has kinetic energy, right? So kinetic energy is something which is because of the motion of an object. It is because the virtue of that motion. A moving object can do work, and faster the object moves, faster work can be done. So kinetic energy can be used to do work, because energy, as I told you, what is energy? Energy is the ability to do that work. And how do we categorize? For example, kinetic energy. There is a moving bullet, there is a moving ball, blowing wind, rotating wheel. Everything has kinetic energy in it. How do we define kinetic energy? What does it depend on? Now we have already established the simple equations of motion. One of the equations of motion was this: v square is equal to u square plus 2as, or v square minus u square is equal to 2as. Now if you simply reorganize this particular equation, you'll get s is equal to v square minus u square by 2a. Now from this particular section, we do understand that work done is equal to what? Work done is equal to force, mass into acceleration, into the displacement. Now displacement is this. There is no need to focus on derivation, but I want you to arrive at this particular thing, because energy or work, I told you what is energy. Energy is the ability to do work. So energy and work can be understood synonymously here. So kinetic energy would be this particular entity, and many a times if a body is at rest, it will not have kinetic energy. So we define it through this. Kinetic energy is basically half mv square. That means kinetic energy, it depends on two entities. It depends on mass of the object. Larger the mass of the object, larger is the kinetic energy. Larger the velocity of that object, larger the kinetic energy. Clear? So half into mass into square root of velocity is kinetic energy. So kinetic energy, it depends on mass and it depends on the velocity of that particular object. Clear? Right. This is about kinetic energy. Let's move on and talk about potential energy. As I told you, kinetic energy is because, or kinetic energy of an object is by virtue of its motion, whereas potential energy of any object is because of its relative position, or it is because of some sort of electrical charges in it, or some other kind of internal stress in it. The most basic idea of potential energy can be understood for a raising object. For an object which has been raised at a height, it will have some potential energy. For example, if I raise this pen from one level to this level, the potential energy of this pen has increased. And if I just leave this pen, then that potential energy is transformed into kinetic energy, and it is going to hit something. It is going to bring some sort of displacement, right? So potential energy by virtue of relative position, electric charge, or some sort of relative stress. Many examples can be found. If an object is raised, or if a spring is stretched because of the position, if a rubber band is stretched, if there is a battery, there are electrical charges, and if there is dynamite, what am I doing is I am putting so much of this igniting material, so much of chemicals at one particular spot. As soon as I ignite it, it is going to blast. Because of that potential energy, it is going to give immense amount of heat and light. So potential energy can be of various types, and there are different formulae for that. We are not going to get into derivation of that as we saw for kinetic energy. But gravitational potential energy is very simple to understand. Gravitational potential energy, it depends on mass of the object. It depends on the height from which it is falling down, the potential energy of falling object, and the acceleration due to gravity. Similarly, if a spring is stretched, what is the potential energy of that spring? The potential energy of spring, it is half kx square. K is the spring constant, x is the extension of the spring. Similarly, if there is an electric charge, then the potential energy of the electric charge would be the charge into electric field into the distance between the two plates, distance from which the charge is moving from one spot to another spot. There is no need to mug up these formulae also, but I want you to understand that potential energy, generally we have a misconception that potential energy from our school days, we simply talk about something at height. Yes, of course, because of relative position, raised object has potential energy, its potential energy will increase. Other things being electric charge, internal stresses, etc. as well, right? So these are the basic categorized potential energy and kinetic energy. The next thing is that since we have different forms of energy, do we see that one form of energy is converted into another? Yes, of course. Potential energy can be converted into kinetic energy. Kinetic energy can be converted into potential energy. For example, here, potential energy. This particular person has now pulled that string. Now, the arrow has potential energy. And as soon as I leave it, because of its position, as soon as I leave it, that potential energy is converted into kinetic energy. And how much kinetic energy it is carrying? It is carrying half mv square. The velocity of the arrow into the mass of the arrow divided by 2, square of the velocity. It is going to give you that kinetic energy, right? So one form of energy can be converted to another form. But there is one particular rule. For any object or for any kind of a system, there is always conservation of energy. That means one form of energy can be converted to another form of energy, but energy can neither be created nor be destroyed. Meaning, for any object, for any system, the amount of energy will always remain constant. That means the potential energy plus the kinetic energy, it will always remain constant. One would be transferred into another. That is the law of conservation of energy. For example, this look at this roller coaster. This particular body here, it has potential energy plus kinetic energy. Now it has potential energy here. This potential energy is transferred into kinetic energy. It reaches here. Right now here it has potential energy and kinetic energy, but as soon as it reaches top, again potential energy. That means for any system in classical mechanics, the sum of kinetic energy and potential energy of any system, of any closed system, it always remains constant. Energy can neither be created nor be destroyed. Simply one form of energy is transferred into another form. That's the law of conservation of energy. Clear? So what we understood work, we understood energy. Now we'll understand what is the meaning of power. Now, power is simply the rate of doing work. Simply the rate of doing work. Meaning, how much work are you doing in unit time that defines your power. So, power measures the speed with which the work is done. Now, that is what we established. As I told you, we started our discussion with the concept of work. We discussed different forms of energy and we said the concept of power. And as I told you, work depends on what? Work depends on the idea of force. Now we have already established force from the Newton's laws of motion. Force, that concept is equal to mass into acceleration. Work depends on this concept of displacement. Energy is basically the ability of this work. Energy is the ability to do this work. And power is this work that you do in your unit time. That's the basic idea. All right. So power is rate of doing your work, or rate at which the energy is transferred, because we established the same thing, that work done is equal to rate of change of energy. Now if rate of change of energy, we use it in the equation, then power is also equal to rate of change of energy per unit time. All right. So this is the basic connection. Work is equal to force into distance. Energy is the ability to do work, and power is the measure of how quickly the work is done. And that is why all three entities are connected through different units as well. Please try to understand, as I told you before, force is equal to mass into acceleration, right? So mass into acceleration, we get kg meter per second square, kg for mass, meter per second square for acceleration. This is denoted through a symbol of Newton. But when you multiply this Newton by meter, you get the unit for work. Unit for work is joule, which is Newton meter. Unit for energy is also same. Please try to understand. Joule is the unit of work as well as energy, because work and energy, I said that they are analogous, right? Apart from that, watt is the unit of power. Watt is joules per second, because I want to see how much work is done per unit time. The unit of time is second, right? There is one more unit that we use in our day-to-day life. Have you received your electricity bill this month? If you have received, just look at the unit. There would be some units mentioned, right? You have consumed 200 units, 300 units, 100 units, right? What are those units? Those units are again expressed as kilowatt hour. Now, why do we do it? Because the unit joule, right? The unit joule of energy or work done, it is very small. And in general, when we consume energy or when we consume power, we do it at a very extensive rate. Meaning 1 kilowatt hour of energy is equal to 3.6 into 10 to the power of 6 joules. So if I keep on calculating in joules the idea of power, the unit becomes very, very large. It becomes extraordinarily large. That's why we have created one more unit called as kilowatt hour. How much amount of work is done in an hour, or how much amount of power consumed in an hour. So this is generally that you get in your households. 1 kilowatt hour is the unit that we measure, that we express, and based on that you get your electricity bills, right? Just something that you need to know from exam perspective. Clear? As I told you, again, not a very complicated kind of discussion, because these build basics of your physics, and physics becomes more complicated as we move ahead in 10th and in 11th, 12th. More and more complicated physics based on different theorems, numericals, and proofs. We are not going to focus on those. So work, energy, and power. Clear? Right. That's the end of today's discussion. We'll meet again with the next chapter in our subsequent class. Now, see, we hear sound every day. Right now, you're listening to my voice, my sound. We hear sound of the birds chirping. We hear sounds of the wind. We hear sounds of the traffic, right? Sometimes there is sound of thunder, baby crying. So many sounds we do hear. And we have already established why do we hear that. In our previous interaction, when we discussed sound chapter from class 8, we understood how humans produce sound. We produce sound from the voice box, the larynx that we have. Two thin cords are there which continuously vibrate. That means vibrating material or vibrating objects, they produce sound waves, and these sound waves, they continuously travel through matter. Right now they are traveling through air. They can travel through matter. So all these things have been established, right? So how is sound produced? Again, the basic chapter talks about sound production. Sound is produced whenever there is a vibrating object. Humans produce it from their larynx. How do we perceive it? We have also discussed that before. We perceive it through our ears. It's a reverse process. That means sound waves, they reach inside our ear. There is an eardrum which vibrates, and the signals from that reach our brain, so that we understand that sound. We hear that sound. We perceive that sound. So sound is produced by some sort of vibration. Here, if you just simply vibrate a tuning fork, see that the sound waves are produced. And if you put the tuning fork in a glass of water, you will see the energy is transferred into that water, and the water waves will also be visible, right? So what have we established till now? We said that sound is produced, again, class 7, class 8 discussion. Sound is produced by a back and forth motion called as vibration. Sound is basically a form of energy, and this energy moves in form of vibration from one place to another place. Sound can be produced by a drum. Sound can be produced by a guitar, a tuning fork, the larynx, the voice box that we have. It produces sound. That's why the sound is reaching to you. I am producing this sound. The vibrating molecules, they are being recorded by the mic, which is reaching to the software. Then it is being transmitted to you eventually. That's how sound moves. So sound How does it propagate? We know sound always needs a medium to propagate. That means, what is the speed of sound in vacuum? The speed of sound is absolutely zero in vacuum, because sound cannot travel in vacuum. Sound needs some matter for it to travel, because sound is traveling as a wave where the energy is transferred through different particles. Say if the sound is traveling in this particular direction from point A to point B, there are different matter, and we have already established that matter is composed of different atoms, molecules, right? So these atoms will continuously move and transfer the energy from point A to point B. And for that, we need some matter. It might be air, it might be air particles, it might be liquid, it might be water, or it might be even solid. So sound travels through air. We do know that when a siren produces sound, the sound is transmitted through vibration. This vibration is taken by air. So air molecules vibrate and transfer the energy. Similarly, water molecules vibrate, they transfer the energy. All right. Right. Next, the question is, sir, how does that travel exactly? What is the format? I told you sound travels as a wave, and sound is a longitudinal wave. I'm repeating this. Sound is a longitudinal wave. All right. Now, when I say longitudinal wave, that means, see, this tuning fork, it is vibrating. And since it's vibrating, it's producing sound. That means the neighboring atoms in the molecules, they are also vibrating. And when it travels as a wave, it travels as a composition of different compressions and rarefactions. You can see here, there are many molecules which have higher energy here. That means many or the matter is compressed in one form. That means it forms the crest of the wave, and then there are rarefactions. Rarefaction means there is a gap between the atoms and molecules here. So sound travels as a means or as a wave comprised of compressions and rarefactions. So it's a longitudinal wave. It's not a transverse wave, although we can transfer this longitudinal wave on a transfer map for sure. So how is sound traveling? Sound travels, say for example, a spring. This spring gives you example of a longitudinal wave in a slinky. You can see, you just pull it and leave it. You will see how the wave propagates. You will see some compressions, rarefactions, compressions, rarefactions. So every compression corresponds to, say, the crest of the wave, and rarefaction corresponds to the trough of the wave. So once we translate this, for instance, when the speaker is speaking, what is happening? There is some sort of density variation, and density variation because of vibration of the molecules. There are many molecules, many atoms here which are vibrating, which are transferring energy. Compression, then there is a rarefaction, compression, then there is a rarefaction. All right. So we can, if we translate this into a wave, you will get a pattern like this. So what are the characteristics of this? We have also discussed that, the meaning of frequency, amplitude, loudness, which we'll just see what exactly are these features quickly. As I told you, sound is a longitudinal wave. Now, this is how we represent it when we draw it on a map. So there is compression, rarefaction. That means the wave can be drawn something like this, where there is a crest. That means this is the top, this is crest, then there is a trough. Trough means the lowest point, lowest energy point. So in this particular wave, we can define certain parameters of these waves, and that's how we say these are the characteristics of sound or sound waves. How do we define them? There are different characteristics. There is amplitude. Amplitude is the height of this waveform. Height of this waveform is called amplitude. So this is amplitude. This can also become amplitude. No issues. That means, how do we define it? First, through the amplitude. If the amplitude is high, that means the sound would be very, very louder. Then there is a concept of wavelength. What is a wavelength? Wavelength is basically a length from say one compression to the next successive compression or rarefaction. For instance, if I simply draw a wave like this would become one wavelength. One wavelength. All right. So it can be a length from here to here, or here to here, whatever you can define. Okay. So if the sound wave has higher wavelength, then it is going to travel for a longer distance. Apart from that, we also measure one more parameter called as time for one cycle. Time for one cycle. Now, this time for one cycle is time taken by two consecutive compressions or two consecutive rarefactions to cross one particular fixed point. So we will measure that in seconds. So when we invert that time period, we get the concept of frequency. This frequency is denoted by the Greek term nu. We all know that this is called nu. Nu is equal to 1 by t. This is frequency. This is called as frequency. And based on this frequency, we have already discussed what is pitch. We'll talk about that also. So these are some of the characteristics of wave that we discuss. And again, based on the amplitude, based on the frequency, we define two more terms. One is loudness. Loudness depends on amplitude. I'm repeating this. Loudness depends on amplitude. The higher the amplitude, the louder the sound. Means the amplitude, as it becomes larger, I'll listen to the sound in a very higher manner, right? The sound is very, very loud. Similarly, there is another quantity called as pitch. This pitch depends on the idea of frequency. So higher is the frequency, higher is the pitch. As I told you many times, if a mosquito comes near my ear, it's a high pitched sound. That means the frequency that the sound that mosquito is producing, the frequency is very, very high. It's very shrill to our ears, isn't it? So when we talk about this, if I say a sound is soft sound or a very loud sound, when I say something is soft, that means its amplitude is low. Just look at this amplitude. The wave disturbance is something like this, where the amplitude is very low. Soft sound. But if I say sound is very loud, just simply shout, right? There's a movie of Shammi Kapoor, right? He says Yahoo, right? There's a song. So that Yahoo is a very loud sound. When he says Yahoo, that means it's a louder sound. Just look at the amplitude of this. The amplitude is high. So higher the amplitude, then louder the sound. Lower the amplitude, softer is the sound. Very similarly, the idea of pitch. Pitch means, see, a waveform, a wave shape of a low pitch sound is something like this, where you will see that if I am talking about a distance something like this, in this particular distance you will see only one and a quarter of a wave. But in the same distance, if I check a high pitch sound, in a high pitch sound, the number of waveforms in same distance is very, very high. That means the frequency of this sound is very, very high. So if it is high frequency, it would be high pitched sound. Low frequency, it is low pitched sound. Now, based on this amplitude, based on this pitch, based on this loudness, we talk about different features of sound waves. For example, something is music for our ears, something is noise. It is based on these parameters itself, right? Now, apart from this, we also understand that the idea of loudness of the sound is measured in terms of decibel. We have discussed this before. So decibel is in form of a logarithmic scale, right? Meaning if one sound is twice the sound, that means a sound is just to be twice as loud as another if its sound level is about 10 decibels higher. Why 10 decibels? Because it is in logarithmic scale. The normal breathing sound that comes to our ears is about 10 decibels, very small. If somebody is whispering, say if somebody is talking on their phone and if they are whispering, that would be probably 10 to 20 decibels. Soft whisper is about 30 decibels. Then a normal conversation is 50 to 60 decibels. Right now, the sound that I am producing, the loudness of that is approximately 50 to 60 decibel sound. Now, apart from that, as I told you, something is music to our ears, something is noise. And this quality, it's called timbre of the sound. The timbre of the sound, it depends on the pitch and loudness of the sound or the note that is produced. When do we say something is music? Music, or if you have studied music, there are some notes and quotes which are written in the musical book. There are different notes. Those different notes are depending on the concept of tone. So a sound wave which is very pleasant to our ears, which is called rich in quality, and once it is rich in quality, the frequency changes are very subtle, and a single frequency sound, it is called as tone. So whenever we listen to music, we see that the sound would be something like this. The waveform would be something like this, where it is a single frequency sound. It will be pleasant for us to hear. But if it is some sort of a noise, the noise waveform is something like this. And again, I told you there is a very strange distinction which is slowly and steadily, I would say, getting diluted these days. There is rock, there is metal, and there is classical music. So classical music have waveform something like this, where you'll see single note, single tone. But these days, even high metallic, right? That has also become music to some people. But in general, the waveform of the noise is something like this, and the waveform of music or a tone is something like this. Clear? Right. Now, apart from this, some very important developments in chapter 9 is connected to the speed of sound and with respect to our audible range. We'll talk about audible range in some time, but speed of sound. The speed of sound is basically defined as a distance which a point on a wave, such as a compression or a rarefaction, it travels in unit time. So basically, distance can be calculated in form of a wavelength divided by its time period. So if we talk about speed of the sound, it becomes simply wavelength of the sound wave divided by the time it travels. So that becomes h lambda. Lambda is wavelength, nu is the frequency. So basically, v is equal to lambda into nu. That's the basic equation. But when we calculate the speed of sound, there are different derivations, and we end up with this formula also, where speed of sound is equal to square root of gamma RT, where gamma is basically this ratio of specific heats, R is the gas constant, which has a constant value, T is the absolute temperature. So that means the speed of sound, it depends on specific heat. That means the matter through which it is traveling. Is it traveling through air? Is it traveling through water? Is it traveling through some solid? It also depends on temperature. And when we put at 0 degrees Celsius, that means at 273 Kelvin, we get the speed of sound to be 331 meter per second in air at about 0 degree Celsius. All right. So what we have established is speed of sound. It depends on the matter. It depends on the specific heat of that matter and also temperature. So speed of sound is the highest in solids. It is lowest in gas forms, and it is somewhere in the middle in liquid. Now, this is the example from the NCERT itself. You can see here the speed of sound at 25 degrees Celsius through these metals is extremely high. Look at the speed in meter per second. In aluminium, it is 6,420 meter per second. Similarly, in case of air, I'm talking about 25 degrees Celsius. At 0 degrees Celsius, it is 331 meter per second, but at 25 degrees Celsius, it is about 346 meter per second. So air, gases, there is lower sound of speed. To liquids, it is much higher, and it is the highest in solids. Please remember this particular fact. Simple MCQ can be created that speed of the sound is maximum in which medium, or speed of the sound is maximum among which of these. Say I give options as copper, I give option as argon, I give option as water, and none of the above. In all, it is equal. 4 options can be created. Some questions like that can be made. Right. Apart from this, there is a very important phenomenon that we need to understand. Sound wave have certain characteristics. We have discussed in our previous interaction about light and the loss of reflection. There are 2 laws of reflection. First, the incident light and the reflected light, they would have equal angle to the normal to the reflecting surface, and all the 3, the incident ray, reflected ray, and the normal, they would lie in a same plane. The same laws also apply to sound. Please remember, sound waves are also reflected. That means if incident energy is hitting some particular surface, it would be reflected in other direction. And please remember, the angle of incidence and angle of reflection of sound would be same, and also the normal to the reflecting surfaces, all the 3 would be in same plane. Please remember, sound follows the same laws of reflection. Very, very important pointer. So does sound reflect? Of course it reflects. We do know that. And based on this itself, there are certain characteristics of sound which have been developed. For example, which have been defined, I would say, something called as echo. What is an echo? Echo is nothing but reflection of this sound. When I'm speaking, if you're listening to some sort of echo in the sound, then there is problem in the acoustics of the room. I'm quite sure. Yes, maybe some amount of sound echoing would be there, because it would be very tough to eliminate. But in general, when you speak in an empty room, you will see that sound, if it is absorbed in a very less way, then it would be reflected higher, more and more. And echoes are basically sound waves which are repeated, because sound waves are reflected back and forth. Sound is reflected off the walls, sound is reflected off the floor, it is reflected off the ceiling, from everywhere. And you must have heard these echoes for sure many a times. If you visit some sort of ancient historical place, you will see that you make a noise or you make a sound from one place, the echo would be heard again, you would hear your own voice back. You must have seen that if you have visited Bijapur in Karnataka. There is a place called Bijapur Gol Gumbaz. It is said that it produces amazing echoing sounds. So if you visit Karnataka next time, do go to Bijapur. There is also a place in Kerala, right? I'm quite sure many people know about this. In Kerala, there is an echo point, Munnar, right? You make a sound, the sound is echoed multiple times at this echo point. Why? Because sound is being reflected. So does the sound reflect? Of course, the sound reflects. So because of that, we see echo. We see echo, the concept of echo. All right. Now, apart from this, there is one more idea of reverberation. Reverberation. Now, reverberation is a sound which is created because of multiple reflections, because of repeated reflections of sound. For example, see, echo. Now, when you see, if I create one particular sound, now if the sound wave is reflected, that becomes your concept of echo. But many times, if you're sitting in a big auditorium, you will see that the sound reverberates also. What is the meaning of reverberation? Whatever you're speaking, that sound is not dying down immediately. The sound is staying in the auditorium or in that particular place for some amount of time, say for 2 seconds, 3 seconds. You must have experienced, especially if you're in a college and if you're in your auditorium, you must have seen the sound reverberate. You speak and the sound is not dying down, right? Say in an auditorium, when the first person comes, whoever announces, he says good morning, then he says good morning, good morning, good morning, 3-4 times. The sound reverberates. That's the concept of reverberation. Reverberation is a result of repeated reflection of the sound. And this we have seen mostly in auditoriums, in empty halls, as I told you, in the room also. If you're able to listen to my sound or my voice again and again, that is reverberation. And if it was possible to turn this camera, you would have seen that in this studio there are sound absorbing material. There are a few curtains, and there are sound absorbing acoustic panels which are connected or which are stuck here, so that the sound is not reflected multiple times and that reverberation effect is not seen. Because if that reverberation effect was seen, you would have heard something like this. When I say today we are going to discuss sound, say sound, 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 reverberation of that particular term or that particular sound. And to eliminate that, of course, we use many things. As I told you, you can go for a rough kind of plastering, you can go for draperies, you can go for some sort of compressed fireboards. These days you get many acoustic panels, special sound absorbing acoustic panels, which you can use to reduce the reverberation effect or the multiple echoing effect. Now this is what I'm talking about, elimination. But many a times what we use is the idea of multiple reflections. Since we know sound reflects, we use the idea of multiple reflections because it has a lot of utility. For instance, if somebody is using a megaphone, these days everybody is using a megaphone. I can see these days hawkers who are selling vegetables, who are selling any other equipment, they are using these kind of megaphones. Simply record this sound, and that is audible till long distance. Why? Because it is louder sound. It uses the concept of multiple reflection. The same thing happens with horn. So we see that megaphones, the loud hailers, the horns, the musical instruments, or the shehnais, they all use some kind of multiple reflection methodology to produce higher sounds. Similarly, doctors use stethoscope. The steth, right? Steth. Now, how do you listen to that? How do you listen to the heartbeat? The doctor, when he puts on the steth, right, he listens to the heartbeat, lub dub, based on the idea of multiple reflection. Still, the sound is very slow, but still, till it reaches the ears, by multiple reflections, you can hear it as an audible sound. Similarly, you must have seen, to avoid multiple reflections, if you are in your college, you must have seen the auditorium would generally be like a dome structure, or there are many sound absorbing materials. As I told you, different kinds of draperies, different rough plasters, fireboards, etc. used so that sound does not reflect multiple times. Same thing in the studio also. In the studio, I do not want the sound to be repeated. I don't want multiple reflections of the sound. That's why some equipments or some setup has been done. Right? Now, next is the idea of audibility of sound. We have already established in our previous discussions that human ear, we perceive the sound on the basis of that eardrum itself. That means the vibration of molecules or atoms, it reaches till the eardrum vibrates, and that fine vibration, the signals from that fine vibration, they reach to brain and we sense sound. And what is the audible range that the eardrum, or that we can identify, that we can sense, that we can hear, is 20 hertz to 20,000 hertz. So basically the audible range for humans, human audible range is 20 hertz to 20,000 hertz. Right? I hope you do remember that. Basically, if you want to remember it, you can remember it as 20 hertz to 20 kilohertz. 20 kilohertz. That's the audible sound that we can hear. But there are many other sounds that are produced. In general, when we look at the wavelength spectrum of or the frequency spectrum of sound, we say this is the acoustic hearing from 20 hertz to 20 kilohertz. This is the acoustic hearing range for humans. It's the human audible range. It's the human audible range, right? But any frequency which is lower than 20 hertz, whose frequency is say 19 hertz, 15 hertz, 10 hertz, 5 hertz, it is called as infrasound. Called infrasound. Infrasound, acoustic range which we can hear, and then the higher frequency is ultrasound. Infrasound means very low frequency waves, very low frequency sound waves. Infrasound. These infrasounds are normally the earthquake waves. You do know from your geography knowledge, right? P wave, S wave, etc. Those are all very low frequency waves. Those are infrasound waves. Low frequency, that means very high wavelength. That means they can travel long distance. All right. Now, apart from that, please remember, infrasound, very low frequency sound, are also produced by some animals. Rhinoceroses, they communicate using infrasound of around 5 hertz, as low as 5 hertz. Apart from rhinoceros, there are also some whales and some elephants that produce sound in the infrasound range. Infrasound range means say from 1 hertz to 19 hertz, less than the audible range. So please remember, there are some animals which produce very low frequency sound, and there are some animals which produce very high frequency sound as well. That means more than 20 kilohertz. For example, especially bats. Now you do know bats have a concept of echolation. That means they cannot see. They use the concept of echolation. As you can see, the reflection of sound, it helps bat to navigate. The bats produce some sort of ultrasound. As soon as they see the signal back, that means they understand there is an obstruction. They turn, right? So some dolphins, some bats, some animals like porpoises, they produce ultrasound frequency sound also. Please remember that. Acoustic range is this, and ultrasound is anything about 20 kilohertz. And many a times these ultrasound frequency, ultrasounds are used in many applications. Ultrasound frequency, it can travel along well-defined paths in presence of obstacles. That means if there are some sort of obstacles, it travels, since it is traveling with high frequency, it travels in a defined path. Many times it can even remove that obstruction. It has higher energy. All right, it has higher frequency. So ultrasounds are generally used to reach places where it is very hard to reach. Ultrasounds are also used in sonar navigation. Ultrasounds are used in in cleaning equipments. Ultrasounds are used to clean parts that are hard to reach. For example, a spiral tube or electronic component where I do not want something to be destroyed or something to be degraded. I use ultrasound or ultrasonic waves. Apart from that, ultrasonic waves are also used to find or detect cracks in metal bodies, since they travel in very defined path. Now I see if the ultrasound is reflected, I check the signal and I understand if there is a crack, if there is a loss of signal, there is a crack or there is a defect. Apart from that, ultrasonic waves are also made to reflect from various parts. That is used for medical imaging. You can see here, animal hearing in ultrasound range is there. Then there is medical therapy. medical therapy. Then there is acoustic microscopy also in very high frequency range, around 200 megahertz, etc. But there are many applications. For example, you must have heard about ultrasound scanning. Ultrasound scanning. Ultrasound scanning is done to understand the get the images of internal organs in human body. Ultrasound scanning is done for the brain, for the kidneys, for the lungs, liver, etc. So ultrasound waves, they travel through the tissues of our body and get reflected from the region where there is a change in tissue density, and on the basis of that we get ultrasound imaging. You do know that ultrasonography is banned for identifying the gender under the PCP-NDT Act. All right, but ultrasound is used in medical equipment. They are used to generate different images of the organs. They are displayed on the monitor, and then you get the report, etc. I'm quite sure at one point or the other time, you or your relatives, they must have gotten the ultrasound for sure, right? Even to examine the pregnancy, to examine fetus during the pregnancy, especially for congenital and other abnormalities. Please remember, during pregnancy, right, ultrasonography cannot be done, or it is illegal to use ultrasonography to find the sex of the fetus under the PCP-NDT Act. Apart from that, ultrasound is also employed these days. We have got ultrasound kind of surgeries. So small stones are broken up in kidney. There is no need for invasive surgery. Simply use high frequency ultrasound to break these stones, to break the calcium stones which are in the kidney or which are in the ureter, where they break and they can pass through urine automatically without any sort of invasive procedures. Some medical treatment methods have been developed. So ultrasound has many applications. As you can see, ultrasound has these many applications. So question can be formed, MCQ or any kind of a question can be created on this as well. Right? So that's the basic understanding of chapter sound from class 11. That's the end of today's discussion. We'll meet very soon with our subsequent discussion. Why do we fall ill? Now, why do we fall ill? Ill means something wrong with the human body or something wrong with the body. Now, to understand this concept of illness or the concept of disease, we first need to understand the idea of health. When do I say I am healthy? See, we have already established in our biology classes that any living organism is made up of cells. Human body is made up of billions of cells. Different cells combine for some sort of specialization. They are called as tissues. We have discussed tissues as well. Tissues then transform into organs, and our body is composed of different organ systems. We have discussed that also. Some ideas we have already discussed in our previous sessions when we spoke about class 7, class 8. For instance, circulatory system. Heart is responsible for circulation. We have the GI tract, the digestive system. We have the excretory system. Kidney runs it. Kidney is primary organ. So when I say someone is healthy, meaning the cells of the body, the tissues of the body, the organs and the organ systems are working in harmony. The metabolism is proper. Another important organ system in our body is a central nervous system, and brain is the key to that. So when we speak about health, we speak from a dual perspective. We say I am physically fit and I'm mentally fit, right? So health means all the cells in your body, all the tissues in your body, all the organ systems, they are working very fine. But there is another dimension to the idea of health which is connected to the society as well. Of course, yes, when I say healthy, yes, the cells are healthy, meaning I am physically fit. The mental system is working well. That means a person or a living organism has cognitive ability. They're able to think very well. Yes, they have mental health as well. But there is another dimension to health, I told you, and that is the concept of social health. Why? Because for me to remain healthy, the environment, the community, the society, it also has to remain healthy. Meaning my physical health, my mental health would be depending on the social health as well. That is why social health is one of the important dimensions. We call it the health triangle. How do we define health? We define health in terms of 3 parameters: physical health, mental health, and social health. We'll get to know about that more. So when I say social health, this is the classic example. See, different factors for a better health. One is your food, right? For your food, you need to run your metabolism. Your cells need energy, so you need to have decent food, clean food. You need to maintain cleanliness, and the society also contributes towards your health. Now, if there is untidy stuff around you, if things are unclean around you, if there are so many microorganisms around you and microorganic activities going on in a higher range, then you are susceptible to illness. That's why the NCERT talks about 5 F's. You need to ensure that the fluids, that means the water source around you, is clean. You need to ensure your personal hygiene by keeping your hands clean. Finger, the second F is finger. Third one is flies. That means cover your food and control the flies, because these flies are the carriers of diseases. They are carriers of pathogens. Fields, you need to keep your fields clean. You need to focus more and more on growing organic fruits and vegetables, meaning clean your vegetables and fruits. If you consume clean food, you will remain healthy. And finally, there is one more F of floods. That means your drainage system should be proper, because drainage system, it is the breeding ground of the pathogens. So 5 F's. I hope you have gotten the idea clearly that when I say health, it has 3 dimensions: physical health, mental health, and social health. Now the next question is, sir, what is the meaning of illness? When something goes wrong, meaning when the bodily cells, bodily organs, bodily tissues are not working in a sound manner, we call that as illness, characterized by disease. What is the meaning of disease? The root word is disturbed ease. When I say I am healthy, meaning I am physically at ease, nothing is troubling me, I don't have pain in any of my muscles, I am at mental ease, I am at societal ease. That is the meaning of healthy life, right? Meaning you are free of any sort of disturbance, physical disturbance, mental disturbance, or societal disturbance, right? So disease means a state of being uncomfortable. It means some sort of abnormality caused in my body. Now it may be because of my internal factors. For instance, say I'm feeling feverish. It may be because of some internal issue, because of the host itself. It may be caused by an external agent also, that may be pathogen. For instance, say I have become sick because of some sort of bacterial infection or viral infection. A pathogen may be responsible. Or environment can also lead to diseases. As I told you, we need to ensure water around us is clean. The surroundings should be clean. Environment, say for example, sometimes an allergen can also cause problems to me. So disease means disturbed ease. It can be caused because of any of these factors. Simply meaning there is some sort of dysfunction in your health system. Now please try to understand there is a difference between being healthy and being disease free. Health has 3 dimensions. Health is connected to society, health is connected to physical fitness, mental fitness, meaning health, mental, social, physical, and it includes individual, physical, and social environment. But remaining disease free is up to an individual. It means simply absence of diseases, and it's at the individual level. The individual may have good health, they may have poor health, but they may be disease free as well. Meaning if they are disease free today, but if they are in poor health, that means they are heading towards some sort of a chronic disease. So I hope you have understood the difference between being healthy and being disease free. Being healthy is a more broader concept. Now next, I understood, sir, what is a disease. Now I want to identify that disease. How do I do it? A disease can be identified using 2 ideas. One is symptom, another one is sign. Now, looking at these terms, they are very innocuous. So symptom, I know what is a symptom. For instance, I go to a doctor. When I say my stomach is aching, there is some sort of stomach pain, discomfort, I go to a doctor. I tell them that I have this pain in my stomach. That is a symptom. Or I say I'm feeling very nauseous, I feel like I want to vomit. Or I say I'm feeling very fatigued, I'm low on energy, I'm eternally low on energy. I just walk 10 paces, 10 steps I take, and then I feel very weak, very fatigued. So these are symptoms that you're describing. Describing to whom? Describing to a physician, to a doctor. So based on these symptoms, the doctor will look for some sort of signs. So by this, you have understood Whenever there is a disease or an illness in your body, you have some sort of symptoms which are broad, which are subjective. When I say say stomach pain, what the doctor will do? The doctor will look for certain signs. What will he ask you? He'll ask you, where is the pain? Is it in the upper abdomen, or somewhere in the middle, or lower abdomen? Probably if it is in the lower abdomen, then he might say yes, it might be issue of the gastric stuff, right? Too many gases in your body, so he might simply prescribe you an antacid or gas releasing tablet or whatever medication. So he's looking for some sort of sign. He's trying to pinpoint something. Or for instance, if you say pain, then he says, have you got any rashes on your body? So he'll see, okay, if there are rashes, probably some sort of a fungal infection, it might have impacted, and it's manifesting outside also, probably some sort of fungal infection inside. Meaning it's an idea of diagnosis. Symptom is subjective, symptom is vague, which we describe to a doctor, but a doctor will look for a sign. Sign is more indicative of that particular disease. For instance, if a fever, what the doctor will do, stomach pain, okay, let me take your temperature, let me take your blood pressure, let me check your pulse. Now these are signs. You see, signs connected to disease. So what is a symptom? Symptom is subjective, broad idea where I say, okay, I'm fatigued, I have fatigue, I feel dizzy, I feel nauseous. These are all symptoms. I feel stomach pain, I feel pain in my lower abdomen. Now these are symptoms that I describe, but the signs of that would be, say, high fever. You check your temperature, you check your pulse, right? You check your pulse, you check your perspiration rate. So these are signs. So based on these signs and symptoms, the physician or the doctor will diagnose what kind of a disease you have. Now diseases can further be classified like this. A doctor will say what kind of disease you have. He will check your symptoms and signs, and then he'll say, okay, it can be acute disease or it can be chronic disease. He'll tell you for some more testing. We also categorized on the basis of the causes. See, how do we classify? One, on the duration of the disease. That's why the doctor will ask, okay, you have stomach pain. From how many days? You say 2 days. Okay. For the past 2 days, what kind of pain you're feeling? So he will look for signs and symptoms, and then he'll diagnose if it is acute or chronic, or if it is some sort of infectious or non-infectious disease based on some testings. So first we'll talk about acute, chronic, then we'll jump into infectious and non-infectious. Now, what is an acute disease? Acute disease is a short-term disease. A short-term disease. Now, this may be because of anything. It may be infectious, or it may be because of some environmental factor, anything. But its symptoms and its signs are rather short-lived. Chronic disease is a long-term disease, something brewing slowly and steadily. So, acute disease is something which lasts for short period. For example, when I get common cold, say I have simple cough, cold, and that cough and cold would be seasonal. Right now, we are entering into the phase of rain. Season is changing. So, there is high probability that many of you will get this seasonal flu, seasonal cough, cold, which will stay with you for probably 4 days, 5 days, a week, and then it will go off automatically because your immune system will take care of it. So acute diseases are those diseases which stay there for short duration, which do not trouble you a lot. You do not feel too much tired. Yes, during that short period, you might feel tired, but not continuously. So acute diseases, they do not have any sort of long-term effect. They do not cause you serious disorders, like they do not cause you weight loss or shortness of breath or some other symptoms like that. Whereas chronic disease is something where the root cause is lying there for years together. It's more like a ticking time bomb. Chronic disease, it lasts for a long time and it gives you long-term adverse consequences. Example, elephantiasis is there. Example, say diabetes is a classic example. Diabetes, it can be a chronic disease. It is simply lying there in your body, and one day you'll feel suddenly dizzy, low blood pressure or high blood pressure, and then you faint. Then you go check, your sugar level is extremely high. Then there is something going on with your releasing of insulin or glucagon, whatever it is. You have some sort of a problem. Then you will have that problem together for a long time until you get some sort of a solution, meaning it will have long-term effects. Chronic disease. All right. We also categorize diseases as infectious and non-infectious. Now, to put it in simple terms, communicable diseases and I would say non-communicable diseases. All right. Now, infectious diseases are caused by a pathogen. It may be a virus, it may be a bacteria, it may be a protozoa. How? We catch these pathogens. Say, for example, I take contaminated food. A pathogen has entered and it is causing me problems. Or COVID-19 is a classic example. Waterborne diseases are classic example. Malaria, cholera, all these are infectious diseases because they're caused by a pathogen, caused by microorganisms. And many a times these infectious diseases, they're also communicable. That means they transmit from one person to another person through some sort of a medium. It may be directly through air, it may be through contact, it may be through water, it may be through some other vector means, it may be through a mosquito. Now here comes the concept of societal or community health, community cleanliness. Now, to take care or to get rid of these infectious diseases, or I would say to prevent these infectious diseases, I would want my surroundings to be extremely clean. Say, I am staying healthy, I am physically fit, mentally fit, but if someone else is ill, they might give me a disease. That's the idea of infectious disease. A non-infectious disease is not caused by pathogen, it is caused by some other factor. It may be intrinsic factor, as I told you, it may be intrinsic factor, host-based factor, or any other environmental factor, say some sort of allergy, or internal factor. It may be, say, genetic, right? It may be some sort of a genetic disorder, or it may be a diabetes, it may be a lifestyle disorder, it may be diabetes, it may be goiter because of the deficiency of vitamins, etc. So transmission in this case is not there. There is no transmission. Although transmission can happen from one generation to another generation, especially if it is a genetic disorder. But I hope that you have got an idea of infectious and non-infectious diseases. That's how we characterize. As I told you, causes of the disease can be immediate or can be contributory. Slowly and steadily, diseases can come. So if they are immediate, they may be caused by pathogens. They are infectious. If they are non-infectious, then may be caused by some other abnormality. But many times there are contributory factors. For example, if water is not clean, if the food is not clean, unhealthy conditions, consumption of contaminated food, if the public facilities are poor in terms of drinking water, in terms of other facilities, or in general, in terms of non-availability of nutritious food, that time also we get some sort of contributory diseases, right? So we categorize them as acute, chronic, infectious, non-infectious. Now, what are these infectious diseases? Our focus is on that because I want to learn how do I take care or how do I stop these infectious diseases. That's the agenda today. As I told you, infectious diseases are those which are caused by pathogens, and these pathogens can be anything. These pathogens can be a virus. We saw COVID-19 pandemic. It can be some sort of bacteria. It can be a protozoa. For instance, malaria is caused by the protozoa Plasmodium. It can be helminth. It can be fungus. It can even be amoeba. Right? Recently, we have seen some deadly amoebas. It causes amoebasis or deadly amoebas. The brain-eating amoebas we have seen, right? Naegleria fowleri, which was there in current affairs in recent times. So it may be any of these pathogens, and infection can spread through different means. For instance, a person is infected. That means the pathogen has already entered this person's body. Now, that pathogen has to spread. How can it spread? It can spread, say, through air. For instance, now this person has, say, COVID-19. How can the COVID-19 virus spread? We know that, right? If a person sneezes, right, even through breathing, right, the small droplets, they evaporate. So this is the zone of those microorganisms. Many a times these droplets may be carried out. It may be there for a very long time in the atmosphere. If a person touches steel plate, plastic, etc., we know about how COVID-19 spread. So it can be spread through air. One of the examples, transfer through air or transmission through air. It can happen by air or it can happen by direct contact. Say if you shake hand or through kissing. It can happen through indirect means. For example, if you are in indirect contact, for instance, say I have got some sort of skin rash, right? And say in hostels these things happen, right? Many a times your friend takes away your t-shirt. If he's going to play cricket or anything, he takes away your t-shirt, he wears it, and if you have got a disease, then he'll also get that, some sort of skin infection. So you use each other's stuff, right? You use each other's stuff. You use each other's utensils. So these can happen. Or you share food. Through food also it can happen. Or through some sort of insect. It may be a mosquito, it may be insect, it may be a tick, etc. It may be other rabid animals. So infectious agents or infection agents like viruses, bacteria, etc., they need vector, and vector can be anything, right? It can be passed through or transmitted through air, water, or through any of these indirect mediums as well. But the next question is, sir, you're only telling about spreading, but once that disease occurs, what do I do? See, there are two strategies. How do we counter, or how do we take care of these diseases? Now, once a person is sick, I have to give them treatment, right? Now, in general, I told you, if somebody has, say, acute disease, I say common cold, the immune system is going to take care of that automatically. But if the immune system is weak, if it is a pathogen based disorder or pathogen based disease, that pathogen is going to attack the immune system itself. Then in that state, we need to treat. How do we treat? We treat these symptoms. Say, for instance, the doctor diagnoses that you are getting fever because of this. They give you paracetamol. They give you some other medication. If it is cough, cold, etc., they give you some sort of medication. If it is, say, a bacterial infection, they give you antibiotic to end the cause of the disease. Meaning, I kill the pathogen itself. I take antibacterial, I take antiviral. If say I am not able to diagnose this properly, then I reduce the symptoms, treat the symptoms slowly and steadily. And what I'll do is I'll simply take rest. I treat for the symptoms, I take rest. Meaning, symptoms, they slowly and steadily go down. My natural immune system will be slowly and steadily strengthened, and then the disease will end by itself, because the immune system is now being strengthened slowly and steadily, right? That is one of the ways. Treatment is one of the ways. So principles of treatment are: try to ensure that you strengthen your immunity. One, if you have disease, if you already have the disease, take treatment, take antibiotics, take antivirals, etc., to end the cause of it, right? But there is another means also. Now, this is a step even before you get sick, something called as prevention. So we use two strategies. One is principle of treatment once the disease occurs. But even before the disease occurs, I take prevention methods. That's why they say prevention is better than cure. You know, prevention is always better than cure. Correct? Now, why do we say that? There are three reasons for it. Of course, I have a means of treatment. Say, I fall sick, I get myself treated. But what are the issues with it? The first issue is that if someone has a disease, then the disease or the pathogen that may still remain there. That means there is no guarantee they will completely recover. There might be some irreversible damage that may occur. The second reason is that treatment generally takes time. Treatment takes effort. And we do know situation in India, the out-of-pocket expenditure is very high. The insurance penetration is very low. So you will be spending too much on that. The treatment will take time. The third one is that a person suffering, especially from infectious diseases, even when they are being treated, there is a very high possibility that the disease might spread. We have seen that during COVID-19, and that is why, because of these three reasons. First is it may be infectious disease, second is it takes time, and the third one is the disease might cause some sort of irreparable damage. Because of these three reasons, they say let us not get diseases at all. That's why prevention is always better than cure. And how can I prevent these diseases? First is general prevention. Now, general prevention is more connected with cleanliness. I told you about the 5 F's, right? You need to ensure that the fluids, your fingers, right, your food, etc., are not contaminated. The proper sewage treatment has to be used. All these things we discuss. So, general prevention is ensure that things around you are clean. You ensure that you wash your hands every time. That Sachin as an ad is coming, no? You say that wash your hands. India, wash your hands so that you do not get disease. So, general prevention method. Ensure you maintain cleanliness. Ensure that the microorganisms or the pathogens, they do not spread. Do not keep contaminated food. Do not keep contaminated water. Do not consume contaminated water. Stay away from it. Go for water treatment. Keep yourself clean. Maintain personal hygiene. All these things. These are general prevention methods. But there is another idea of specific prevention also, especially against pathogens. Now that is called as vaccination or immunization. This is a specific prevention method that I use against a specific disease, that I do not get disease X. I do not get disease called COVID-19. I do not get disease called, say, a disease called the tetanus, or disease called rubella, measles. We have got hepatitis. We have got so many vaccinations and immunization that run. So I do not get that specific disease. That is called vaccination or immunization. And now vaccination and immunization, it basically works by training. Now here I spoke about natural immunity. Now here in this vaccination or immunization, what I do is I go for some sort of artificial immunity development, or something called as, I wouldn't say artificial per se, but adaptive immunity development. In our immune system, we have B cells and T cells, B lymphocytes and T lymphocytes. So what do? I train them. So how do I train them? For example, the polio vaccine. We have the oral polio vaccine. The government runs the program. There is also injectable polio vaccine also. What is that? It is inactivated virus itself, meaning I am introducing an inactive virus in my body so that my immune system recognizes that. And as soon as it is recognized, it's a weak virus, my body will produce antibodies against that. So when the proper or the strong virus enters from any other means, through any other vector, my body would be ready to fight it. That is called as vaccination or immunization. And that is why we run the universal immunization program. In India, there is immunization, which is immunization or vaccines given to women. There are different tetanus boosters that are given. For a child, you can see this schedule, right? There is a long schedule. For infants. There is a schedule during the first year, during the second year, for 24 months, etc. You get BCG. You give BCG vaccine, hepatitis vaccine. There is oral polio vaccine 1, 2, 3. There is injectable polio vaccine also, which has been introduced. We also give Hep B, Hep A, Hep B vaccines are given. Measles, rubella. We have a vitamin A dose. Then you have a DPT booster also between 16 to 24 months. You have a Japanese encephalitis vaccine that is being given under the India's universal immunization program. So what is this? These are all methods of prevention. It is based on the principle of prevention is better than treatment. Prevention is better than cure. So let's not get the disease in the first state itself. All right. So I hope you have gotten clear idea about why do we fall ill, what are the kinds of diseases, and how do we identify them, and how do we treat them. Also, how do we prevent them from occurring in the first place. So let me end our discussion for today with this particular motto: stay fit, stay healthy. So to be healthy, you need to ensure that you have physical fitness, you have mental fitness, and you also have some sort of cleanliness around your community or your society. So ensure that you have a positive, happy attitude. You get sound sleep for 7 to 8 hours. Drink plenty of water. Have good food. Have balanced diet. It should have carbohydrates, proteins, fats. It should have roughages. It should have vitamins, green leafy vegetables. So ensure that you get all these macro and micronutrients in appropriate amounts. Apart from that, ensure that you do exercise as well. Okay? That is what is the meaning of health: being physically, mentally, and socially fit. Do all these things religiously. Follow a strict schedule for this, and stay fit, stay healthy. With that note, let me end today's discussion. As I told you, our discussion is about natural resources, and we know planet Earth is the only planet which has life. It is the biosphere. It is the planet with life. We have living factors or living organisms. We have different microorganisms. We have multicellular organisms like plants, animals. We have discussed about this. In fact, we have discussed living organisms as a resource as well. For instance, forests as natural resource. But when we talk about biosphere, it consists of two different factors. One is the biotic living things or biotic factors. I discussed about this just now. Then it also consists of abiotic or non-living things, non-living resources. We all know that the ultimate source of energy is light, which is a non-living thing, abiotic thing. Apart from that, Mother Earth, which is considered as biosphere, it supports different life forms. It is considered as the sphere of life. And this sphere of life, it has three important natural resources. First one is air. Air helps in sustenance of life. Air is responsible for this biosphere. Water is responsible for sustenance of biosphere. And then there is lithosphere or soil, which is responsible for productivity. So biosphere or Mother Earth, it is composed of three spheres: atmosphere, hydrosphere and lithosphere. That means there are three important natural resources that we exploit. Not just humans, but animals, microorganisms, they all rely on these three important natural resources. Let's talk about them. We have already discussed about air, right? The atmosphere is composed of air, and every living organisms, they need something from the air. We have discussed that air composition is nitrogen. The maximum amount of nitrogen is found in air, 78% of nitrogen. Then there is 21% oxygen. Every eukaryotic cell, for instance human cell, we need oxygen. See, right now I'm breathing in oxygen. Oxygen is needed for my cellular metabolism. I need oxygen to break complex molecules into simpler ones so that my body metabolizes, and then I produce the waste metal or waste energy. The waste gases are carbon dioxide. So I need oxygen, and I exhale or I release carbon dioxide during my metabolic activity. So every organism needs something from the air, just like we animals or animals and the other multicellular organisms or other eukaryotes and some prokaryotes, they need oxygen for metabolism. Very similarly, autotrophs, that is plants, they need carbon dioxide for their production, carbon dioxide for photosynthesis. So from air, we need oxygen for survival. Plants need carbon dioxide for survival. In fact, when I talk about carbon dioxide, we have already discussed there is a very small contribution of carbon dioxide into atmosphere. Only about 0.04% of carbon dioxide is seen in atmosphere. This is enough. This is enough for the plants to photosynthesize. Apart from that, this is also very much needed for the survival of life form on the earth itself. I'm not talking about plants or animals. I'm talking about the entire biosphere, the life. Carbon dioxide is responsible for an effect called as greenhouse effect, which ensures that we have sustainable temperature or we have habitable temperature on Mother Earth. Air also has many other applications. For instance, atmosphere or air, it helps in the climate control. See, we all know sun is the ultimate source of energy. Sun gives us light and heat. So when the solar radiation is incoming towards Earth, if 100% solar radiation is incoming, because of the characteristics of air, we all know air is a poor conductor of heat. So it is going to hold on to some amount of heat that is needed for our sustenance. That means air is responsible for maintaining the heat budget in Earth, in the biosphere. That is why we see that atmosphere or air, it has a role in climate control. Sometimes we see there is a sudden increase in temperature, sudden decrease in temperature. We see winds also because of air. So one application is climate control. Another one is greenhouse effect. Because air has carbon dioxide, as I told you, the incoming solar radiation, it is trapped by the greenhouse gases. It is trapped by the greenhouse gases. Now you must be thinking, sir, I have heard that because of these greenhouse gases, climate change is occurring, global warming is occurring, and you are telling me that greenhouse effect is responsible for sustenance of life? Yes, absolutely. Because without these greenhouse gases, the incoming solar radiation, it would have gone out. That means without the greenhouse gases, without this impact, the earth would not be warm enough. In fact, if the greenhouse gases were not there in appropriate amount, then the temperature of the earth would have been somewhere in minus 50 degrees Celsius, in the ranges of minus 50 degrees Celsius. Would it help in sustenance of life? No. So air is responsible for the heat budget of Earth. Air is responsible for the greenhouse gases, carbon dioxide in it. It helps in maintaining the optimum temperature needed for sustenance of life. Yes, of course, because of the pollution, because of air pollution, because of more and more greenhouse gases, what is happening is the Earth is becoming more and more warmer. This is creating a problem for us in form of global warming and climate change. That is a separate point of discussion, but you need to understand air also plays a very important role in the greenhouse effect, maintaining an optimum temperature needed for our life. Apart from that, air is also responsible for winds. Now we have seen air always moves from a point of higher pressure to low pressure. Now because of that, we have wind systems on Earth, wind systems on biosphere. We have the trade winds, we have the other winds, we have the local winds, or we have daytime and nighttime winds. We have discussed about that. During the daytime, the warm air, whenever air gets heated up, it rises up. So this warm air, it moves towards the sea, and then we see cold breeze, cold sea breeze during the daytime, and the situation reverses during the night time. During the night time, since water retains heat and it releases heat slowly and steadily, we see that because of this residual heat of water, warm air ascends, and then there is a cool land breeze towards the seaside. So air is responsible for this as well. Apart from that, air is also responsible for the precipitation. Of course, water is also responsible, but how air helps, how atmosphere helps? As I told you, the warm air ascends upward. So along with the air, we see the water which has been evaporated, or the vapors, they are also carried to great heights, and as the temperature is reducing, they condense to form these clouds. And once the cloud saturates, we see precipitation. So now you understood how important air is for our survival. Air plays different roles. From air, we get oxygen, plants get carbon dioxide. Because of air, the heat budget of Earth is maintained. Because of air, there is greenhouse effect, and we have sustainable temperature. We have habitable temperature on Earth, on biosphere. Air also helps in formation of clouds. Air also helps in bringing the precipitation eventually. The precipitation can be in form of rain, sleet, hail, or snow. We have discussed about these as well. So air is a very important natural resource, and we need to protect it. If there is air pollution, all these activities would be disrupted. Apart from that, water is another very rich resource which is responsible for human life, and water, it constitutes the hydrosphere. 97% of Earth is covered by water, that is oceans. So we have oceans on one side, we have glaciers on the other side, we have underground water also. So water, it plays very important role for survival of every organism, be it plant or animals. We all need water. Plants use carbon dioxide and water and synthesize their food. Animals consume the food. To break down the food, we need water. For metabolism, we need water. That means water is also a very important natural resource for us, which we need to preserve and conserve. Apart from this, the third natural resource for us is soil. Now we have discussed about this as well. Soil, that is lithosphere. Now we have discussed soil has different layers, but how are those layers created? Soil at the beginning, or at the 0th time, we had only parent rock or a bedrock, parent rock. So what happened? This parent rock has been subjected to different stresses, has been subjected to different physical and chemical stresses. For example, precipitation, rain is falling. So rain is slowly and steadily breaking this parent rock. Carbon dioxide is there, oxygen is there, other chemicals are there. Those are continuously working on them. And since life is there on Earth, on the lithosphere, we have many microorganisms and different organic matters which slowly and steadily form different layers of this soil. So because of weathering of the bedrock and the parent rock, we see weathering can be because of physical process, because of physical stresses, or chemical stress, chemical reaction. Slowly and steadily, different horizons or different layers of soil or lithosphere can be seen. We have discussed this. The topmost layer is the O layer or the organic layer, which is very rich in humus, which is dark in color. Below that, we have the topsoil, A horizon. It is rich in minerals and it is also rich in humus. The organic layer and the A layer, topsoil, they constitute soil fertility. These are responsible for higher productivity of plants. And we have seen these days, because of deforestation, degradation of soil, this top layer is being degraded, and that is why productivity is going down. Below that, we have seen there is E layer, that is alluviation layer, then the B soil, which has deposited salts and minerals, then there is parent rock C, which is partly weathered rock, and eventually you have the bedrock at the end, which is the R layer or R horizon. So soil, lithosphere, has different horizons. Soil is created through a very long process. It takes thousands of years, thousands of millions of years for this soil to be created. And that's why soil, it also needs to be preserved and conserved. Soil fertility is extremely important for sustenance of life on earth. And what anthropogenic activities are doing? Anthropogenic activities are leading to this. That is what this chapter talks about. It talks about air pollution. Air is extremely important for sustenance of life, but anthropogenic activities like the gases from the industries, I can say point sources and non-point sources, so much of vehicular emission, so much of gas release or the pollutants released from the industrial activities, it is polluting the air. It will impact eventually on all the functions that air or the atmosphere performs. Water is also being continuously polluted. Again, because of point sources and non-point sources, industrial effluents, sewage, plastic waste. We see mountains of plastics in the oceans. So water pollution is also there. Soil pollution is also there. Soil pollution or soil degradation is happening. We have known the concept of desertification. On Mother Earth, on biosphere, continuously desertification is happening, land degradation is happening. We need to take steps to stop it. Why? Because without these natural resources, human life, for that matter, any life, it cannot go on. It is not sustainable. So we need to ensure that we curb this pollution. That is why we came up with the concept of 3 R's: reduce, reuse, and recycle. Another R has also come, refuse also. Right? Refuse, reduce, reuse, and recycle. Alright. Apart from that, we have seen so much of other pollutions as well, light pollution, noise pollution, etc. But natural resources, air, soil, and water pollution has become a huge problem for everybody, not just humans, animals, microorganisms, plants, everybody. It has created problems for everybody. We need to stop this pollution. Apart from this chapter also talks about natural resources and how these natural resources are recycled, or how they are transferred from one spot to another spot. For instance, we spoke about natural resource of water. On Mother Earth, we have water cycle, and of course, I told you 97% of Earth is covered with water. So you think that water is very abundant, so water pollution is very fine. No, we find it in oceans. Yes, water is abundant in oceans, but the potable water, or waters that can be used by humans and animals, the fresh water, is very little. Just about 2.5% of Earth's water is useful for us. And most of that is again stuck in glaciers and ice caps. And because of global warming, now these are melting. Now you must be thinking that, sir, if these are melting, then the water quantity would be increasing. No, that creates some other problem, because biosphere has a very delicate balance of hydrosphere, lithosphere, and atmosphere. And if we are changing, or if anthropogenic activities are changing that delicate balance, it leads to catastrophe. Meaning, we have groundwater usage, we have surface water usage, right? So very little fresh water is available for us, and that is why we need to ensure that water pollution is stopped. The water, we do know, it moves in a cycle. From oceans, there is evaporation. From other sources, there is evaporation. From plants, there is transpiration. So because of transpiration, evaporation, the water rises up along with air. So air and water, they play a very important role. Clouds are formed, condensation happens, and when these clouds they reach saturation, they give rain through precipitation. And once rain occurs, then the excess runoff, see, some amount of water, it goes underground, some amount is runoff into rivers and lakes, and eventually that reaches to your oceans. That is how the water is recycled. Apart from water, there is nitrogen, the nutrient, which is also recycled. That means air, water, and your soil, they help in nutrient recycling. Very important, very important function, nutrient recycling. And nitrogen is a nutrient which is extremely needed. We have plenty of atmospheric nitrogen. I told you we have 78% of atmospheric nitrogen, but not all of this is in soil. I need that in the soil because that nitrogen has to be used by plant. And that's why nitrogen is a limiting nutrient. There is abundant in the atmosphere, but it is limited in soil. And how it enters soil? There is abundant amount of nitrogen, but through lightning and through nitrogen fixing bacteria, it enters the soil. Nitrogenous compounds in the soil, and this nitrogen is taken up by the plants. We consume these plants, right? Plants are autotrophs, they produce their own food, but animals and others, they eat these plants, and eventually they help in fixing this nitrogen in the soil through excretion, through other things, through death, etc. There are some bacteria which can directly fix the atmospheric nitrogen into soil, and reverse is also possible. From nitrogen compounds directly atmospheric nitrogen is also created by some bacteria, and these are basically ammonifying bacteria, nitrifying bacteria, and denitrifying bacteria. As I told you, denitrifying bacteria like Theobacillus denitrificans, Micrococcus denitrificans, they directly turn the nitrogenous compound into atmospheric nitrogen, and others, they fix the atmospheric nitrogen, mostly prokaryotes. Remember, these are bacteria mostly. They fix nitrogen directly from atmosphere into soil. That's how nitrogen cycle runs. Apart from this, we have carbon cycle. Now this is one of the longest cycle. The carbon recycling, it takes years together. Why? As I told you, carbon cycle, the most important constituent of carbon cycle is carbon dioxide. Of course, it is present in very low quantities, 0.04% of carbon dioxide in atmosphere. I'm talking about atmosphere. And contributors to this would be the animals. Microorganisms, animals, what do? We inhale oxygen and we give out carbon dioxide, which enters into the atmosphere. Now, this carbon, which is already present in us, see, carbon in the atmosphere, once it enters into organic compounds, that is plants, these are consumed by animals, and after they enter the ground, you see that they are fixed in the ground for a very long time, and these things, they turn into what? They turn into fossil fuels. So carbon cycle is a lengthy cycle, but because of the anthropogenic activities, we do see the amount of carbon dioxide as a greenhouse gas is continuously increasing more and more, leading to global warming and climate change. Apart from this, oxygen cycle is much simpler, right? Oxygen cycle is much simpler. Why? As I told you, photosynthesis, plants take up carbon dioxide and they release oxygen. Now what do? We take up oxygen through respiration and release carbon dioxide. Alright, so this is the simplest of the oxygen cycle. Many a times oxygen in terms of deposition and in terms of fossil fuels can also be seen, and oxygen cycle, photosynthesis and animal and plant respiration is majorly responsible for the recycling of oxygen. And you do know these nutrients are always fixed in the biosphere. These nutrients are always fixed wherever that may be present in the hydrosphere, they may be present in the lithosphere, in atmosphere. Please remember, when I talk about these nutrient recycling, they will be present in all the three spheres of the biosphere: lithosphere, atmosphere, and the hydrosphere. All right. Right. Now, apart from this, oxygen also helps. A compound of oxygen, that is ozone, O3, it helps us in survival. Now, ozone is a layer which is found near the stratosphere above Earth. In the Earth's atmosphere, in the Earth's upper atmosphere, we find ozone layer. Ozone is O3. Three oxygen atoms combine to form the ozone molecule, and a layer of ozone is found above the Earth's atmosphere. Now, this is responsible for absorbing the harmful ultraviolet radiation which is coming from the sun. Ultraviolet radiation in different wavelength ranges, it may be ultraviolet A, B, or C. All this is absorbed by the ozone layer. Now, if ozone layer was not there, then imagine what could have happened. The ultraviolet radiation would have reached the Earth's atmosphere, or the Earth's surface, I would say, Earth's surface. It would have raised the temperature further. If ultraviolet radiation is directly incident on the skin, it might lead to problems. It might lead to skin irritation. It might lead to cancer eventually. And in many areas, especially towards the poles, towards the Antarctic and the Arctic, we had seen ozone holes a few decades back. Now, this was attributed to the use of different refrigerants like chlorofluorocarbons. Right? Ozone hole was created because of the other characteristics also, mainly because chlorine and other halogens were taken through air into this stratospheric layer, where ozone is continuously depleted because of halogen use, chlorofluorocarbons. Again, why only on poles? There is a different story to it as well. Why only on the poles? Because on the poles the temperature is very lower, and it leads to formation of polar stratospheric clouds and a polar vortex, which will take the chlorofluorocarbons to such great heights. And a single halogen molecule like chlorine, it will degrade, or it will destroy millions of molecules of ozone, which eventually led to weakening of the ozone layer around Arctic and the Antarctic. Eventually, we realized that because of anthropogenic activities like the usage of refrigerants, like the usage of other halogen-based compounds, say we use them in aerosols, we use them in foams, we use them in your dry cleaning equipments, as dry cleaning liquids. So this creates a problem for ozone. So we signed, or we finalized, something called as Montreal Protocol in 1980s, and today the health of ozone layer is slowly and steadily improving. But scientists do say that if we stick to the Montreal Protocol and the targets that are signed by that, the targets that are finalized by that, we are looking at ozone regeneration completely, or ozone layer rejuvenation completely by 2050 to 2060. But things have improved slowly and steadily during these last, I would say, 2 decades. All right. So this was our discussion about the natural resources chapter. I'm quite sure you must have felt that many of these discussions might be redundant because we have discussed them earlier in class 6, class 7, class 8, but nonetheless, it would be like a revision for you. As I told you, today's discussion is about understanding the improvement in food resources. Till now, through our NCERT interaction, we have discussed that every living organism is made up of different cells, and those cells, they need energy. Those cells undergo metabolism. Cells become tissues, tissues become organs, and organ system is something that our body is composed of. And for our metabolism, we need nutrients, we need food, and we are heterotrophs. We rely on others, we rely on other plants, we rely on other animals for our food, right? So if we talk about food resources, food production, both plants, animals, they need food production. Plants can produce their own food, but animals rely on others. So if we talk about food resources for us, how much food we have to produce? If you look at India from 1947 till today, till 2023, the population has been continuously rising. The absolute numbers are increasing more and more. Maybe the rate is going down in last 2 or 3 decades, but the absolute number is still very high. According to United Nations, we have reached 140 crore. So a huge number. That means we need to produce more and more food. And we have achieve that? If you look at this particular graph, this is from the Ministry of Agriculture and Family Welfare. There was a point in our history after independence, for almost 2 to 3 decades, we were reliant on others for food. That means we used to import food grains from other countries. Right? We remember the PL 480 program of United States of America. Right? The entire food security was threatened in 1971. But after that, if you look at this particular threshold, after 1980s, 1990s, we have seen more food production. From deficit food production, we have moved towards surplus. Today, we do not rely on any other country for our own food security. How have we achieved this? How did we do it? How did we improve our food resources? That is the agenda of today's discussion. And this discussion is divided into 3 different dimensions, 3 different stages. We'll understand improvement in our food resources first through improvement in crop variety. Next, improvement in our crop production system. Crop production means the crop production parameters. We know for photosynthesis, what do we need? We need carbon dioxide, we need water, we need nutrients. So in all these aspects, we improved our production. We brought new processes, new structures to improve productivity. And finally, we also improved on the crop protection. So we'll talk about crop protection management. So let's begin this interaction of improvement of food resources first through crop variety improvement. Now we have seen that initially we were reliant on other countries. We used to import food, but slowly and steadily we invested in our research and development. We came up with different varieties of food crops, different varieties of seeds. We brought high yielding variety seeds. This was one of the pillars of Green Revolution. We brought improvement in the quality of the food grains by bringing different processes, by improving productivity, by protecting the crop. We also brought biotic and abiotic resistance in our crops. How? See, we all know that in India, even today we are more or less reliant on rain. Today, we are waiting for rain. In fact, in my village, we are waiting for the rains to fall and then Kharif sowing would take place. But we have reduced these dependence on other things. We have brought more and more resistance, both in terms of biotic and abiotic terms. For instance, we have developed different kind of herbicides, insecticides, pesticides. So biotic resistance has been brought. Diseases have been reduced. Plant diseases have been reduced. Abiotic resistance has been brought. We have brought irrigation facilities. We have brought other facilities so that the crops are more resilient. In fact, we have brought biotic, abiotic resistance even through different processes. For instance, through genetic modification. We have also brought changes in the maturity duration. Classic example being the pusa arhar, the pusa dal or the pusa arhar that we have developed. Earlier it used to take 6 months. Now we have reduced the maturity period. So what we can do? We can go for multiple croppings in 1 year itself. Apart from that, we have developed wider adaptability in different food crops. We have also included desirable agronomic characteristics in many of the food crops, or many of the food crops or commercial crops for that matter, right? The classic example being, say, not a food crop per se, but cotton. In cotton, we have brought we have brought some new genes, or we have introduced new genes, Cry1AC gene, so that it becomes resistant to the pink bollworm. Recently, we have brought a GM mustard hybrid, DMH11, giving us more desirable agronomic characteristics. So how have we achieved this? We have used different kind of methodologies. For instance, we know about Green Revolution. Now, during Green Revolution, what we did? We provided the farmers with input for agricultural or credit for agricultural inputs. We also provided them with irrigation facilities, and we provided them high yielding variety seeds. One of the important pillars of Green Revolution was the HYV seeds, the high yielding variety seeds. The high yielding variety seeds were of better quality. That means the germination would take place. The germination rate, the success rate of that particular seed becoming a sapling, then becoming a plant, are higher. The quality of the food that is produced by that particular seed is much better than the seeds that were used before. So we used better option for seeds, and then we turned our food production into surplus, from deficit to surplus. We have also used other methods like hybridization. We have created different hybrids, the DMH11 hybrid. Now, what do we do in hybridization? We select a plant. We emasculate. The flower is emasculated, right? Why? Because I want another pollen to fertilize the core plant or fertilize one plant. So what do? We select a plant, we emasculate it, we bag and tag it, and then we let the pollination happen, and eventually we harvest the seeds, harvest the F1 seeds. Simple. That means we take a parent line A, parent line B. Parent line A is emasculated. That means the pollen grains from this are removed, and we ensure that the pollen grains from another one, they are going to fertilize this, and then we get the F1 hybrid. So we have gone for hybridization. Apart from this, we have also gone for genetically modified crops in recent times. I gave you example of BT cotton. BT cotton is a genetically modified crops which has led to immense cotton production since 2005. In fact, today on millions of hectares of land, we cultivate BT cotton. Recently, the Genetic Engineering Appraisal Committee has also given approval to DMH11, Indian origin, Indian produced DMH11, Dhara mustard hybrid 11. Very soon, probably in another 3 to 4 years, we might look at more and more commercial cultivation of that mustard as well. So how have we improved our food resources? Through research and development, by developing different variety of seeds. Apart from this, we have also improved the crop production processes. Now, you all know, for photosynthesis, what do we need? For photosynthesis, see, we need light. We cannot do anything with light. Can we do something with light? Because we have to produce for the masses. So we cannot play around with the light. We cannot play around even with the atmosphere, the carbon dioxide. But what we can do is we can ensure that we provide proper irrigation wherever we are cropping. We can ensure that the soil has proper nutrients wherever we are sowing the seeds. So we have done all these things. We have ensured that the plant receives appropriate nutrients, macronutrients like nitrogen, phosphorus, potassium, sulfur, micronutrients like boron, copper, iron, chloride, magnesium. Manganese, not magnesium, remember, please remember this particular pointer. Magnesium for plants is a macronutrient because chlorophyll contains magnesium. So magnesium is a macronutrient, manganese is a micronutrient. So we have ensured all these things. What have we done? See, we have applied manures and fertilizers for these crops. Now, manure is something which is created from organic substances. We know that. Manure are organic. Fertilizers are chemical fertilizers which are produced in big chemical factories. There is a Ministry of Chemicals and Fertilizers itself. So fertilizers are produced at a high rate. In fact, India is the second largest user of fertilizers, right? And we use chemical fertilizers, we use manure, organic fertilizers as well. So when we talk about manure, this is more organic, that is chemical free. So manure can be through compost. We can go for composting. We have discussed about composting before. Composting means you take your organic waste material like your livestock excreta, cow dung, etc., vegetable waste, animal refuse, domestic waste refuse, the extra straw that is left out from the previous cultivation season. What do? We simply create a pit. We put all these waste material in the pit and let it decompose. And once it decomposes, it becomes compost. It would be rich in organic matter and nutrients. I apply this on the soil. I can also go for vermicomposting. Now, when I take this organic waste, I put it in a pit and also add worms. I get vermicompost, or I can even get green manure. Now, green manure is received mostly from the plants itself. Green manure from plants. These are some of the methods that I have used. Apart from organic manure application, I have also gone for fertilizer application. In fact, we have used fertilizers quite indiscriminately, especially nitrogen based fertilizers, which is one of the problems that we discuss multiple times. Whenever we talk about fertilizers, we say that in India we use a lot of nitrogen based fertilizers, but nonetheless we have used fertilizers in our soils so that soil fertility is maintained and ultimately plant or the crop production enhances. We have used nutrients like nitrogen, phosphorus, potassium, sulfur, etc. There are different complexes that we have created. For instance, there is a complex of NPK, nitrogen, phosphorus, potassium, different combinations. We also have diammonium phosphate, DAP, other complexes are also found. But many a times, because of this indiscriminate use of fertilizers, we have seen some problem as well, leading to soil degradation, leading to nitrification of soil. But nonetheless, we can say that fertilizers, if applied in proper dose and proper time, at a proper time, then we do get a lot of benefits of it in terms of improved food productivity, improved production. So what have we done for crop production, crop productivity? We have used manure and nutrients. Apart from that, we have also gone for organic farming. These days, the government is promoting this a lot. Now, organic farming and manure, how are they different? You need to understand, organic farming is a method where you use no or zero chemical fertilizers. You do not use any fertilizers, you do not use any pesticides, any insecticides, any herbicides. It is completely organic, no chemicals used. And these days we are promoting this a lot. It does not mean we do not use insecticides or we do not use any kind of herbicides, etc. We use biopesticide, we use bioherbicide, we use organic manure, we use compost, vermicompost. That becomes part of organic farming. Many a times we also use different crop rotation policies. For example, crops which can fix, or crops which have rhizobium in the roots, we use that, or we directly apply biopesticides or biofertilizers, something like this. We use rhizobium, azotobacter, azospirillum, phosphate solubilizing bacteria. So we basically use bioagents. We use bacteria, fungi, etc., so that we enhance the soil fertility and enhance the productivity. So apart from these nutrients, I have also focused on my irrigation. As I told you, I cannot do anything to light, I cannot do anything to carbon dioxide. But what I can do, I can improve soil fertility. What I can do, I can improve my irrigation facilities. Earlier, we simply used to rely on rain. Majority of agriculture in India was rain-fed agriculture. But these days, we see many irrigation facilities also being developed. Irrigation predominantly through wells, big kind of wells, or even bore wells. Irrigation through river lift systems. Now we have seen irrigation through river lift system predominantly in northern areas where water is lifted from a river and we have created different canals. Canal flow system can be seen in many northern Indian states. In UP, in Bihar, in Rajasthan, Gujarat, canal systems have been very prevalent. Apart from that, we have also used tanks, different tanks of small size. These days, in many areas, we are also rejuvenating the small ponds, small lakes. Many such schemes are running in different states. So we have provided irrigation facilities. In fact, today we talk about use of science and technology, use of research and development for enhancing water efficiency. We talk about per drop, more crop. And for that, we are using different irrigation techniques as well. Earlier, of course, we used to use surface irrigation techniques, but these days we use drip irrigation techniques where piping systems, something like this, are laid on the ground and drip by drip, small drop by drop, water is then let onto the ground. It increases the water efficiency of the crop. Apart from that, we have also developed sprinkler system predominantly for vegetables, and some crops which are suited for sprinkler irrigation. So we have provided irrigation facilities as well. Apart from this, we have developed new cropping patterns. We have developed new cropping patterns to enhance productivity from an acre of land. We go for mixed cropping. That means we grow 2 or more crops on a same piece of land, that too simultaneously. For instance, right now it is the Kharif time. Say, imagine in this Kharif time, if I go for mixed cropping, that means on 1 acre of land, I go for multiple crops together. Now, when I use them in a particular method, or when I use them in terms of say relays, one row after another row or one column after another column, I call it intercropping. In fact, this time at my village we are going for intercropping itself. Intercropping means on a same piece of land I use two different crops. Two or more different crops can also be used. Now this time it depends on selection. This time we are using soybean and tur dal, arhar dal basically, right? So we are going for a column or a column or a row of soybean, and then we'll go for a column or a row of tur dal, right? So intercropping. Apart from that, we also go for crop rotation. Now crop rotation is something which is very useful. Now here we do not do it simultaneously. Please remember, it is a system of growing different kind of crops on a piece of land, on a same land, but not simultaneously at different seasons. For example, say right now the Kharif season is going on. Say for this Kharif season, what I do is I go for a short duration crop. For instance, say go for urad dal or moong dal. Urad or moong are short duration crops. For example, tur it goes on for almost 6 months. Soybean, it goes on for 4 to 5 months, 4 months approximately. So short duration crops like urad and moong can be used, and immediately after we harvest that, we go for another crop. Then another short duration crop or some sort of vegetable, etc. Then we start for Rabi. And after Rabi, we go for Zaid cropping as well. The meaning of crop rotation is within a year, I can grow 2 to 3 crops in 1 year itself. Kharif season, Rabi season, and then we grow in Zaid season also. Alright, so crop rotation. Now crop rotation in a long term can also be worked out. For example, if I plant sugarcane on one particular land, sugarcane, it is a multi-year crop. Say for 1 year, 2 years, 3 years, I'll continuously run sugarcane. After that, I rotate the crop because I want the soil to become fertile again. So I can go for some sort of a leguminous crop which can help in nitrogen fixation in the soil. So crop rotation is rotating the crop properly so that in a year I can go for 2 or 3 crops which can give you good harvest. One, and in long term also, there is always benefit in rotating the crop to ensure that soil remains fertile. Apart from this, we have also gone for crop protection. This is the third aspect. First aspect is the crop variety. Second aspect is the crop production techniques, and then crop protection techniques. Now we all know a crop needs protection from weeds. A crop needs protection from the pathogens. Pathogens, say bacteria, fungi, etc. It also needs protection from different insects. So we have to protect them. First thing, for weeds, there are so many weeds. For example, as I told you, we are cropping right now, say soybean. So along with soybean, when I give the fertilizer, when I give the manure, when I apply manure fertilizer, when I apply water, the same fertilizer is also being used by this weeds like xanthium, we call it gokru. Weed like parthenium. Parthenium is, in Hindi we call it gazar grass, or colloquially it's also known as the Congress grass, right? So there are many weeds that grow in the field. And what do these weeds do? These weeds compete with my crop. I want my crop so that I produce food grains, because I am talking about food resources. But these weeds, they compete with my crop for water, compete with my crop for sunlight, compete with my crop for the nutrients. I apply the fertilizers for my crops, but these weeds, they take up those nutrients as well. So what do I have to do? I have to remove them. So what do I do? The best method for weed control that we use is the mechanical removal. Mechanical removal means manually you go and remove the weeds. Apart from that, some preventive methods can also be used by using proper seed bed preparation, or we can also go for intercropping and crop rotation. But these days we have also developed specific kind of weedicide and herbicides as well. So these days we have specific herbicides and weedicides which do not act on the crop, but they are harmful for the weeds for sure. Alright, so we have developed these things also. But again, there is a flip side for using weedicide and herbicide, because they contain a lot of chemicals which ultimately enter the food chain. That's why we are promoting more and more of organic farming. But nonetheless, we protect our crop from the weeds. Apart from that, insect and pests. We need to protect the crop from insect and pest attack. These insects and pests, what do? They finish off the leaves, they cut the stem, they attack the roots, they suck the cell sap from various parts of the plant, they bore into the stem and the fruits, and that is what we need. We need ultimately the fruits itself. So they bore into the stem and fruit. So what do? We use specific methods. We use disease resistant varieties. For example, the genetically modified crops. We go for growing 2 or more crops simultaneously, where one crop can act as some sort of a biocontrol agent for another crop, and vice versa. Or we can use pesticides and insecticides directly. Apart from that, there is another simple technique of summer plowing also. Summer plowing, that means in summer season, what do? I deep plow the land, I simply leave it. And because of intense sunlight, because of intense heat, the insects, the pests, the microorganisms, they die off. And then I would see less of diseases for the crops. So I have to protect them from the weeds, from insects and pests. For weeds, manual methods, weedicide, herbicides are used. For insect pests, we use different kinds of methods. Along with it, pesticides, insecticides can also be used these days, right? So using these methods, I improve my food resources. Apart from that, I go for something called as mixed farming. Now we need to understand, we want the income of the farmers to improve. By 2022, the government had said that the farmers' income would be doubled, right? That has not happened, but nonetheless, farmers, to increase the farmers' income and to increase the food productivity, food resources, we promote mixed farming. Now, mixed farming means farmer will grow crops, yes. Along with it, farmers will also use some sort of another method where animals are integrated on the crop. It can be milch animals, it can be draught animals, it can be poultry, it can be anything. So mixed farming basically means crops and animals are both grown, both cultivated on the same farm, and they interact with each other. For example, now this particular animal, it is going to provide me milk, it is going to provide me draught power, it is going to provide me the organic material for creating the compost. All right, so all these things will be done. So what are the examples of mixed farming? Now I grow a crop and I go for cattle farming. I grow a crop and I also go for poultry farming. I grow a crop and I also go for some sort of fish production, right? Farmers who crop, and they can go for marine fish catching or marine fish production, or inland fish production as well. Or on my farmland, I can go for apiculture. Apiculture is cultivation of bees. And why are bees useful? Bees are useful for honey. So what do? Say for example, if I am the farmer, I have 2 acres of land. So what do? I on my land piece, on my land, I cultivate. In the Kharif season, I cultivate crop X, and on the Rabi season, I cultivate crop Y. Along with it, I also have a shed in which I do cattle farming. Now, why do I do cattle farming? Cattle farming is done for 2 reasons. First reason is I need milk. Means I have milch cattle. I have different cows, buffaloes, which can give me milk. I can also use them for draught power as well. So what do? On my piece of land, crop is already there. I simply create a shed. I need a shed for cattle farming, and that shed must have land which is sloping. I create some sort of slope towards one side, and on the side of the slope, I provide a pit or a place for creating compost. Why? You already know that the cattle, that means the cows and buffaloes, they are going to excrete, right? They are going to excrete, they are going to urinate. So the excreted material in the urination, or the urinated material, it has to pass through the slope, enter the area of the compost, and I need the area where the cattle is there, which should be dry and which should be clean. Because if it is not dry and clean, if I do not clean the waste material and the urine from there, then the cattle would get different diseases. But I want that cattle to be healthy. So I create a shed with these parameters. Apart from that, I have to provide proper nutritious food to these cattle. Nutrition for daily needs, right? Green leafy grass for daily needs. And whenever they are lactating and whenever they are producing milk, I need to provide them with specific nutrients so that milk production is more and more, because it is going to improve my income. And finally, I need to ensure that there is disease control in my cattle farm. These days, we are looking at many sort of cattle outbreaks, right? Cattle disease outbreaks. We discussed about the lumpy skin disease. I want to protect my cattle from such diseases. So I want to maintain a clean shed. I want to maintain a disease-free shed. So these are some of the things that I proceed with. Apart from that, if I have a piece of land, I can also go for poultry. Now, when I create a poultry farm, what do I get? What are the products that I get out of poultry? I get chicken. That means I get meat. I also get eggs. And what do I need? I simply need a poultry farm, a poultry shed. And in this poultry shed, I need continuous cleaning, I need continuous sanitation and disinfectant facilities. Because we know about the avian diseases. You can talk about H1N1, H3N1, different kind of variants have been developing. So I want my poultry farm where cleaning, sanitation and disinfection facilities are available, because without these, if one chicken gets a disease, it can spread very, very quickly, because within a small area, I'll be having thousands of these chicken for meat and egg laying. Apart from that, I need proper food, because I need vitamin rich, protein rich food for these chicken. Vitamin rich supplementary feed is needed because I need them to grow. I need them to have food so that they efficiently produce proteins, they efficiently produce meat and they lay proper eggs. Again, the food specifically for meat poultry and egg poultry are a little different, but nonetheless, they are mostly vitamin rich supplementary foods. Apart from that, I also need to control diseases here. If disease outbreak is seen in a poultry farm, it is going to be catastrophic. Not just for the poultry farm, for the farmer, but in general, that disease may spread through to other avian species as well. Apart from cattle farming and poultry, I can go for fishing. Now, fish is a very cheap source of animal protein. So if I'm a farmer, what I can do, I can go for marine fishing. That means I can bring marine fish species here, or I can directly go and fish if I am especially in the coastal region. If not, then I can create a small inland pond or a small pond where I can go for inland fishing, freshwater fishing. So a farmer can go for both marine fishing or the inland fishing, freshwater fishing. And a lot of subsidies also given from the government side, right? What do I need? I need a water source for the fish. The water can be seawater also or fresh water. Generally, in our side, in our village, etc., many people have gone for freshwater fishing. Freshwater fishing. That means in my piece of land, in a small area, I create a pond, and that pond is used to create an ecosystem for the fishes. And the government's different departments, the fishing departments, they are going to provide you with the fish eggs, right? You take the fish egg and you cultivate the fishes in your pond. Apart from that, farmers can also go for honey production. Now, honey production is called apiculture. Now, you get two products from this. One, if you go for apiculture, that means culturing the bees, it needs very small area. Along with my crop, I can go for apiculture, which needs basically a very small area, bee cultivation, and then I can get two products. One, I can get honey. It's very, very important, right? And I can get wax. Two products can be developed, and from these two products, I can enhance my income. I can improve the food productivity, food resources. You can see here, I increase the production of honey. In the fishing, I increase the production of animal rich protein source. In the poultry, again, chicken and egg, and with the cattle, I increase again food resources. That means milk and other food resources. All right. So I hope you've gotten a good idea about how far we have reached from 1947. We became independent in 1947, and at one point of time, we were relying on others for our food security. We were importing food grains. We were importing food stuff. We do it today also. It's not like we don't import food grains today. We do it today also. But in India, the food production, that means the demand for food and the production of food, we have gone into the surplus region. How? By improving the food services, by improving the crop variety, by improving the crop production styles, and by protecting our crops. Along with it, by going for mixed farming, where I have supplemented the farmers with the other measures that we discussed. All right. So that's the completion of this chapter, and that's the completion of 9th standard discussion as well. In our next interaction, we will discuss the NCERT class 10 science. All right. Thank you very much for watching this video, and if you have liked this video, if you have any doubts, any queries, if you want to follow me, you can follow me on the ID @RahulSai222. If you have any queries, etc., do reach out to me on IG. I do respond on Saturdays and Sundays. Thank you again. Jai Hind.